Hey everyone, my name is Zandile and welcome to Calculus. Please don't skip this intro as it is very important. This video covers everything that you need to know to get a minimum of 60% and above in this section of the paper. It is very important that you watch the video in order. Why? Because as we move along, we're going to come across some concepts that I've already explained earlier in the section. So I won't be going deep into them again. They've already been broken down properly before. So there is no need to repeat as already I've explained it in a deeper sense. Now, if you're currently sitting below 50%, I highly recommend that you start with solve for X, not because I want to discourage you, but because this section is foundational. And if you understand solve for X, trust me, everything is going to be easier. And again, in this video, if we come across anything that is related to solve for X, I'm not going to go deep into it as I'm going to assume the fact that you already know the knowledge. Hope that makes sense why it's very important to basically start with solve for X. And again, solve for X is a foundation of every topic because you're going to come across it in every topic that we're going to do from now on, right? The video breakdown. The video is divided into 3 sections. Section 1, differentiation, basics. Section 2, cubic functions. Then section 3, applications of calculus, also known as optimization questions. This video is pretty long, so to help you out, I've added timestamps in the description. You can use them to jump to specific parts if needed. Again, right? Just very important. Only use it to jump into sections if you already know the fact that the previous sections you already understand. If you don't understand, make sure the fact that you go in order. As I said, the fact that everything is a build up. Hope that makes sense, right? So with that said, we can start with the video.
Welcome to the first lesson for calculus. So now we're going to do first principle, right? Which the only thing that you need to just know is this formula, which is f prime is equals to the limit when h approaches 0 from fx plus h minus f of x divided by h. So this is the only important thing that you need to just understand, right? So now we're going to just do the first example, right, on how to find the first principle. So all the questions that we're doing here is under first principle, right? So remember the fact that the formula says what? We're looking for f prime, right? And we're looking for it using the first, what? Using the first principle, meaning we're using this formula. So it's going to be f prime is equals to the limit, right? And if h approaches 0, then you're going to say f of h plus h, x plus h, minus f of x, right? Then you're going to say this is divided by what? This is going to be divided by h. So after doing that, we're basically looking for the first principle. So how you would do it, which is this way, is the most easiest way, is that you're going to look for h plus h separately, h of x separately. Then we're going to look at the numerator separately. Then we're going to simplify it. Then we're going to put it back in the formula after simplifying it, right? So the first thing that you're going to do is the following. So you're going to say f of x. So we know the fact that we have f of x in the formula, which we already know as being what? As being 2x minus 3, because it was already given in this formula, right? Then you're going to look for f, which is x plus h, and that's going to be equals to what? Wherever now we see x, we're going to put x plus h. So that's what we're going to do. So you're going to say 2 open bracket, then you're going to say x plus h, then you're going to say what? Minus 3. Then you're going to distribute the 2. So you're going to have 2x, then you're going to have plus 2h, then this is going to be minus 3, right? So we are done looking for this and this. So now we're going to look for the entire of the numerator, which is what? Which is f, then it's going to be x plus h, right? Then it's going to be minus f of x is equals to what? So we know the fact that x plus h is equals to what? Is 2x, right? Plus 2h, then it's going to be minus 3, right? then you need to subtract it by f of x, which is in our case is 2x minus 3. Put in the bracket because of this negative is going to affect the whole of f of x. Then now we're going to distribute the negative. Then it's going to be what? It's going to be 2x. Then it's going to be plus 2h minus 3. Then it's going to be minus 2x. Then it's going to be plus 3, right? Then what you're going to see, we're going to see the fact that this 2x is going to cancel out and this 3 is going to cancel out. To know the fact that you're doing the right thing, right? Always when you get to this step, right, the original function is going to cancel out, as you would see here, right? Always the original function is going to cancel out. It only differs at one equation, which is you will see. But if it's like a quadratic or a cubic and it's just linear, it's not divided by anything, just remember the fact that the minute you see when you get to this step and the original function cancel out, just know the fact that you're on the right track, right? So after them cancelling out, you're going to have the following. You're going to have 2h, right? Then when you get here, right, the thing that you would do is that you need to take out h as a common factor. So take it out, only h alone. And the reason why is that we want to get rid of this h, right? So this is going to be the same as what? As h, then this is going to be 2. Then you are sorted. So now you have simplified the numerator. After this, you're going to just rewrite this, but now you're going to put f of h plus h. You're going to substitute the numerator as being this. So that's what we're going to do. So you're going to say the limit when h approaches 0, right? Then you're going to have what? You're going to have h. Then you're going to have 2. Then this is going to be divided by h. Then the h's are going to cancel out. So you're going to be left with the limit when h approaches 0, which is 2. Then now we're going to substitute h, right? Since we have nothing to substitute, then we can drop this limit. So your answer is going to be 2. So this limit, right? Finding the first derivative. So this is finding the first derivative using first principle, which is this formula, right? Then your answer for this question is going to be 2. I hope that makes sense. So now let's do another example, right? It says we're still finding the first derivative, right? Which is the first derivative is this, right? But we're using first principle, so meaning we're using the one with the limit, the one with the formula. So it's going to be the limit when h approaches 0. Then you're going to say f, then it's going to be x plus h. Then this is going to be minus f of x, right? So this is going to be divided by h. The best way to do this type of questions, right, is only to split them. So look for this and the entire numerator, do it separately on the side. Then after simplifying it, come back and write it in the formula. Then that is like the most easiest way to master these questions. So that's what we're going to do even with this one, right? So it says what? It says f of x is equals to what? To 4x cubed, right? So we know the fact that we're going to find f of x. I'm going to start there. It's going to be equals to what? To 4x cubed. So you sorted with this one, right? You sorted. So now we're going to look for f of what? Of x plus h. Then you're going to say what? You're going to say 4, open bracket. Wherever you see x now, you're going to substitute by what? By x plus h, right? And that's going to be cubed, right? So now we're going to expand this. So when we expand this, right, so I'm going to just create 2 brackets, so 3 brackets in total. So it's going to be x plus h, then another x plus h, right? So this is going to be equals to what? This is going to be x plus h. Then this one is going to be what? It's going to be x squared, right? Plus 2xh, then it's going to be h squared, right? Then now we're going to, expand this now with the first bracket in front. So it's going to be 4, then it's going to be what? It's going to be x cubed. So it's going to be 3 multiplied by x squared. Then it's going to be x multiplied by 2x squared. So it's going to be 2x squared h. Then it's going to be the last one, which is going to be plus x h squared, right? So now I'm going to distribute the h. So it's going to be what? It's going to be plus x squared h, then you're going to have plus 2x h squared. Then the last one is going to be h cubed. Right, let's simplify that. So you're going to have the following. So you're going to have x cubed. Let me just erase that. I think I wrote it 3 by mistake. So you're going to have x cubed, right? Then here you're going to have the following. So you see the fact that this one and this one are the same. So this is going to be plus 3x squared h. Then you see that this one and this one are the same. So you're going to have plus x h squared, right? So no. It's going to be plus 3x h squared, right? Then it's going to be what? It's going to be, so this one's we sorted and this one's are sorted. So you're going to be plus the last one, which is going to be h cubed, right? So now we're going to distribute the 4. So it's going to be 4x cubed plus 12x squared h. Then it's going to be plus 12x h squared, right? Then it's going to be plus h cubed. So you have sorted with x plus h, right? Then what you're going to do is we're going to look for the entire numerator, which is going to be f of x plus h minus f of x is equals to what? Is equals to, so the h plus x plus h is going to be 4x cubed plus 12x squared h plus 12x h squared. That's going to be plus h cubed, right? That is going to be minus by what? Minus by open bracket 4 f of x. Remember, it's going to be f of x plus h minus f of x. So f of x, remember, is 4x cubed. As I said when I did the previous one, to know the fact that you're doing the right thing is that your original function, right? Your original function, which is in our case is f of x, needs to cancel out. As you see the fact that 4x cubed, they're going to cancel each other here. So you know the fact that you're going in the right direction. So what you're going to be left with is going to be 12x squared h, right? So it's going to be plus 12, right? X h squared, and it's going to be plus x cubed, right? So now what you're going to do is that you're going to take out h, only h outside, right? So when we do that, we're going to take out h. So we're going to have h open bracket here. We're going to be left with x, 12x squared only. Then here is going to be plus 12x h. Then the last one is going to be h squared. That's what you're going to do. Then when you're done, you're going to take this simplified version and substitute it here in the numerator. So this is going to be the limit when h approaches 0, right, of h open bracket is going to be 12x squared, right, plus what? Plus 12x h, then it's going to be plus h squared. And the reason why we took out h is because of we want to get rid of this one. That's why we did that. So this is going to be divided by h. We see the fact that the h's are going to cancel out. So you're going to be left with the limit when h approaches 0, right, of 12x squared plus 12x h, and this is going to be plus h squared, right? So when you get here, when now there is no denominator, which is your h is get, which call this, you sorted it out, you can substitute what? You can substitute your h. And the reason why we want to get rid of the h is because of if we had to substitute at this point, right, without getting rid of the h, is that our answer is going to be undefined because of when we substitute 0 here in the denominator, what happens is becomes the answer, whole thing becomes undefined because we can never divide by 0. So I hope that makes sense, right? So now we can substitute h, right? Because we got rid of the denominator. So when we substitute this limit, like you call this, you no longer write it. So you're going to say 12x squared plus 12x open bracket 0 plus 0 squared, right? So this one is going to be 0 and this one's going to be 0. So your answer is going to be what? It's going to be 12x squared. So this will be your final answer. So remember the fact that when answering the first principle, always do it on the side before you put it here. Because if you're going to do this whole mess in the numerator, you end up being confused and losing some track, right? And end up like just doing like slight small mistakes. But if you do it outside, you always get your 6 marks or 5 marks in the test. You would never go wrong by doing it the way I'm doing it on the side, taking out y-intercept and putting it back. You will never go wrong by doing it that, right? So this is how you would do example number 2. So now let's do an example where they gave us in a form of a fraction, right? If you're doing finding first principle, this is the most hardest. This is the highest that you can get. It can never get harder than this, right? So this is the ultimatum. If you can get this one, then you're like truly sorted, right? So now remember the fact that, let me just take out my pen. Remember the fact that we're looking for the first derivative, which is gf prime, right? Using the first principle, meaning we're using the formula of the limit. So it's going to be the limit when h approaches 0, right? Then it's going to be f of x plus h minus what? Minus f of x divided by h, right? So now we know that f of x is equals to -2. Then it's going to be x. Then we need to look for f of x plus h, right, which is going to be equals to -2 divided by what? Wherever we see x, we substitute by x plus h, so it's going to be x plus h, right? So now looking at this one, what you call is x plus h, there's nothing to simplify, so we're going to go to the third step, which is we're looking for f of x plus h, which is the numerator, right? Minus what? Minus f of x. It's going to be equals to what? It's going to be equals to, then this is going to be -2 divided by x plus h, right? Then this is going to be minus, then open bracket, you're going to have f of x, which is -2xh, right? So as I said, the fact that we were doing example 2 and example 3 is that when you get to the third step, which is this one, right, is that always what happens is that your original function cancels out. And also here, when we did the one with the cubic, right, is that always your original function cancels out. But if you're dealing with the fraction, your original function can't cancel out, right, because of like the denominator situation. So that's what I just wanted to say, the fact that here, don't expect if you're dealing with the fraction for your original function to cancel out, then. So here you're going to be left with 2x, then it's going to be x plus h, then this is going to be plus 2x, right, 2 divided by x. So now what we're going to do is we're going to find the LCD. Always use what I'm doing. How to find the LCD is that I'm just going to highlight the things. You're going to multiply this one, the yellow ones together, right? Then you're going to multiply the green ones together. Then to find the denominator, you're just going to multiply the green and yellow together. So that's what we're going to do. So the yellow ones is going to be -2 multiplied by x, right? Then you're going to say plus. The green ones is going to be 2, open bracket. Then it's going to be x plus h, right? Then the entire denominator is going to be what? It's going to be the green multiplied by yellow. So it's going to be x plus h, right? Then multiplied by x. Always do it like this. Always, right? Always do the LCD. Don't get there when it comes to this question and crack your skull. Be like, oh my God, I don't know how to find the LCD. No. Always do it the way I'm doing it right now. I hope that makes sense. So now, never simplify the denominator. Leave it the way it is. Leave it alone, right? So it's going to be what in the numerator? Let's simplify that. So you're going to say 2x, right? Then it's going to be distribute the 2. Then it's going to be 2x. Then it's going to be plus what? Plus 2h, right? So this and this are going to cancel out. So this whole thing, remember, is divided by what? It's divided by x plus h. Then it's going to be x, right? So now you're going to be left with 2h divided by what? By x plus h. Then it's going to be x. So that's what you're going to be left with, right? So since this one, it's more or less like simplified because of h is alone the way it is, you can take this whole thing, this numerator, right, and substitute it back into this formula. So that's what we're going to do. So you're going to have the limit when h approaches 0, right? Then remember that our numerator is what? It's 2h, right? Divided by what? Divided by, open bracket, x plus h. Then you're going to have what? You're going to have x, right? Then that whole thing, remember, is divided by h. So now we want to get rid of the h. So I'm going to rewrite this whole thing, but instead of having a division as like the way it looks like, I'm just going to put the division on the side, right? So I'm going to say the limit when h approaches 0, you're going to have 2h, right? Divided by what? Divided by x plus h. Then it's going to be x here. Then this is going to be divided by h, right? So what I just wrote here and here is exactly the same thing. Instead of having the division as being like the actual fraction line, I just substituted it to being like this division because it's easier to work with, right? So now I'm going to change my division into a multiplication. So it's going to be the limit when h approaches 0, right, of 2h divided by what? Divided by x plus h. Then it's going to be x, right? Then you're going to say multiply by what? If we're changing a division into a multiplication, right, then since this is h, then the h is going to change to 1 over h. So what happens is that the numerator, since remember that here the denominator is what? Is 1. The numerator becomes the denominator and the denominator becomes the numerator. So this is what's going to happen, which is exactly what I did in this step, right? So what do we see? We see the fact that since everything is multiplying, this h and this h are going to cancel out. And remember that always the goal is to get rid of this h. So since this h is cancelling, then I'm sorted. Then I'm going to rewrite it. It's going to be the limit, right? When h approaches 0, then you're going to have 2 divided by what? By x plus h, right? Then it's going to be x, right? And then now, since we are sorted, now we can substitute 0. And I know the fact that there's an h here, but when you substitute by 0, this whole thing is not going to become what? It's not going to become undefined because of this h is what is added to an x. I hope that makes sense. So let's substitute. Remember that when we substitute, we get rid of the limit, right? So it's going to be 2 divided by what? Divided by x plus 0. Then you're going to say x, right? So that's going to give you what? X plus 0 is just x. So it's going to be the same as x squared because you're going to be left with x multiplied by another x, which is going to be x squared. And this is going to be your, and this is going to be your final answer for this question. So now let's do example number 4, right? It says f of x is equals to what? Is equals to 3 divided by what? By x plus 2. So you're going to do the same thing that we did with example 3, right? So you're going to find, remember the fact that we're finding the first derivative using the first principle. So it's going to be the limit when h approaches 0 of f, then it's going to be x plus h, then it's going to be minus f, then it's going to be what? X, f of x, right? And this is going to be divided by h. So we know the fact that f of x here is going to be equals to 3 divided by x minus 2. Then we're going to look for f of x plus h, which is going to be equals to what? To 3. And wherever I see x, I'm going to put x plus h. So it's going to be x plus h, then it's going to be minus 2. Since we can simplify it, we're going to leave it the way it is. So now we're going to be looking for what? For f of x, right? Plus h minus f of x, right? And that's going to give you what? It's going to be 3 divided by what? By x plus h minus 2. Then this is going to be minus this f of x, which is going to be 3 divided by what? By x minus 2. As I said when we did the previous example, is that we multiply the yellow ones, right? Then we're going to multiply the green ones. Then the denominator is multiplying the yellow, multiply the yellow and the green. So let's do that. So multiplying the green ones is going to be 3 open bracket x minus 2. Then the green ones is going to be minus 3 open bracket. It's going to be x plus h minus 2, right? And divided by green multiplied by yellow. So it's going to be what? Bracket. Never simplify it. So it's going to be x minus 2. Then it's going to be x plus h minus 2. So you sorted, right? So now let's expand the numerator. Never do anything to the denominator. So you're going to do the following. So it's going to be 3x. Then it's going to be minus 6. Then there's going to be minus 3x, right? Then it's going to be minus 3h. Then it's going to be plus 6. So the 3x are going to cancel out and the 6 are going to cancel out. So you're going to be, so this is, remember, it's divided by what? By the denominator. So it's going to be x minus 2. Then it's going to be x plus h minus 2. So you're going to be left with the following. So you're going to be left with negative 3, right? Divided by what? By x minus 2. Then you're going to be x plus h minus 2. So that is going to be your numerator for the original, right? For the function, for the formula. So now we're going to basically substitute this. So we're going to say the limit when h approaches 0, then substitute by the simplified version, which is this. So it's going to be negative 3, right? H, forgot h here. So it's negative 3h. And that whole thing is going to be divided by what? Divided by x minus 2. Then you're going to have x plus h. That's going to be minus 2, right? And this whole thing is divided by what? By h. So we're going to do the same thing that we did with example 3. Take the denominator and use the division side. So you're going to be the limit when h approaches 0. Then you're going to say negative 3h divided by what? Divided by x minus 2. Then you're going to have x plus h minus 2, right? And that is going to be divided by h. As I said, is that this and this are exactly the same thing, right? So now I want to get rid of the division, meaning I'm going to use multiplication. So you're going to say the limit when h approaches 0, then you're going to have negative 3 divided by what? Divided by x minus 2, right? Then it's going to be x plus h minus 2, right? And remember that the goal is always to get rid of this h, which is in our case is this one, right? So you're going to say multiply, that's going to be 1 over h, right? So when we do that, so remember the fact that this is 3h, these h's are going to cancel out. So you're going to be left with the limit when h approaches 0 of negative 3. And that's going to be divided by what? Divided by x minus 2. Then it's going to be x plus h minus 2. So now, since we got rid of this h, we can substitute the h, right? So now when we substitute, remember the fact that you get rid of the limit. So it's going to be negative 3. And that's going to be divided by x minus 2. Then it's going to be x plus 0 minus 2, right? Which is going to be the same as what? As negative 3 divided by what? By x minus 2. Then you're going to have x minus 2. Since the brackets are the same, so your final answer is going to be negative 3 is divided by x minus 2 all squared. And this will be your final answer for this question. And I hope you can see the fact that doing it separately really helps with you getting the answer. Because if you had to do it inside the formula here, right, it will be very tricky and you might do slight mistakes that are going to end up making you not get your full marks, right? So it's very crucial to do it on the side first before you substitute it back. Simplify the numerator, which is this part, right? So that when you put it back, everything becomes easy and you can get your full 5 to 6 marks. So now let's do example 5. If you're given a constant and they say the fact that find the first derivative. So we know that the first derivative, right, is equals to what? Is equals to the limit when h, which was when h goes to 0. Then we know the fact that it's f of x plus h minus f of x, right? And that's going to be divided by what? Divided by h, right? So if you're given a number or constant, this is considered a constant. If you're given a function where it's a number, it's a constant function, right? What you do, remember the fact that you use the same rules, is that you need to find f of x, which is in our cases 1 over 3. Then you're going to say find f of x plus h. So you're going to find f of x plus h, which is going to be equals to what? It's going to be 1 over 3 because we do not have any x to substitute, right? So it's going to be 1 over 3 because there's nothing to substitute inside, right? So it's going to remain like this. Then if you find the numerator part, which is going to be f of x plus h, right, minus f of x, you're going to get what? You're going to get 1 over 3 minus 1 over 3, which is going to just give you 0, right? So you're going to have 0. So when you substitute the numerator here, because there's nothing to simplify, right, is that you're going to have the limit when h goes to 0, then you're going to have 0 divided by h. Anything, if the numerator is 0, right, then the entire thing is going to be 0. So that means the fact that it's going to be the same as the limit of h goes to 0, which when you substitute h, since there's no h to substitute, your final answer would be what? Would be 0. I hope that makes sense, right? So just remember the fact that if you are given a function of a constant, right, which is a number, always the limit is going to be 0, or the first derivative is going to be always 0, right? So that's how you would do this question. So now let's do a question like this. Same thing is that remember the fact that we're looking for the first derivative, but using the first principle, right? So it's going to be the limit when h approaches 0 of f of x, right, plus h, and this is going to be minus f of x, and that whole thing is going to be divided by h, right? So first we need to find f of x. So we already know that f of x is just going to be the original function. So it's going to be x squared plus 3x plus 1, right? Now we need to look for x, f of x plus h. So if I see x, I'm going to substitute by x plus h, right? So it's going to be -2, then it's going to be x plus h, then it's going to be what? All squared, right? Then it's going to be plus 3, then it's going to be x plus h, right? Then we're going to have 1. Simplify this, right? So it's going to be -2. Expand this bracket, so it's going to be x squared plus 2xh, and it's going to be plus h squared, right? And that is going to be plus, distribute the 3, so it's going to be 3x, right? Plus 1, so it's going to be 3x plus 3h, then it's going to be plus 1. Then now let's distribute the -2 to clean it up, so it's going to be -2x squared, right? Plus -2, so it's going to give me, so here it's going to be -2x squared, then it's going to be minus 4xh, then it's going to be -2, right, h squared, right? Then this is going to be plus what? Plus 3x plus 3h, then you're going to have plus 1. So there's no common factor, so you're going to leave it the way it is. So now we're going to move to finding the entire numerator of the equation. So it's going to be f of x plus h minus what? Minus f of x. So let's do that. So we know the fact that x plus h is -2x squared, right? Minus 4xh, that's going to be minus 2h squared, plus 3x plus 3h, then you're going to have plus 1, right? This whole thing minus by what? Minus by -2x squared plus 3x, right? Plus 1, right? So now we're going to have the following. We're going to have -2x squared minus 4xh. Then it's going to be minus 2h squared. Then it's going to be plus 3x. Then it's going to be plus 3h. Then it's going to be what? It's going to be plus 1. Then distribute the negative. So it's going to be minus and a minus is going to give you a positive. So it's going to be 2x squared. Then you're going to have minus 3x. Then you're going to have minus 1, right? And I said the fact that if you're given this function like this without any denominator, right, is that your original function needs to cancel out. If it does not cancel out, you are doing something wrong. You are the issue in this problem, right? So to know the fact that I am doing the right thing, it needs to cancel out. The original really needs to cancel out, right? And that is the case always. It really needs to cancel out. Just remember that, right? If it doesn't cancel out, you're doing something wrong. Go back to the drawing board and see maybe there's a simplification that you did wrong, right? Maybe while expanding, you did a slight problem, like you did a mistake, and that could be affecting your final answer. So we see the fact that, do you see the original, the 2x are going to cancel, see? Because of this is -2x squared, and this is a positive. Then we have 3x, see? it cancels out with this one is positive and this one is negative. Then we have 1 is positive and this is negative. So since you see the fact that the original function cancel out, so you're going to be left with negative 4xh minus 2h squared, right? Then you're going to have plus 3h. So let's check whether we have everything, negative 4, negative 2, plus 3h. So that's sorted, right? So now when you get here, only take out h, right? Take out h because we want to get rid, remember the goal is to get rid of this, right? So we're going to just take out h. So we're going to have h, open bracket, I'm going to have 4x, right? This is going to be minus 2. Then it's going to be h, right? Then the last one is going to be what? It's going to be plus just 3. Then you're going to close your bracket. So that's what you're going to have. So this is the numerator being simplified. So let's substitute it back here. So it's going to be the limit when h approaches 0. Then it's going to be h, open bracket, it's going to be negative 4x, right? Then it's going to be minus 2h. Then it's going to be plus 3, right? And that's going to be divided by what? This is going to be divided by h. So the h's are going to cancel out. So you're going to have the following. You're going to have the limit when h approaches 0, but now you have negative 4x minus 2h, then this is going to be plus 3, right? So what we're going to do is now we're going to, since we got rid of with the h, we're going to substitute u0, which is for h, right? So we're going to substitute h to bring 0 because it goes to 0. So let's do that. So it's going to be negative 4x, then it's going to be minus 2, then it's going to be 0. Then it's going to be plus 3. Remember when we substitute the h, right, is that we get rid of the limit. So now you're going to have the following. So you're going to have negative 4x, right? Then it's going to be plus 3, which is going to be your first derivative using the first principle. So that's going to be your answer. So now let's do a question from past paper, right? It says John decides that g prime, right? G prime of a, so meaning they substituted x, they substituted by having a inside, right? And they said the derivative of a certain function g, right, at x is equals to a, so they replace x by a, which is a is a number, né? And it arrives to this answer. So we see the fact that it arrives to the fact that g prime of a arrives, and that's going to be equals to the limit, right? When h approaches what? When h approaches 0, then we're going to have the square root of 4 plus h. Then this is going to be minus 2 divided by what? Divided by h. It says write down the equation of g and a and the value of a. So we need to find the actual value of a, and we can find it using this, right? So if I had to rewrite this thing and like replace the numbers, right, by y, to replace the numbers by like what you call this by x. So I'm looking for, basically what I'm saying is that I'm looking for g of x, right? We know that the limit, what you call this, the first derivative using the, what you call this, the first principle is that the limit when h goes to 0 is equals to what? It's going to be g of x plus h, right? Minus what? Minus g of x. And that's going to be divided by what? That's going to be divided by h. In our case, right, we need something that's going to be x plus h. Do you see the fact that here I can replace the 4 by x, right? So this function is the same as having the limit when h approaches 0, right, of what? Of the square root. Remember the fact that our equation, right, when we find in the first principle, it's never a number, it's actually x. This is the same as x plus h, right? And this needs to be minus what? This means the fact that it needs to be minus square root of x. And it makes sense because of, remember, that means the fact that to get here is that this happened is that g of x is going to be equals to square root of x. Therefore, it makes that g of x plus h needs to be equals to what? To x plus h, which makes sense why this 4 is actually what? Is actually what you call this x, right? And that's going to be divided by h, right? So now matching up this one and this one, we know the fact that our function, we know therefore, we know the fact that the graph g of x is actually equals to the square root of x, and a is actually equals to y to 4 from here, right? A is equals to 4. And if I had to take this function, right, the one that they gave us, and substitute A. So if I find G prime, you'll see the fact that we're going to arrive here, right, of A, right? It's going to be what? It's going to give me the square root. So sorry, I forgot the limit. I'm going to get the following. It's going to be the limit when H approaches 0, right, of the square root. Then wherever I see X now, I'm going to substitute by A. So going to be A plus H. Then it's going to be minus the square root of A, right? And that's going to be divided by what? Divided by H. But in our case, as I said, the fact that for us to arrive to this situation, A needs to be equals to 4. And again, it matches up to 4 because of this rule. Do you see that? So if I substitute 4, we're going to arrive exactly at what the statement gave us, right? It's going to be the limit when H approaches 0, then it's going to be the square root. If you say 4 plus H, which is exactly this, then if you say the square root of 4, which is going to give you 2, right? So this is going to be exactly it's going to be exactly like this one. So it's going to be when H approaches 0, then it's going to be what? It's going to be 4 plus H, then it's going to be minus 2 divided by H, which matches up exactly with this one. So this will be your 2 final answer. So it's that G of X is equals to root X, right? And A is actually equals to 4. So that's how you would find this question. So now let's move to rules of differentiation, right? So with rules of differentiation, the first thing that you need to understand is the notion, right? Different ways that they can ask the question. So this is the different ways. So I said for f of X, they can ask it in the following ways. They can either ask you to find f prime, right? And f prime, it looks like this. It's just the line, right, which represents f prime. Or they can say find df over dx, right? Meaning differentiating with respect to x, right? Or they can ask it like this or like this. Just know the fact that what they're asking the same thing, right? Then for y, it can be y prime, dy over dx, right? Or dx then y. So here, just know the fact that you're finding the first derivative, right? And one more thing before we move on is that finding the first derivative is equivalent to finding the gradient. So f prime of anything, just know the fact that it's actually the gradient. So first derivative is actually finding the gradient. So just wanted to just put it out there, the fact that when we dealing with when we dealing with a linear function, finding the first derivative, we actually finding the gradient. And one more thing is that if we're dealing with a quadratic and a cubic graph, which you will see when we do later on, we are actually dealing with a turning point. It will make sense when we get there. Just know the fact that our first derivative, we're actually finding the gradient. So with that said, now let's move on to the rules, right? The way I take it is that the most important thing that you need to understand is this one, right? Number 3 and 4 really is just there, right? Just to understand the fact that if you have a constant, then you can take out the constant and differentiate the function, right? And this number 4 is adding 2 functions, the fact that you can differentiate them separately, right? But the 2 things that you need to genuinely know is number 1 and number 2, right? So number 1, it's an exponential. It says the fact that if you have x to the n and if you're looking for the first derivative, right? Because this means the derivative is that you take the n in front, then subtract the power by -1, right? Then number 2 just says the fact that differentiating a constant, right, will always give you a 0. And you saw that by when we did limits, if we're differentiating a number, the answer that we got is it's 0. And another thing is that with limits, remember the fact that we found the first derivative, right? Using the first principle, is that if you in the test, you could check using the rules to check whether your limit is right? Using the first principle. Because of this, the one with the limit, right, using the first principle, and what we're doing now is exactly the same way, but the difference is that with the limit, you're using the first principle approach. When they say use the first principle, then you need to use this. If they don't state whether to use the first principle or not, then that's when you use the rules, right? So next video, we're going to do we're going to be doing examples. So now, example 1, remember the fact that here we're using rules, we're not using the first principle, right? Is that it says to us, y is equals to y to x to the power 5, and we need to find what? I'm going to say find y prime, right? So how do we find y prime? It's going to be the following. Remember that we're going to use what? We're going to use number 1, right? First is that we're going to write 3. Then remember, let me just write the rule here, is that if you have y is equals to what? So if I say y is equals to x in, so I can make sense, x in, then y prime is basically in, then it's going to be x to the power n minus 1. So that we have this as a reference, right? So we see in our equation, our n is equals to 5. So we need to take the 5 in front. So this is going to be the same as multiplying it here, right? Then we're going to have x, right, to the power 5. Then we're going to need to subtract it by 1. So it's going to be minus 1. So your answer here is going to be 15 x to the power y to the power 4. So this will be your, what you call this, your y prime, if you're given this example. Alright? So now, let's say they give you a question like this, and they tell you the fact that find g prime, right? So remember the fact that the rule here, as I said, the most important rule is that if you have y is equals to a to the power x in, right, then y prime is basically equals to what? It's equals to, what you call this is equals to a. So it's going to be equals to, okay, it goes the same as a multiplied by n, then it's going to be x, then n minus 1, right? I should have not put the a, but it really doesn't matter because of a, it's going to act like a number here, right? So here, to find g prime, right, the first thing that we need to do is, and I'm just going to change color for the solution, is that I need to change the square root into an exponential so that I can apply this law. Always remember, change your root into exponential so that the law is easy to apply, right? So let's do that. So first we're going to find g of x. I can't apply this yet because I haven't changed this, right? So it's going to be g of x is equals to what? It's going to be x to the power 1 over 2, right? Then now I can apply the rule. So it's going to be g prime, right, is equals to what? Take the exponential in front. So it's going to be 1 over 2. Then it's going to be x. Then it's going to be 1 over 2 minus 1, right? Simplify it. It's going to be 1 over 2, right? Then it's going to be x. Then it's going to be a half minus 1. So it's going to be a half minus 1, which is going to give you negative a half. So it's going to be negative 1 over 2, right? So now let's put this in a positive exponential. So it's going to be 1 divided by 2. There's going to be x, 1 over 2. I can change this into a root. So this is just equivalent to 1 over 2 root x. And that's how we will do this equation. That's how you would find the derivative of x squared, right? So now let's do example 3. The reason why it's not in terms of x and y is that in the exam, they can ask you in like any variable. Just know the fact that what you're looking for, right? So here they could say to you, find d, or what you call this, dp over dq, right? So meaning here we're differentiating with respect to q, right? So that's what we're doing. Remember the rule is very important, is that if we have y, okay, if you have y is equals to y to x to the power n, right? Then y prime is basically equals to n x n minus 1. So that's the rule, right? So here, right, knowing the rule is the following. Is that since our power is like, which one is our q, right, the one we looking for, so we're looking for this one, right? Is that since the q is not a square root, it's just in the proper state, meaning there's an exponential, then I could just apply the rule. So I'm going to say y dp, right, over d cube, right, is going to be equals to the following. So it's going to be 1 over 4. Take the 2 in front, so it's going to be multiplied by 2. Then it's going to be q. Then it's going to be 2 minus 1, right? Let's simplify it. It's going to be 1 over 4, right? Multiplied by 2, which is going to give you a half. So it's going to be 1 over 2, right? Then q is going to be 2 minus 1, which is going to be just 1. So it's going to be just q. So your final answer, you can say q divided by 2. And that will be your final answer. So number 4, it says f of x is equals to 60, and we need to find f prime, right? Remember from one of our rules, I said the fact that if you're differentiating any number without any variable, meaning variable x, right? So that will be equals to y to 0. So any constant will always be equals to 0. So f prime here will be just equals to 0. So now let's do example 5. Example 5 is like an expression, as you can see. And here we're looking for, let me just say dy over dx, meaning we are differentiating with respect to x, right? And remember again, the most important rule that you just need to know, right, is the following. Is that we know the fact that if y is equals to xn, then we know the fact that y prime is basically equals to nx n minus 1, right? So that's what we're going to do. So here we're going to differentiate each term separately, right? So I'm going to do the 12x cubed separately, then the 7x separately. So that's what we're going to do. So it's going to be y prime, right, is equals to what? It's going to be 12 multiplied by 3. Then it's going to be x to the power 3 minus 1, right? Then here's going to be plus, here's the same as 1, right? So it's going to be 7 multiplied by 1. Then it's going to be x, that is going to be 1 minus 1, right? Let's simplify this. We're going to have 12 multiplied by 3, which is going to give me 36. So I'm going to have 36 here. Then it's going to be x squared, right? Then here I'm going to have what? I'm going to have plus 7. Then 1 minus 1 is going to be 0. So this is going to be x to the power 0. Then from rules of exponential, anything to the power 0 is 1. So your answer is going to be 36x squared plus 7. And this will be your final answer. So now let's do example 6, right? But here you see the fact that they gave us in terms of m and n, right? So they could ask you m prime, right? So meaning we differentiate with respect to n. That's what we're doing, right? So we just pretending that m is y, then n is x. That's what we're doing, right? So here, it's beautiful. Everything is in terms of like a power. There's no square root, so there's nothing to change. And remember our important rule, right? So it's going to be n. Then prime is going to be y prime is equals to nxn, right? So now let's n minus 1, yeah, right? So now let's do the following, right? So let's do this one. So we're looking for n prime, right? That's going to be equals to what? So it's going to be 3 divided by 2. Then you're going to take the 4 and 5. So it's going to be multiplied by 4. Then it's going to be n. Then it's going to be 4 minus 1, right? Since 1 is a constant, that's going to be equals to 0. Remember, differentiating a number at 0. So this is just going to be minus 0. So let's simplify this. It's going to be what? It's going to be 3 divided by 2, right? Multiplied by 4, which you will get what? 6, right? So here's going to be 6. Then it's going to be n to the power 3. And this will be your final answer for this question. So now let's do example 7. So with example 7, the most important thing is that our questions or our terms needs to be in this form, right? Because remember the rule. The rule is what? Is x to the power n, right? Which binding y prime is basically n, right? X n minus 1. So if we given in terms of like this, we need to expand it so that we can apply this rule. So always if you're given like this, expand it so you can apply the rule. So first, let's rewrite f of x expanding x. So it's going to be what? It's going to be x squared, right? Then it's going to be minus 1, right? Because this is a difference of 2 squared. So therefore, f prime, right? In our case, because here we're looking for f prime, right? It's going to be the following. It's going to be 2, right? Then it's going to be x. Then you're going to say what? You took the 2 in front, so it's going to be 2. Then it's going to be x. Then it's going to be 2 minus 1, right? And here it's going to be minus 0 because it's a constant, so it's going to be minus 0. So therefore, f prime is going to be basically equals to what? 2 x, right? Because it's going to be 2 minus 1, which is, if it's 1, we never write it. And this will be your final answer. So this is another question. Again, if you're given like this, remember the fact that you need to expand this, right? Here we're looking for g prime, right? You already know the rule because I've been writing it, but let me just write it again. So it's going to be y is equals to x to the power n. Then this is going to be y prime is equals to y to nx n minus 1, right? So this rule, as I said, the fact that that's the most important rule that you need to understand, right? So if you're given like this, remember the fact that expand first. So we're not going to apply the rule yet. So we're going to say g of x is going to be equals to what? Then it's going to be 4. Expand this. It's going to give us what? It's going to give us x squared, right? Plus 2x plus 1, right? Then it's going to be x minus 3, right? So I want to still clean it out. So it's going to be x squared is equals to, I'm going to take the x minus 3 in front of 4. So it's going to be 4. Then I'm going to say x minus 3. Then I'm going to say x squared, right? Plus 2x plus 1, right? Expand this brackets, right? So it's going to be what? It's going to give me the following. It's going to be 4. Open bracket is going to be x cubed, right? Plus 2x squared, right? That's going to be plus x. Then it's going to be a minus 3, right? X squared. Then you're going to have minus 6x. Then the last one is going to be minus 3, right? So let's clean this up. Let's clean the bracket part. So it's going to be 4. There's going to be x cubed, right? So x squared. And this one are going to basically, they have the common term, right? So it's going to be 2 minus 3, which is going to give me negative 1. So it's going to be minus x squared. So this one is sorted. Then you're going to have this one and this one, which is going to be 1 minus 6, which is going to give you minus 5x. So it's going to be minus 5x. So this one and this one is sorted. Then it's going to be minus 3, right? Then close the bracket, distribute the 4. So you're going to have the following. You're going to have 4x cubed minus 4x squared, right? Minus 20x. Then the last one is minus 12, right? So you're going to have that following. So now everything is in like single, the expression is in individual terms. So meaning I can apply this rule. So we know the fact that this is g of x. So now I can find g prime, right? So finding g prime is going to be what? It's going to be 4 multiplied by 3 for the first term. Then it's going to be x. Then it's going to be 3 minus 1, right? And this is going to be minus 4. Then take the 2 in front. It's going to be multiplied by 2. Then it's going to be x. Then it's going to be what? It's going to be 2 minus 1, right? It's going to be minus. Then you're going to say 20. This is the same to the power 1. So multiplied by 1. Then it's going to be x. That's going to be 1 minus 1. 12 is a constant, it's a number. So you're going to say minus 0, right? Then g prime, let's clean that out. We're going to have the following. Here we're going to have 12x squared. Then here we're going to have negative 8, right? Then it's going to be x. Then here it's going to be minus 12. Then minus 20, sorry. Then this is going to be x to the power 0. Remember, anything to the power 0 is 1. So our final answer is going to be g prime is equals to 12x squared minus 8x, then minus 20. And that will be your final answer for number 8. So now let's do question 9, right? Every time, this is very crucial, if you're given a question like this where the denominator is just a single term, right? The goal is that you need to distribute the single term into the numerical values, right? But in our case here, we see the fact that the numerator is what? It's in like they factorize it, so we need to expand it first. So let's first clean up the numerator, meaning expand it. Then, because of this, it's just a known, it's just a single term, right? We're going to distribute it, right? And change the square root into a power. So let's do that, right? So you're going to start by doing what? Expanding the numerator. So it's going to be f of x is equals to what? To x squared, right? Plus 4x plus 4, right? And that's going to be divided by what? By root x, right? Then we're going to change the denominator. So it's going to be f of x, right? Is equals to, so here you're going to have x squared plus 4x, right? Plus 4. So the denominator, now you can change it into being x to the power 1 over 2, right? So now what you're going to do is you're going to distribute this x into each term. So you're going to have f of x, right, is equals to x to the power 2 divided by x 1 over 2. Then you're going to say plus 4. That's going to be x. Then it's going to be x to the power 1 over 2. Then the last one is going to be 4. Then it's going to be x to the power 1 over 2, right? And then now what we're going to do is we're going to use exponential laws. since the bases are the same, right, we can subtract the powers. So for the first one, we can say f of x is equals to x. Then you're going to say 2 minus 1 over 2, right? Then here, see the bases are the same, so we can subtract the power. So it's going to be plus 4, then it's going to be x. That's going to be 1 minus 1 over 2, right? Then here, what we're going to do is we're going to take it at top so that we can apply this law, this rule. Remember this rule, which is going to be nx n minus 1, right? If you're given that y is equals to x to the power n, right? We're doing this so we can apply this rule. That's why I'm going to take it at top. So it's going to be 4, right? Then it's going to be x to the power negative 1 over 2. And then now we can apply the rule. No, before we apply the rule, let's simplify this. So it's going to be f of x is equals to what? 2 minus a half, right? Which is, we're going to get x to the power. So it's going to be x to the power 3 over 2. So 3 over 2, right? Then we're going to have plus 4x. Then this is going to be a positive a half. And the last one is just going to be 4x to negative 1 over 2. So now we can apply the rule, right? So f prime here is going to be equals to the following. Take the exponential in front. So it's going to be 3 divided by 2. X, that is going to be 3 divided by 2 minus 1, right? Then it's going to be plus 4. Then we take the exponential in front. So it's going to be multiplied by 1 over 2. X to the power 1 over 2 minus 1, right? Then the last one is going to be plus 4 multiplied by the power. So it's going to be negative 1 over 2, right? So it's going to be x to the power what? To the power negative 1 over 2 minus 1. Let's clean this up. So it's going to be equals to the following. So this one's going to be 3 over 2. Then if we say 3 over 2, right, minus 1, you're going to get the following. You're going to get a positive a half. So it's going to be 1 over 2, right? Then here it's going to be 4 multiplied by a half, right, which is going to give you 2. So this is going to be plus 2. Then it's going to be x. Then here is going to be negative 1 over 2, right? Then here you're going to see 4 multiplied by negative a half, which is you're going to get negative 2. So you're going to be negative 2. Then to the power, if you say negative a half minus 1, which is you're going to get negative 3 over 2, right? So now let's clean it up, meaning changing the negative exponential to being positive. So you're going to have 3 over 2, right? So it's going to be x 1 over 2. Then here you can say 2 plus 2 divided by x 1 over 2, right? Then here we can say minus what? Minus 2, then divided by x to the power 3 over 2. And you can just leave your answer here. So now let's do example 10. So I want to just show you a difference between example 9 and 10, right? Remember that example 9, there was only a single term in the denominator, right? That is why I expanded and distributed it, right? So if in the denominator is just a single term, just remember the fact that, make sure the fact that the numerator is individual terms so you can distribute your denominator, right? But here we have a different situation where now our denominator is what? It's an actual expression, right? So what we need to do is that if we have a situation like this, is that you need to factorize the numerator, and like 9 out of 10 out of the time is that it's gonna cancel. If they give you a question like this, right, where the denominator is an expression, and at the top part it's like an actual, which was an expression that they already expanded, make sure to factorize the numerator, because of 9 out of 10, the numerator and denominator are going to cancel, right? So in our case here, right, it's going to be what? It's going to be, first, let's factorize the numerator. So we're not going to apply it f prime, right? We're not going to do that yet. We need to clean this up. So you're going to have f of x is equals 2. So the numerator, right, you're going to have 2 brackets, which is you're going to have x, right, minus 3, right? Then you're going to have x, right? X, then you're going to have what? Minus 2. So if you expand this, right, you're going to get exactly this. This and this are exactly the same thing. So you're going to say divided by what? This is going to be divided by x minus 2. So x minus 2 are going to cancel out, right? So now your f of x, you're left with what? With x minus 3. Then now you can differentiate this, right? Because we got rid of the denominator. So you're going to have f prime of x is equals to what? So this one, it's the same as 1. So it's going to be 1 multiplied by x to the power 1 minus 1. And the 3 is a constant, so this is going to be minus 0. So therefore, f prime of x here is going to be equals to what? It's just going to be equals to 1 multiplied by x to the power 0. X to the power 0 is 1. So f prime here, our final answer is just going to be equals to positive 1. And you're done solving this type of question. And one more thing is that remember the fact that if the denominator is a single term, distribute that term to the numerator, right? Then here, if it's what? If it's an expression where it's like x minus 2 or x minus 3, is that 9 out of 10, the numerator of the equation, right? When you factorize it, one of the terms are going to cancel out. So I hope that makes sense. Now, let's look at number 11, right? Number 11, you see the fact that they're looking for dx, right? And it's like this. So before we just apply and write the final answer, we need to clean this up. Do you see the fact that here is what? It's 1 over 2, right? And it's in the denominator. We don't need anything in the denominator, so I'm going to take it up. So I'm going to say dx, right? Then here we're going to have what? We're going to have x to the power 3 over 2. That's going to be minus 3. Then you're going to say x to the power negative a half, right? Then after this, since everything is in this form, right? So it's going to be x to the power n. So since everything is in this form, then we can apply, which is we know is that y prime is equals to nx, and it's going to be n minus 1. So it's going to be easy to apply this. So let's do that. So since now we are applying the rule, right, I can get rid of the dx, right? So this is going to be equals to what? This is basically equals to x. Like it's going to be 3 over 2, take the power in front, yes, then it's going to be x, then it's going to be 3 divided by 2 minus 1. Then here's going to be minus 3 multiplied by negative a half, right? X, then it's going to be negative 1 over 2 minus 1, right? So let's clean that up. So when we clean that up, we're going to have 3 over 2. So here's going to be 3 over 2. Then it's going to be x, right? So it's going to be 3 over 2, right? Minus 1, which is going to give you a half. So it's going to be 1 over 2, right? Then this is going to be minus what? You're going to say 3 minus 3 multiplied by negative 1 over 2, right? Which is you're going to get what? You're going to get a positive, right? So you're going to get a positive 3 over 2. So you're going to get a positive 3 over 2. Then this is going to be x to the power negative 1 minus a half, right? Which is going to be negative 3 over 2, right? So I want to change this into a positive exponential. So this is going to be 3 over 2, right? Then this is going to be x to the power 1 over 2. Then this is going to be plus 3 divided by 2. Then it's going to be x to the power 3 over 2. And that will be your final answer for this question. So now let's do example 12, right? You're given a question like this. So they want what? They want the differentiation. First, we need to clean up. So here in the first part is that we have a root of 3. We use to change that into an exponential. And here we need to first distribute the 2, then take this denominator into the numerator. So let's clean that up, right? So it's going to be dx, right? Then here we're going to have the following. So first, we're going to change this one into an exponential. So this is minus, then it's going to be x to the power 1 over 3, right? And that's going to be divided by 2, right? So we're going to leave that, that 2 in the denominator because it doesn't need to go to the numerator, right? Then now we're going to distribute the 2. So it's going to be plus 1 squared divided by y divided by 3x all squared, right? So now let's clean this up. It's going to be dx. Then we're going to have the following. So here it's going to be what? It's going to be negative. I'm going to take the half outside because it's going to be easy for us when we apply the rule. So it's going to be x to the power 1 over 3. This and this is exactly, so this and this is exactly the same thing. didn't do anything. I just pulled out the half, right? So here it's going to be what? It's going to be 1, right? So it's going to be plus 1. Then here it's going to be 9x squared, right? So now I'm going to take the 9 to the top, which was the x squared to the top. So we're going to have dx, right? So here's going to be what? It's going to be negative 1 over 2. That's going to be x to the power 3, not squared. So it's going to be x to the power 1 over 3, right? Then it's going to be plus 1 over 9. Then take the x squared to the top. So it's going to be x to the power negative 2, right? So now I can apply what? I can apply the rules of differentiation. So I'm going to rewrite it here, what we have. So it's going to be negative 1 over 2. Then you're going to have x cubed like this. Then it's going to be plus 1 over 9. That's going to be x to the power negative 2. So now we can apply the rule. So when we apply the rule, it's going to be the following. We drop the dx in the square bracket. So it's going to be negative 1 over 2 multiplied by 1 over 3, right? Taking the power to the front. Then it's going to be x. Then it's going to be 1 over 3 minus 1, right? That's going to be plus 1 over 9 multiplied by negative 2, taking the power in front. So it's going to be x, right, to the power negative 2 minus 1. So let's clean that up. So you're going to have 1 over 6 here. So it's going to be 1 over 6, right? So then it's going to be 1 over 3, right? 1 over 3 minus 1, which is you're going to get x to the power negative 2 over 3, right? And then here you're going to have 1 over 9. So you're going to have 1 over 9 multiplied by negative 2, which is you're going to get your answer as negative 2 over 9. Then it's going to be x to the power negative 3. Change everything to positive exponential. So it's going to be 1 divided by 6 to the power y to the power 2 over 3, right? So then this is going to be minus 2 divided by 9x to the power 3. And this will be your final answer for this question. So now let's do example 13. And the reason why we're doing example 13 is because of 7.3.1 and 7.3.2. It gives us like on how to solve it, and what do I mean when I say to respect to x, and what do I mean when I say to respect to y, right? So the first one is 7.3.1, right? It says d1 dy over dx, meaning they say the fact that you need to differentiate with respect to x. So what does that mean is that I'm going to take my a's as being constant here. So a is going to be a constant value, right? It's going to be like a number. So that's what it means, right? So here, my answer for dx and dy is going to be what? It's going to be a multiplied by 2, because 2 is an exponential. Then you're going to say x. Then you're going to say 2 minus 1, right? Then what you're going to say is going to be plus 0, because remember that a for the first one, right, is what? Is a constant. So any constant or number, then the differentiation is 0. So here our answer is going to be what? It's going to be 2ax, because 2 minus 1 is going to be 1, so we can just leave it here, right? Then now we're going to move to 7.3.2, right? It says dy over dA, meaning now we're differentiating in respect to what? Respect to a, right? So what does that mean? It means the fact that now I'm going to pretend, right, that x is a constant. So now in our case, x is going to be a constant because of we differentiating with respect to a, right? So now in this case is that a is going to act like x, right? Meaning x is going to be a constant in this situation. I hope that makes sense. So here, what we need to do is that x squared, right, is a constant. So we're going to take it in front. And here, remember the fact that a is to the power 1. So it's going to be the same as what multiplied by 1, because of it's the power 1. Then it's going to be a, then it's going to be 1 minus 1, right? Then this is going to be plus a is a variable in this case, right? And we're differentiating and we're pretending that in our case here, a is what is like x, it is like x, right? So here's going to be what? It's going to be 1, take the power in front, right? Then that's going to be multiplied by a, then it's going to be 1 minus 1, right? So let's clean that up. It's going to give you x squared. Then this one is going to give you what? It's going to be a to the power 0. Then here it's going to be the same thing. It's going to be 1 multiplied by a to the power 0. So anything to the power 0 is 1. So this is the same as x squared plus 1. So this will be your final answer for this one. I hope that makes sense. So when they say something, when they say to the respect of a, right? So remember the fact that a is going to be the variable, then the rest of them are going to be what? They're going to act like numbers. So in this case, is that x squared acts like a number where a acts like a variable. I hope that makes sense. So now let's do question 14. As I said, the fact that if they give you like an expression, right? 9 out of 10 is that this expression, after maybe like simplifying it, or the actual expression is going to cancel with the numerator after factorizing it, right? So here we see the fact that in the numerator where we factorize it, we have a difference of 2 squared, right? So we see the fact that the first term and the second term, we can get perfect squared, because for x squared, right, the perfect squared is what? It's actually 2x, and 9, the perfect squared is 3. So I can have what? I can find the difference of 2 squares. So if of x here in the numerator, if I, factorize it, it's going to be what? It's going to be 2x minus 3. That's going to be 2x plus 3, right? So don't worry, we're going to do more questions on like factorizing and finding the difference of 2 squared, right? So when we get to solve for x, so this is going to be divided by what? Here, remember the fact that now looking at it is that we need 2x plus 3. So do you see the fact that in the denominator I can take out 2 as a common factor, and I'm going to get exactly 2x plus 3. So if I take out 2 as a common factor, I'm going to have the following. I'm going to have 2x, right? So then it's going to be plus what? It's going to be plus 3, right? So now, do you see the fact that this and this are going to cancel out? So therefore, f of x here is basically equals to 2x, right, minus 3 is divided by what? Divided by 2. So this is a single term, so I can distribute it. So it's going to be f of x is equals to the following. It's going to be 2x divided by 2. Then this is going to be minus 3 divided by 2, right? So now let's clean that up. So f of x is going to be equals to what? To x minus 3 over 2, right? So now we can find this f prime. So f prime here is going to be equals to what? This is going to be to the power 1. So it's going to be 1 multiplied by x. Then it's 1 minus 1. Then this one is a constant, so it's going to be minus 0. So therefore, your final answer is going to be a positive 1. So that's going to be how you would find the first derivative here. So now let's look at example 15, right? It is given that y is equals to 4 open bracket cube root of x squared. And they tell you that x is equals to w to the power negative 3. Then they want you to find what dy with respect to w, right? So first, we're going to clean up this one, right? Make it in terms of exponential. And then, because of we need to differentiate with respect to w, we're going to substitute. Wherever we see x, we're going to substitute by this w to the power negative 3. Then we can differentiate. So let's do that. So first, we need to clean up this y, right? So it's going to be y. Then change this one into being into being an exponential. So this is going to be 4. Then it's going to be x to the power what? It's going to be x to the power 2 divided by 3, right? So we sorted with that one. So now remember the fact that we're differentiating with respect to w. So what I'm going to do is I'm going to substitute wherever I see x, I'm going to substitute by w to the power negative 3. So let's do that. So it's going to be y is equals to 4. Then you're going to say y w to the power negative 3. Then this is going to be 2 over 3. Right? So it's going to be 2 over 3. So this is going to be 2 over 3, right? So we're going to multiply the exponential. So let's clean that up. So it's going to be 4. Then it's going to be w. Then it's going to be negative 3 multiplied by 2 over 3. So let's clean that up. If you say negative 3 multiplied by 2 over 3, that's going to give you negative 2. So y is basically equals to 4w to the power negative 2. So now we're looking for dy over dw, right? So our function is in terms of w. So let's do that. So it's going to give us what? It's going to be 4 multiplied by, take the exponential in front. So it's going to be -2. That's going to be w to the power -2 minus 1. So our answer here is going to be -8 w to the power -3. Change this exponential to a positive. So it's going to be -8 divided by w cubed. Right? So this will be your final answer for this question. So now let's do example 16. So it says if y is equals to, open bracket, 6 to the power 6, right, minus 1, then close bracket all squared, prove that dy over dx is equals to 12x to the power of 5, right, square root y, if they tell us that x needs to be greater than 1, right? So here in this question is that we need the following, right? Is that we need to find dy over dx, right? So we're going to do that. And we need to find the square root of y, right? So to get this, right, let's start with the square root of y. We know the fact that we have y, right, is equals to what? Is equals to, open bracket, 6 to the power, x to the power 6, minus 1. Then this is going to be all squared. To get the square root of y, meaning we need to square both sides, right? So it's going to be root y, right, is equals to what? To root, open bracket, it's going to be y, it's going to be x squared minus 1, then it's going to be all squared. We knew the squared and the square root are going to cancel out, so you're going to have that root y. That root y is going to be equals to 6x, right, minus 1, right? So that's what we're going to have. So now we know that root y is equals to this, right? So now we are done with this one. So now we need to sort out the dy over dx, right? So dy over dx is finding the first derivative of this, right? So we know the fact that we have y here is equals to what? To open bracket 6, what you call this, x to the power 6 minus 1, then it's going to be all squared. Let's expand this. So it's going to be y is equals to what? To, let's open 2 brackets like this. So let's open 2 brackets so we can expand it, right? So it's going to be x to the power 6 multiplied by x to the power 6, which is going to give us the following. It's going to be x to the power 12, right? Then it's going to be x to the power 6 multiplied by -1. So it's going to be minus x to the power 6. Then it's going to be x to the power 6. It's going to be this -1 multiplied by x to the power 6. So it's going to be minus what? Minus x to the power 6, right? Then it's going to be -1 multiplied by -1, which is going to be plus 1, right? So therefore, y is going to be equals to y to x to the power 12. Then it's going to be minus what? Minus 2x, right? So it's going to be minus 2x to the power 6. Then it's going to be plus 1, right? So here we need to find dy over dx. So to find dy over dx is going to be dy over dx. It's going to be the following. It's going to be 12, we take it in front, so it's going to be 12. Then it's going to be x, it's going to be 12 minus 1, right? It's going to be minus 2 multiplied by what? Multiplied by 6, right? Taking this exponential here. Then it's going to be x to the power 6 minus 5, right? Then the last one is going to be 0, so I'm not going to write it, right? So it's going to be dy over dx, right? It's going to be equals to what? It's going to be equals to 12x to the power 11, right? Then here we're going to have what? We're going to have minus 12, right? To the power what? To the power, this is, sorry, made a mistake here. Let me just fix it now. It's -1, not -5. Made a mistake, so it's -1, right? So this is going to be to the power 5, right? So that's what we would have, right? So after that, right, we see something is that we have already dy over dx, right? And we have our 12. Do you see the fact that we have this portion here? Let me take a highlighter. We have this, which is this one, right? And we have this portion here, right? It's this one, right? Even though that is negative. And we also know the fact that root y is equals to this one. So from here, I need to find x minus 1, so I can substitute it by root y to get whatever that they want here. So that's what we're going to do, right? If here I take out a common factor of what? Of 12x to the power 5. So let's do that. So it's going to be dy over dx, right? Is equals to, take out a common factor of 12 to the power x. So it's going to be 12 to the power 5, right? So it's going to be 12 multiplied by 5 to the power. It's going to be 12 multiplied by x to the power 5. That's what I mean, right? if I take out that as a common factor here, right, I'm going to be left with what? With x to the power 6. Because if I say 11 minus 5, it's going to give me 6, right? So this is going to be x to the power 6. Then here, since I'm taking out 12 multiplied by x to the power 5, I'm just going to be left with 1. So do you see the fact that this and this now are the same thing? So I can replace x to the power 6 minus 1 by root y, right? So now I can conclude that dy over dx, right, is basically equals to what? Is equals to 12x to the power 5 root y, which is exactly what they want here, right? So that's how you would get this answer. So now let's do question 17. Is that we need to find the first derivative, but using the rules, right? So let me take my pen. Is that if you have it like this, remember the fact that if it's a bracket and it's squared, we need to expand it. So we need to expand f of x. So you're going to say f of x is equals to, I'm going to do 2 brackets. So it's going to be x minus 3 over x. Then it's going to be x. Then it's going to be minus 3 over x, right? Then we're just going to expand this. So this is going to be equals to y. So this is f of x is going to be equals to x squared, right? Then it's going to be minus what? It's going to be 3 over x, right? Multiplied by x. Then here it's going to be negative 3 over x multiplied by x. Then it's negative 3 over x multiplied by negative 3 over x. So it's going to be plus what? Plus 9 over x squared, right? Then now we need to simplify it. So it's going to be f of x is equals to, this is just going to be x squared. We're going to leave it the way. This x and this x are going to cancel out because the other one is in the denominator and the other one is in the numerator. So here we're going to be left at what? With negative 6. Then it's going to be plus 9 divided by what? By x squared, right? Then you're going to have f of x. Now taking this exponential to the top, so it's going to be x squared, right? Minus 6 plus 9x squared to the power negative 2, right? Because you're taking it to the top. So now we can differentiate. So it's going to be f prime is equals to what? Is equals to, take the 2 in front. So it's going to be 2x, then it's going to be 2 minus 1, right? The 6 is going to become a 0, so I'm not going to write it. Then you're going to say plus 9 multiplied by negative 2. Then you're going to say x. Then you're going to say negative 2 minus 1, right? So let's simplify this. It's going to be f prime, right, is equals to what? It's going to be equals to 2 to the power y to the power 1. So you're going to leave it without writing the 1. Then here it's going to be what? It's going to be 9. So it's going to be 9, right? So it's going to be 9 multiplied by what? Multiplied by negative 2, which is going to give you negative 18. So it's going to be negative 18, right? Then it's going to be x to the power what? To the power negative 3. Now I want to change this into a positive exponential. So it's going to be f prime is equals to 2x, right? Minus 18 divided by what? By x cubed. And this will be your final answer for this question. So now let's do example 18. If you look at it, it's more or less similar to example 17. It's just that here we're dealing with square root, right? So here again, we need to expand it before we apply the rules, right? So we know the fact that we have y is equals to the open bracket, the square root of 18, right? Minus x squared, then it's going to be to the power 2, right? Then what you're going to do is we're going to just do 2 brackets. So it's going to be y is equals to what? To square root of x minus x squared, right? Then another bracket, square root of x minus x squared, right? Then now what we're going to do is we're going to expand this. So we're going to have what? We're going to have square root of x, right? Multiplied by the square root of x, right? Then you're going to have what you call this minus what? Minus square root of x multiplied by x to the power 2, right? Then here we're going to have again minus x squared, right? Multiplied by the square root of x. Then you're going to have what? You're going to have x squared multiplied negative x squared multiplied by negative x squared, which is going to give you x to the power 4, right? So now let's sort this one out. So I'm going to change them into powers so you can see what's going on. So this is the same as x to the power 1 over 2 multiplied by x to the power 1 over 2, right? And this is minus what? Minus x to the power 1 over 2 multiplied by x all squared. Same thing here is going to be x squared multiplied by x to the power 1 over 2. Then this is going to be multiplied plus x to the power 4, right? Then y is going to be equals to what? A half plus a half gives you y. So this is just going to be x, right? Then a half plus 2 is going to give you what? It's going to give you, so if you say a half plus 2, it's going to give you what? 5 over 3. So this is going to be minus x to the power of 5 over 2, right? Not 5 over 3. I made a mistake there. Then same thing with this one. It's going to be minus x, then 5 over 2, right? Because that's 2 plus a half. Then the last one is just going to be what? It's going to be plus x to the power 4, right? Then y here is going to be equals to x. Then this 2 is the same as 2, right? Then it's going to be x to the power 5 over 2. Then this is going to be plus x to the power 4, right? Then looking at it, we can apply the exponential law, like the n. Looking at it, we can apply the what? We can apply the differentiation rule, right? So it's going to be y prime is going to be equals to, here is the same as to the power 1. So it's 1 in front multiplied by x to the power 1 minus 1, right? Then there's going to be minus 2, take the 5 over 2 in front. So it's going to be multiplied by 5 over 2, right? Then it's going to be x. That's going to be 5 divided by 2 minus 1. Then here it's going to be plus 4, take the 4 in front. Then it's going to be x, then it's going to be 4 minus 1, right? So now let's clean this up, right? So we know the fact that this one is going to give me x to the power 0, which is 1. So this is the same as having just 1, right? This one, when we simplify it, we're going to have what? We're going to punch that into the calculator, say negative 2 multiplied by 5 over 2 is just going to give you negative 5. And this is going to be x. And then let's simplify the power. If you say 5 divided by 2 minus 1, it's going to give you what? It's going to give you 3 over 2, right? Then the last one is just going to be what? It's just going to be plus 4 to the power 3. And you're done with this question. So now let's do this question. Remember the fact that we're looking for what? For y prime, right? Meaning if you have such a question, make sure the fact that you make y the subject of the formula, right? So here we see the fact that the other side has y with an x in it. So the goal is to make y the subject of the formula. So we see the fact that we have yx, right, minus y is equals to what? To 2x squared minus 2x, right? So as I said, make y the subject. So here we see the fact that we have a common y, so we can take it out. So you can say y, open bracket, you can say x minus 1, right? And that's going to be equals to 2x squared minus what? Minus 2x, right? Then divide both sides by what? By x minus 1 so that y can be alone. So this is going to be y is equals to 2x squared minus 2x. Then this is divided by what? This is going to be divided by x minus 1, right? So now remember the fact that now since we have x minus 1 in the denominator, we need to get rid of it. So how can we do that? Is that in the numerator we need to factorize, yeah? We see the fact that we have a common factor which is 2x, right? So let's do that. So let's take out the common factor. So you're going to have 2x. Then we're going to be left with what? We're going to be left with x minus 1. And this is going to be divided by what? By x minus 1. What do we see? We see the fact that x minus 1 in the numerator exists, that x minus 1 in the denominator exists. So we can cancel it out. So we left with y is equals to 2x. So now since we left with y is equals to 2x, we can apply our what? Our differentiation rule. So it's the same as looking for y prime is equals to what? Take here, it's a 1. Take the 1 in front. So it's going to be 2 multiplied by 1. There's going to be x. There's going to be 1 minus 1, right? Which is 1 minus 1 is going to give us 0. And anything to the power 0 is 1. So therefore, y prime is going to be equals to 2. And this will be your final answer here. So now let's talk about example 20, right? It's they say if g is a linear function, so we know the fact that a linear function, it's in this form, y is equals to mx plus c, right? Mx plus c. And they say the fact that with g of 1 is equals to 5. So what does this say? If you rewrite this as a coordinate as y, it means the fact that g of 1 here is x, right? So g of 1 represents x, so this is going to be 1. And this 5 represents the y. So this is a coordinate. G of 1 equals to 5 is the same as writing as 1 is to 5. It's actually a coordinate, right? And they tell us the fact that g prime of 3, right? So they say the fact that finding the first derivative at 3 when x is equals to 3. So this is when x is equals to 3 is equals to 2. This whole thing, right, is the same as m. Finding gradient at the point is you are finding what? You're finding the gradient, right? So the gradient here is actually equals to 2. So this whole thing, if they say g prime of anything, right, it means the fact that we're finding the gradient at that point. So here, meaning the gradient of this graph at the point 3 is actually equals to 2, right? Then they say determine the equation of g, but we know the fact that g is a linear function, right, in a form of y is equals to something. So we know the fact that g is a linear function. We know the fact that the linear function is in the form of y is equals to mx plus c. They gave us m and they gave us a set of coordinates, meaning we can calculate what? C, right? So we know the fact that m is equals to 2 because of we know the fact that g prime of something gives us the gradient. Just remember that g prime of something gives us the linear, what you call this, gives us the gradient, right? So we already know that m is equals to 2. So let's rewrite this equation with having m in it. So it's going to be y is equals to 2x plus c, right? We see now we can solve for what? We can solve for c because of we have a set of coordinate, which is g of 1 is equals to 5, right? So we can substitute, right? So let's call this 1. We can substitute 1 is to 5 into 1, right? Into 1 to solve for c. So let's do that. So substituting it, so it's going to be 5 is equals to 2, open bracket 1, then it's going to be plus c, right? So this is going to be 5 is equals to 2 plus c. Take the 2 to the other side, it's going to be 3 is equals to c. So c is equals to 3. So now we know the fact that g of x is equals to, what is our m? We know that our m is 2, so it's going to be 2x, and we know that our c is 3. So it's going to be plus 3. So this is how you would find the linear function. So now let's do example 21. It says, given that h of x is equals to ax squared, then they tell us the fact that x needs to be a positive number, right? Because of x needs to be greater than 0, meaning it needs to be a positive number, right? Then it says, determine the value of a if it is given that h inverse at 8, meaning h inverse when x is equals to 8, right, is equals to the first derivative of h, right, when x is equals to 4, right? So what does that mean? It means the fact that to find a, we need to equate when the inverse is equals to 8 and when finding the first derivative is equals to 4. So how do we need to solve for a is that we need to equate this equation. So we are given this one, we're not given this 2. So we can find h inverse, right? We can find that, right? How do we find h inverse? So I'm just going to underline it because we're finding that, right? We know the fact that we need to change this and change into the inverse. So we know the fact that y is equals to ax squared, right? Then now interchange them because we're looking for the inverse. It's going to be x is equals to a y squared, right? Then take a to the other side so we can make y the subject. So it's going to be x divided by a is equals to y squared. Divide both sides by what? What you call this? Square root both sides because you want to get rid of the 2. So it's going to be the square root of x divided by a is equals to what? Is equals to y, right? So now we know the fact that this is the inverse. So this is the same as h inverse at x is equals to what? Is equals to the square root of x divided by a, right? But remember the fact that we need h of 8. So this is the same as h of 8. So let me say h inverse at 8. Wherever I see x, I'm going to substitute by 8. So it's going to be the square root, and then it's going to be 8 divided by a, right? Then we sorted with finding this part. So now we need to find the first derivative, right? So for h, so that's what we need to find, right? So from here, we know the fact that h, the first derivative, is going to be equals to what? Here, take the 2 in front, so it's going to be 2a, then it's going to be x, then it's going to be 2 minus 1, right? Then it's going to be h. The first derivative is going to be equals to what? To 2ax to the power 1. So, but remember the fact that we need h inverse, the first derivative, right? That's what I mean when it's equals to 4. So let's substitute 4. So it's the first derivative at 4 is going to be equals to 2a. Then it's going to be what? It's going to be 4, right? So it's going to be 2 multiplied by 4, which is going to be 8. So it's going to be this is equals to 8a, right? So now we have this as an equation and we have this, right? So let's equate them. So we know the fact that H inverse at 8 is equals to this, right? H inverse at 8 and the first derivative at 4, right? So we know the fact that this one is equals to the square root, right, of what? Of 8 divided by 4. And the side we know the fact that is equals to 8a, right? So now what we're going to do is we need to get rid of the square root. So I'm going to square both sides. So it's going to be like this divided by 4. All squared is equals to 8a all squared, right? So here we're going to get rid of it. So you're going to be left with 8 divided by 4 is equals to 8 squared is going to give you 64. So this is going to be 60. This is, I keep on writing 4 for some weird reason. So this is A. Don't know why. Okay, so it's A. Yes. So here's going to be 64a squared, right? So you're going to have 64a squared. So now I'm going to take the a to the other side. So this is going to be the same as a is equals to what? To 64a squared multiplied by a, right? So this is the same to the power 1. So you're going to add the exponential. So this is going to be 8 is equals to 64 a to the power 3, right? So divide by 64 because we want a, we're solving for a, so we want to make a the subject. So it's going to be 8 divided by 64 is going to be equals to a cubed, right? So this is going to be the same as 1 over 8 is equals to a cubed, right? Cube root both sides. So I'm just going to do it this side. So cube root both sides. So it's going to be like this. So it's going to be 1 over 8 is equals to cube root, you remember? So we're going to cube root both sides. So this side is going to give you what? 1 over 2 is equals to a. So therefore your a is basically equals to a half. So that's how you would find it. And this is going to be the last question for this section. So now what we're going to talk about, the equation of the tangent to a curve. So for us to basically understand the relationship between the tangent and the curve, I need to give you a sketch, right? So if you have a curve which looks like this, right? So this is the curve that they're talking about. And a tangent, it's a line that is touching the curve, right? So this is going to be a tangent, right? So this is a tangent. So the tangent is the one that we were looking for the equation, right? So we see the fact that the tangent and the curve intersect at one point because of its touching, right? So if I take this color, it intersects here. And what is this point called? It's called the point of contact. It's going to be the point of contact, right? So it's going to be the point of contact, right? So this is the point where it intersects. So this point of contact is very important. Let's call this point of contact P, right? Meaning it's going to be XP and YP, right? So with this point of contact, there's a relationship that you need to understand with this point of contact and how we find the equation, right? Since, before we continue with that, let's talk about more about what? Let's talk about more the line that is perpendicular to the tangent. So if we draw a line going down like this line is called a normal, right? And the normal is perpendicular to the tangent, right? Since the line of the tangent and the line of the normal are perpendicular, what is the relationship between the tangent and the normal? Is that the gradient of the tangent, right, multiplied by the gradient of the normal is equals to -1. So meaning the fact that if you have the gradient, the tangent gradient, you can find the normal. Or if you have the normal, you can find the tangent because of, you can just take it to the other side and you can either get the tangent and the normal. So this is the relationship of the tangent and the normal. And how do we know this case is because of the tangent and the normal are perpendicular to each other, right? So now let's talk about how to find the equation of the tangent, right? So we know the following. We know the fact that since the tangent is a straight line, then how do we find the equation? It's going to be y is equals to mx plus c, right? So now from this equation, we need what? We need how to find the gradient, then we need to know how to find the c. So how do we find the gradient is by finding the first derivative of the function, which is going to be f of x, right? Then after finding the first derivative, we're going to substitute what? The x coordinate, right? So we're going to substitute the x coordinate of the point of contact, and that's going to give us our gradient, right? And how do we find c? Is that after finding the gradient, right, we're going to substitute what? We're going to substitute the point of contact, right, to basically solve for c. So the point of contact to solve for c, right? So that's how we will solve for what? We'll solve for c. So everything that I'm saying right now is going to make sense when we do an example, which is what we're going to do in the next video. So now let's start with example 1, right? It says find the equation of the tangent to the curve y is equals to what? Y is equals to 3x squared and x is equals to what, right? So now we need to find what? We need to find the equation of the tangent to a curve. So this is the curve, right, that they're talking about. So here the curve looks like this, right? So let me just draw. I'm gonna just draw a random curve. I'm not gonna really draw this hyperbola. So this is the curve, right? And we know the fact that this is going to be y is equals to what? To 3x squared, right? And remember the fact that we're looking for the tangent at the point x is equals to 1. So we know the fact that this is going to be the tangent that we're looking for, right? So this is the tangent. This is the equation that we're looking for. And we're looking at it from when x is equals to 1, right? Remember the fact that for us to find what to find, remember the fact that before we get there, remember the fact that the equation of the tangent, right, is equals to y is equals to mx plus c, right? And remember how do we find our gradient, right, is going to be the first derivative, right, at the point. And at the point, when substituting the x coordinate, which is at 1, right? So it's going to be at 1, and this is going to give us our gradient, right? Then C, remember we're going to need the following. We're going to need what? The complete coordinate of point of contact. Do you see the fact that here they only gave us the x coordinate? So to find the entire point, we need to substitute this x here into y to find our what? Our y coordinate of the point of contact. So let's do that, right? So we know the fact that y is equals to what? It's going to be 3 open bracket 1 all squared. So therefore, y is going to be equals to 3, right? So here, our point of contact is going to be 1 is to 3, right? So that is going to be the point of contact. So now, to solve for c is going to be what? We need to substitute the point 1 is to 3 to solve for c. So let's do that. So now, let's start with the gradient. So with the gradient, we know the fact that since now in our equation that we given is given in terms of y, we're going to find y prime first. So it's going to be y prime is equals to 3, then you take the 2 in front, so it's going to be multiplied by 2, then it's going to be x, then it's going to be 2 minus 1, right? So it's going to be y prime is equals to y to 6, then it's going to be what? It's going to be x, right? But remember the fact that to find the gradient, we need to substitute the x coordinate of the point of contact. So it's going to be y prime, open bracket, it's going to be 1, then it's going to be 6, open bracket 1, right? Therefore, we know the fact that our gradient here is going to be equals to 6. So we know the fact that now our gradient is equals to 6. So now to solve for c, right, first let's substitute this m here. So it's going to be y is equals to y to 6x plus c. So now we need to solve for c. So we're going to say substitute 1 is to 3, right? So let's do that. It's going to be 3 is equals to 6, open bracket is going to be 1 plus c, right? So this is going to give us just 6. So take 6 to the other side. It's going to be 3. Minus 6 is equals to c. So therefore, c is going to be equals to negative 3. So therefore, making our equation to the tangent equals to the following. It's going to be y is equals to what? To 6x minus c. And that's how you would find the equation of a tangent to a curve. So now let's do example 2, right? So I just want to show you that example 1 and example 2 are basically the same thing. Here, the difference is how they ask the end part of the question, right? So in example 1, they just tell you the fact that it's at x is equals to 1, where in example 2, they tell you the entire point, they give you the point of contact, right? So right now, if I had to sketch this situation, right, it's going to be a curve, like example 1, like this, right? Then this curve, we know the fact that it's y is equals to 3x squared, right? Then here, instead of just giving us x, right, it gave us the entire point. So the point here is going to be 1:3, right? So here again, we're still finding what? We're still finding the equation of the tangent to the curve, right? So remember the fact that the relationship, the equation to the tangent is y is equals to mx plus c, right? So remember the fact that to find the gradient is going to be what? The first derivative, right? Substituting what? The x coordinate of the point. So it's going to be 1, right? So we know the fact that here the first derivative is going to be equals to what? Is equals to 6x to the power 1, right? Or, okay, I'm not going to edit it out. Then it's going to be, now we're substituting 1, so it's going to be first derivative at 1 is equals to what? Is equals to 6, open bracket 1. So now making us our gradient is going to be equals to 6, right? Which is exactly the same as this one. Then now, remember to find c, we need the entire point. We need the entire point 1:3, right? Which in our case, they gave us the whole thing. So that's what we're going to do. So it's going to be, we're going to substitute 1:3. But first, we're going to substitute the gradient here into this equation. So let's do that. So it's going to be y is equals to 6x plus c, right? So we're going to be what? It's going to be 3 is equals to 6, open bracket 1 plus c, right? So now we're going to take the 6 to the other side. So therefore, c is going to be equals to -3. So making our equation to the tangent to the curve is going to be y is equals to 6x minus 3. And this is the same thing. Just wanted to show you the fact that when they just gave you the x coordinate, and now when they give you the entire point, that's all what I wanted to show you guys. So now let's do example 3. It says the curve with the equation y is equals to x plus 12 divided by x passes through the point A, and with A they only give us the x coordinate, right? They don't give us the y, and the y is b. Then they tell us determine the equation of the line, right, perpendicular to the tangent to the curve A, right? So what do they want? Let's draw a sketch of the situation that they gave us, right? So this is a curve. And the curve, we know the fact that the equation to the curve is y is equals to x plus 12 divided by x, right? Then we know the fact that there's a tangent line. So the tangent line is this one. So this is the tangent, right? And the tangent has a point here. The point is A. And that point is what? Is to B. So what do they want? They do not want the equation of the tangent. They want the equation of the tangent, the line that is perpendicular to the tangent, right? So this is the line that they want. And I'm just going to do it in a different color. This is the equation of the line that they want, this one, right? So the red one is the equation that they want. Remember when I started with the note, I talked about the relationship between the tangent and the normal, which is the line that is perpendicular, right? So we're going to use that relationship to basically find what this equation. But first, let's complete the point A, right? So to complete the point A, what we're going to do, we're going to substitute point A here into the curve to find B, right? So that's what we're going to do. So I'm going to substitute 2:B into y is equals to x plus 12 divided by x, right? So we are basically solving for what? We're solving for B. So let's substitute that point. So it's going to be B is equals to 2 plus 12 divided by 2, right? Punch that into the calculator, you can get the following. So you're going to get that B is equals to what? B is equals to 8, right? So now we have the complete point here. So here is going to be 8. So let me so this here is going to be 8. So the point B here is going to be what? It's going to be 8. So now we know the fact that we have the complete coordinates. So in this equation of the red one, we know the fact that it's going to be, since it's a straight line, it's going to be y is equals to mx plus c. So now we need to look for m, right? So here, how do we find m? We know the fact that first we need to find the gradient of the tangent, then use the relationship between the tangent and this line that is perpendicular to find the rate gradient, right? So that's what we're going to do. So first we need to find the first derivative, right, of this. But before we do that, let's rewrite this by taking the x on top. So that's what I'm going to do. So I'm going to say y is equals to what? To x plus 12, then it's going to be x. Take the x on top, it's going to be -1, right? So now what we're going to do is we're going to find the first derivative. So it's going to be y prime is equals to x, right? So it's going to be 1 in front. That's going to be 1 minus 1. Then it's going to be plus 12. Take the -1 in front. So it's going to be multiplied by -1. Then it's going to be x. Then it's going to be -1 minus y, right? So let's clean this up. It's going to be y prime is equals to what? To 1. Yeah, because 1 minus 1 is going to give you 0. And anything to the power 0 is 1. Then this one is going to be minus 12. Then it's going to be x to the power -2, right? So now to find the gradient of the tangent, it's going to be y prime, substituting the x coordinate of this point, which is 2. So it's going to be 2, right, is equals to 1 minus, then it's going to be 12. Then it's going to be, then we're going to substitute here 2. So it's going to be 2 to the power -2, right? So when we do that, the gradient of the tangent is basically going to be equals to what? It's going to be equals to, so this is going to be -2. So it's going to be equals to -2. As I said, the fact that since they told us the line, the red line, which is the one that we're looking for the equation, right, is that it's perpendicular to the tangent. I know the fact that the gradient of the tangent multiplied by the gradient of this line, and I'm going to call it normal because that's the normal line, is equals to -1, right? So with that said, we know the fact that the gradient of the tangent is -2. So it's going to be -2 multiplied by the gradient of the normal is equals to -1. Take this to the other side. So therefore, the gradient of the normal is equals to what? To 1 over 2. So now we know that the gradient of the normal is equals to 1 over 2. So now I'm going to rewrite this equation, right, substituting 1 over 2 because of that's what we're looking for. So we know the fact that y is equals to 1 over 2 x plus c, right? So now how do we find c? We're going to substitute this point A to basically solve for c. So we're going to substitute, let me just do it here. We're going to substitute A, right, which is what? Which is 2 is to 8, right? And we're going to substitute it here into y is equals to 1 over 2x plus c, right? And we're solving for c, so let's do that. So it's going to be 8 is equals to 1 over 2, open bracket, is going to be 2, then it's going to be plus c, right? Then this is going to be 1 over 2 multiplied by 2 is going to give you 1. So it's going to be 8 is equals to 1 plus c. Take the 1 to the other side. Therefore, c is going to give you 7, right? So therefore, the equation of the line perpendicular to the tangent at the curve A is going to be equals to the following. It's going to be y is equals to 1 over 2 x. Then it's going to be plus 7. And that's how you would solve this question. So now let's do example 4. It says calculate. Let me just take my highlighter. It says calculate A and B if f of x is equals to x squared, right, plus bx plus 5. So where is A and B is on f of x, right? Then they tell us the fact that it has a tangent at x is equals to -1, right, which it is defined by the equation y is equals to -7x plus 3. So again, we're going to do a diagram so you can see the situation in a visual form, right? So we see the fact that we have a curve. So our curve is like this. But in our case, our curve is f of x, right? So it's going to be f of x, right, is equals to what? Is equals to ax squared plus bx plus 5, right? Then we see the fact that we have a tangent. And this is the tangent, the equation of the tangent. Let me just do that properly because this is not going to touch. So it's going to be the tangent. So it's going to go like this, right? So this is the tangent, and the tangent, the equation they gave us is y is equals to -7x plus 3, right? And it meets at, it touches at this point, but they only gave us the x coordinate, which is x is equals to -1. So we see the fact that this is x is equals to -1. Remember the fact that we need the entire coordinate just, so let's find the entire coordinate. Since we know the fact that at this point here, right, we are putting x, let me just do it in another color. So this point here, right, it's a point of contact when what? It's a point when the tangent and the curve intersect, right? So meaning I can use the equation of the tangent, because that's the one that's complete, right? To do what? To find the complete point. And you're going to see why we need the complete point is that since we have two unknowns, we have A and also B, right? Is that we need two equation to, to find both A and B, because we're going to use simultaneous equation. So one of them is going to be the relationship between the gradient, and one of them is going to be from this point of contact, right? So that's what we're going to do. So first, let's find this entire point. So we're going to substitute it using this equation, y is equals to -x plus c, because it's the one that's complete. So let's do that. So it's going to be, let me just take this color. So it's going to be y is equals to what? Is equals to -7, right? Open bracket, it's -1. Then it's going to be plus 3, right? If you pass that into the calculator, you're going to get y is equals to what? Is equals to 10, right? So this point here is going to be what? It's going to be -1 and it's going to be 10. As I said, the fact that we need two equations to basically solve simultaneous to solve A and B. So now we're going to find the first equation, and the first equation we're going to use it by using this coordinate, and we're going to substitute it here, right, at f of x. So because of f of x is the one that has A and B, so let's do that, right? So it's going to be, I'm going to say substitute -1 and 10 right into f of x. So let's do that. It's going to be, so it's going to be what? It's going to be 10 is equals to what? Is equals to A. Then open bracket is going to be -1 all squared plus B. Then it's going to be -1. Then it's going to be plus 5, right? So now it's going to be 10 is equals to what? Is equals to A. Then here it's going to be -b. Then it's going to be plus 5. Take the 5 to the other side. So you're going to get the following. So it's going to be 10, right? Minus 5, which is going to give you 5. So it's going to be 5 is equals to what? To A minus B. And this we'll call it what? We'll call it equation 1, right? So we are done with the first equation. So now let's do the second equation. So with the second equation, this is the following. We see the fact that, remember how to find the gradient? We can find the gradient by finding the first derivative, right? Substituting the x coordinate of the point of contact. So we know the fact that it's going to be -1, and that's going to be equals to the gradient. But from here, we see the fact that the gradient is equals to what? We know that the gradient is equals to -7. So I'm going to use this relationship and the gradient being -7 to form the second equation. So let's do that. First, let's find the first derivative. So it's going to be f prime, right, of x is equals to, we're going to take the 2 in front. So it's going to be 2a, right? It's going to be x. Then it's going to be 2 minus 1, right? Then we're going to take the 1 in front there. So it's going to be plus b. Then it's going to be x. Then it's going to be 1 minus 1. Then the 5 is going to be 0, right? So the first derivative, right, is going to be equals to what? It's going to be equals to 2ax. Then it's going to be plus b, right? But remember the fact that to find this n, we need to substitute by -1. So it's going to be fn, f prime at -1, right, is equals to what? Is equals to 2a, open bracket, -1 plus b, right? Then now let's clean this up. It's going to be the first derivative at -1 is equals to what? Is equals to -2a, right? That's going to be plus b. But remember, we know the fact that this is equals to what? Is equals to m, and m is equals to -7. So we know the fact that this is going to be the same as -7 is equals to -2a plus b, right? So now I'm going to make b the subject of the formula. So I'm going to take -2a to the other side. So it's going to be 2a minus 7 is equals to b. And then I'm going to call it equation 2, right? So now, knowing the fact that this is equation 2 and this is equation 1, so now I'm going to substitute equation 2 into 1. So this is simultaneous, right? So I'm going to say substitute 2 into 1, right? So let's do that. So when I substitute 2 into 1, it's going to be 5. So wherever I see b now, I'm going to substitute by 2a minus 7. So it's going to be 5 is equals to what? It's equals to a minus, open bracket, 2a minus 7, right? So it's going to be 5 is equals to a minus 2a. Then it's going to be minus and a minus going to be give you a positive. Then it's going to give you that, right? So let's clean this up. I'm just going to take it this side. So when I clean it up, it's going to be 5 minus 7, which is going to give you negative 2. So it's going to be negative 2, right? It's equals to what? Then you're going to say a minus 2a, which is going to give you negative what? Negative a, right? So a negative and negative is going to give you a positive. So a is going to be equals to what? To positive 2, right? So we know the fact that a is equals to positive 2. So now I'm going to substitute this a is equals to 2 into what? Into equation 2. So into equation 2, right? To solve for b. So b is going to be equals to 2. Then it's going to be 2. Then it's going to be minus 7. Therefore, b is going to be equals to 2, open bracket 2. Then you're going to say minus 7 is going to give you 3, negative 3. So it's going to be equals to negative 3. So now we know the fact that a is equals to positive 2 and b is equals to negative 3. So that's how you would solve this question. Okay, now let's do this question, right? So it tells us the fact that, so it tells us the following. It tells us that f of x, which is a cubic function, right? It tells us that there's a point E and point W, which is two variables at f prime, and there is on some horizontal line. So if there is a horizontal line that touches the graph, what does it mean? It means the following. It means the following is that that line is basically only happening where? At this graph's turning point, right? So if we have this graph, because of the cubic as a set face, meaning the curve here, our curve is going to be what? It's going to be a quadratic with the set face, right? So the tangent line only happens here, right? So this is where the tangent line is going to happen. And if it's a horizontal line, meaning that the gradient is equals to 0, right? So the gradient that is equals to 0 is going to be very crucial to us finding the questions here. They tell us that h and g, right, h is a tangent on f prime. So there's a tangent on f prime at point E. So let's say maybe point E is here, right? Then there's a tangent line like this, right? So there's a tangent line. Let me just change color. There's a tangent line like this, right? So there's a tangent line like this. Then there is point W. Let's say W is somewhere here. So W. So there's a tangent line going like this. And they tell us the fact that they intersect here. So they actually intersect at the turning point. So they intersect here at the turning point on the quadratic function, which is f prime. So we know the fact that D is going to be here because they intersect there, right? So the first one, they say the fact that write down the value of A, right? So now we need to understand the relationship of this point here and the horizontal line, right? So with the horizontal line, we know the fact that this point here, if I just had to, let me just do it with another color. If I do it in yellow, right? We see the fact that this tangent line here, right, has a point of contact, and our point of contact is going to be D, right? So if we find the first derivative, since we already know the fact that the gradient is 0, if I find the first derivative and I substitute A, right, and equate the other side with 0, I can basically solve for A. So that's what I'm going to do, right? But here, remember the fact that we're not going to necessarily use the first derivative because the curve is in terms of the first derivative, right? So we need to use what? Meaning finding the gradient in this situation, we need to find the second derivative. The reason why I'm using the second derivative is because our curve is the first derivative, right? And what do we know? We know the fact that to find the gradient, we find the first derivative. But since our curve is already the first, meaning our gradient is going to be what? Meaning our gradient is going to be the second derivative. So this is going to be our gradient, right? So which is gradient is the same as me saying f prime, f double prime is equals to A, right? But because of here is at a point, so it's going to be the second derivative at a, right? At this horizontal line, right? So it's going to be equals to m. So that's how we're going to solve for a. So now taking this, let's find the first derivative. So it's going to be f prime is equals to what? It's going to be negative 3, taking the 3 in front, right? Then it's going to be x squared. Because if it's going to be 3 minus 1, then it's going to be plus 2. Then it's going to be x. Then it's going to be 2 minus 1, which is going to give us 1. Then it's going to be just plus 1, right? So now let's find the second derivative, right? So it's going to be what? It's going to be negative 6x, right? Then it's going to be plus 2, right? So after doing that, we're going to do the following. We're going to substitute a, right? Because that's what we're solving for. So remember the fact that it's gradient at the point, which is at that point is t, and the x coordinate is a. So that's why I'm doing that. So it's going to be negative 6a plus 2. But remember the fact that since this is a horizontal line, meaning our gradient is going to be equals to 0. So f double prime at a is equals to m, right? Which is m is 0. So it's going to be 0 is equals to 6a plus 2. Take the negative 6a plus 2. Take the negative 6a to the other side. So it's going to be a is equals to 2. Divide both sides by 1. Divide both sides by 6. So it's going to be a is equals to 1 over 3. So that's how you would find a, right? So that is this question done. So the second part says determine the value of b, right? For which h and g, right, will no longer be the tangent to what? The tangent to f prime, right? So we need to write when both these two tangent will no longer be what? Will no longer be the tangent, right? So when can that happen? Is that, remember the fact that the two graphs, and I'm just going to do it in a different color. See the two graphs, so it's going to be these two graphs, right? We know that they intersect by the turning point, right? They're going to stop being tangent if this intersection moves inwards, right? So if this intersection, the point D, moves inwards, so meaning it goes like this. Let me just do it in another color. I know this is messy. And now it's maybe the tangent is going to be like this. Meaning the graphs are no longer tangent, but they're intersecting, right? So do you see the fact that they're intersecting the graph at 2 points here and there, right? So that's when it's going to happen. It's when this moves down. But actually, when we're looking at this, remember this is point D. Let me just erase this because let me just write this point D properly, right? So do you see the fact that this point D, the intersection, which is A is to B, right? A represents this and B represents here, right? So B is here. So do you see the fact that for us to stop having a tangent, right, is when everything is less than B. So when our value are less than B, then we're no longer going to have what? We're no longer going to have tangents, right? But everything that's below it, the tangent is going to still keep on happening. So do you see the fact that if any value that is below B, so it's anything that's below B. So, but now we need to solve for B, which is simple because of we already have A, right? So now we're solving for B. Then we're going to say everything that's less than B. So it's going to be what? We're going to substitute, right? We're going to substitute what? We're going to substitute A, which is equals to 1 over 3, into what? Into the first derivative. Not the first derivative. This is what I mean. The first derivative, not the original, because of the curve that we're dealing with, right, is the first derivative. So we're going to substitute it here. So we're going to substitute it here to find B. And a B, right, is the what? Is the y coordinate, right, of the turning point, and A is the x coordinate. So that's what we're going to do. So we're looking for y. So this is the same as saying y is equals to what? Is equals to negative 3, right? It's negative 3. Then you're going to say 1 over 3, right? Then you're going to say all squared plus 2, open bracket, 1 over 3, right? Then you're going to say plus 1. Paste this into the calculator. You're going to get y is equals to the following. Y is going to be equals to 4 over 3. And remember the fact that y is b, so b is going to be equals to 4 over 3, right? So therefore, I said anything that's less than this value. So your answer is gonna be when b is less than 4 over 3. This means that everything that's less than b. So anything that is less than b is gonna cause this this two tangent line to stop being what? To stop being tangent, but they're gonna start intersecting the graphs. I'm just marking intersecting where the dotted lines are intersecting. I hope that made sense. So now we're going to move to example 6, right? It says g of x is given as negative 2x cubed plus 3x squared plus 12x. It says determine the equation of the tangent g at the maximum gradient. So here keyword is maximum gradient. Is that at the maximum gradient? What does maximum gradient mean? It means the following. So if you're finding a tangent at the maximum gradient, meaning you need to find the x, right? You need to find the coordinates actually, right? So the point of context here, right? The point of content is at where the coordinate here is going to be at the point of inflation. So that is going to be our point of contact. So this is it's going to happen at point of inflation, right? So how do you find that? We find it by finding the second derivative, right, and solving for x when it's equals to 0. So that's how we find it. Then this is going to give us our x, right? It's going to give x. Then we're going to substitute this x to the original to find our y. Then we're going to have the complete coordinate. And why do we need this? Remember, we needed to find what? This x we needed to find for m, right, to find the gradient. And the complete coordinate we needed to find what? To find c. So let's do that. So first we need to find the complete coordinate so we can find the gradient, and we can also find what? We can also find the c value. So let's start now, right? So we're going to find the first derivative. So this is not g, this is not f, so it's going to be g prime, right? It's going to be equals to, take the 3 in front, so it's going to be negative 2 multiplied by 3, which is going to give you 6. Then it's going to be x squared. Then take the 2 in front, so it's going to give us what? It's going to be plus 6. Then it's going to be x, and this is going to be plus 12, right? So we sorted. Now we're looking for the second derivative, because if I said the maximum is the point of inflation, right? And we're finding the x value. So let's do that. So it's going to be x. Take the 6 in front, it's going to be negative 12x, right? Then here it's going to be plus 6, right? So equate it to 0 to solve for x. So it's going to be 0 is equals to negative 12x plus 6. Take the 12x to the other side. So it's going to be 12x is equals to 6. Divide both sides by what? Divide both sides by 12. So x is going to be equals to 1 over 2. So this is the x coordinate for the point of contact. And then, so just know that. So now let's look for the y. So it's going to be g of 1 over 2, right? So it's going to be equals to negative 2, open bracket, 1 over 2. Then it's going to be all cubed plus 3. Then it's going to be 1 over 2. Then it's going to be all squared plus 12. Then it's going to be 1 over 2, right? Then substitute this into your calculator. You're going to get it to be what? You're going to get your value as being the following. So let's punch it. It's going to be negative 2, right? Open bracket, 1 over 2, right? Then that's going to give us all cubed, right? Then it's going to be plus, so it's going to be plus 3, open bracket, 1 over 2, right? Then it's going to be all squared. Then it's going to be plus 12. Then it's going to be 1 over 2. Then you're going to get your answer as being 13 over 2. So if I had to sketch the situation, right? Let's sketch it. So let me just sketch it. So this looks like this, even though we haven't done cubic function, but this looks like this. So it's going to be like this. It's negative. I could be wrong. I'm just sketching a rough sketch, right? I could be wrong with the sketch, but the point of inflation is when the graph changes from concave up to concave down, right? So this point here, the maximum gradient is going to happen somewhere here. And I'm saying the fact that if this graph is wrong, I'm not trying to make the graph right? I'm just showing you where would the maximum point happen. So in our case, it's going to be what? It's going to be 1 over 2 and 13 over 2, right? So this is how it would look. I hope that makes sense, right? So this is going to be the way our tangent is happening, and this is going to be our point of contact, right? So now we have that point, right? So we know that that point is going to be what? It's going to be 1 over 2 is to what? Is to 13 over 2, right? So that is sorted. Now we can use this point to find what? We can find it. You can use it to find the gradient. Then we can use the complete point to find C. So first, let's find the gradient. Remember, to find the gradient is the first derivative, right, at the x coordinate of the point of contact. So it's going to be at 1 over 2. And this is going to give us m. So we know the fact that we already calculated the first gradient. I keep on saying if it's g. So it's going to be g, substitute 1 over 2, right? It's going to be equals to what? Remember the fact that we already found that. So it's going to be negative 6, open bracket 1 over 2, all squared plus 6. Then it's going to be 1 over 2, right? So it's going to be plus 12, right? Pass that into the calculator. You're going to find that your gradient is going to be equals to the following. It's going to be equals to g prime at 1 over 2. It's going to be equals to 27 divided by 2. So that is m. M is going to be equals to 27 divided by what? Divided by 2, right? So that is sorted. After that, now what we're going to do is we're going to do the following. We're going to find C, right? So we know the fact that therefore, substituting our m is that y is going to be equals to what? Is going to be equals to 27 divided by 2, right? X plus C. So now we're going to substitute the entire coordinate to find C. So substitute 1 over 2, right, is to 13 divided by 2, right? So let's do that. So if we substitute that, we're going to have the following. So we're going to have that it's going to be 13 divided by 2, right, is equals to what? It's equals to 27 divided by 2. Then this is going to be 1 over 2. It's going to be plus C. This is the same as 13 divided by 2 is equals to 27 divided by 4 plus C. Take the 27 divided by 4 to the other side, right? Subtract it. So C is going to be equals to negative 1 over 4, right? So now we know the fact that C is equals to negative 1 over 4, making our equation, right, of the tangent at the maximum gradient being equals to y is equals to 27 divided by 2, right? X minus 1 over 4. And this will be your final answer. So now let's do example 7, right? It says h of x is equals to negative 2x cubed minus 7x squared plus 9. It says for which value or values of x will the tangent of the curve, right, at h that is equals to the parallel to, that is parallel to the line y is equals to negative 4x is equals to 7, right? So here, what are they talking about? Since they talked about parallel lines, what do we know about the relationship of parallel lines, right? We know the fact that the parallel lines, the gradients are equal. So gradient A is going to be equals to gradient B, right? So since they gave us what? They gave us the gradient of the line that this is parallel to, right? And they want the x, and they want the x coordinates that the tangent to the curve will be parallel to this line, right? So how can we find the x coordinate? Remember the relationship between what? Remember the fact that let's say we have a curve, right? And we have a tangent going like this, right? The relationship between the gradient and this x coordinate is that if you find the first derivative, right, of the curve, you can and equate it, if you find the first derivative of a curve, this gives you the gradient. That's what I wanted to say. Yes. So this is the relationship that we can use to find x, right? But now the nice thing is that we know the fact that they're equals to each other. So in our case, it's going to be the gradient of h, right? It's going to be equals to the gradient of y. And this is y. This is the equation of y. So it's going to be equals to the gradient of y. And the reason why they're equal is because of parallel lines. Parallel lines satisfies this condition. I hope that makes sense, right? So with that said, for gradient of h, I'm going to use this relationship now to find the gradient of h to solve for x. I hope that makes sense. But before I do that, let's rearrange this and find what is the gradient here. So we know the fact that this is y is equals to what? Take the 4 to the other side, so it's going to be 4x plus 7, meaning our gradient is going to be 4. So here, the gradient of y, so we know the fact that the gradient of y is equals to 4, right? So now we have the gradient of y, let's sort out the gradient of h. So we know the fact that the first derivative, right? So we know the fact that h of x, the first prime of it, is going to be equals to, take the 3 in front, so it's going to be negative 6x squared, right? Minus what? Minus 14x. Then this is going to be plus 0 because of 9 is going to be a constant, right? So we're going to substitute this. Remember the fact that this is what is the gradient of h, right? Because of this relationship. I hope that makes sense. So now we can substitute the gradient of h by this equation. So it's going to be negative 6x squared minus 14x, right? Is going to be equals to 4. Because remember, I said the fact that this relationship is this relationship that the gradient of h is equals to the gradient of y because of the tangent here is going to be parallel to this line. I hope that makes sense, right? Take the 4 to the other side, so it's going to be negative 6x squared minus 14x, right? So then it's going to be minus 4 is equals to 0. Then what you're going to do is you're going to divide throughout by 2. So this is going to give you what? This is going to give you negative 3x squared, right? Then this is going to be minus 7x, and this is going to be minus 2. It's equals to 0. Divide throughout by negative 1. So it's going to give us what? It's going to give us 3x squared. So everything, if it was positive, it's going to become negative. If it was negative, it's going to become positive. So everything was negative, so everything now is going to be positive, right? And this is equals to 0. Then you're going to factorize this. So it's going to be what? It's going to be 3x, right? Plus 1. Then you're going to have x, right? Plus what? Plus 2. It's equals to 0. Then you can even use a quadratic formula to factorize this, right? So now what you're going to have that x is equals to what? It's equals to negative 1 over 3. Or it's going to be x is equals to what? It's going to be equals to negative 2. So this other two x values, right, of the tangent. So this is the x coordinate of the point of contact. That's what I mean. These are the 2 points, right, that for the x coordinate of the point of contact, that's going to happen when this, which was the tangent of the curve, like the tangent line, right, of, what you call this, of the curve on the curve h, right, where this tangent line is going to be parallel to this line here. I hope that makes sense. So these are the 2 x values. So now we're going to do the following equation. It says, given that h of x is equals to 4x cubed plus 5x, explain if it's possible to draw a tangent to the graph of h that has a negative gradient, right? So we know the following. We know that, let me just write this. We know the fact that h prime of x gives us the gradient, right? So this gives us the gradient. So that means the fact that negative gradient f prime of x is going to be less than 0. This means what? This means negative gradient, right? So that's what it means, right? So we're going to basically solve for h prime x and substitute it here and try to solve for x. If I can find x, then that means we can actually have a negative gradient. If I can't solve for x, then that means that graph h, right, does not have any tangent that has a negative gradient. I hope that makes sense. So we know the fact that h prime of x is equals to what? It's going to be 12x squared plus 5. So let's substitute this here. So it's going to be 12x squared plus 5 is less than 0, right? Take the 5 to the other side. Here we're solving for x. If x exists, then here we can have a tangent with a negative gradient. If it doesn't, we can't, right? So take the 5 to the other side. So it's going to be 12x squared is less than negative 5, right? So divide both sides by 12. So it's going to be x squared, right, is less than 5 divided by what? Divided by 12. Square root both sides. So it's going to be x is less than, so yes, it's going to be less than the square root of negative 5 divided by 12, right? Plus or minus. But here, if you punch this into the calculator, this is undefined. So this is going to give you undefined. So what that means, it means the fact that there is no x value, right? So there isn't any x value, right, where this gradient is going to be negative. The situation is happening because of the undefined, right? So now you can conclude the fact that the graph H does not have a tangent with a negative gradient. So that's how you would solve this question. So now let's do example 9. It says f of x is equals to 2x cubed minus 23x squared plus 80x minus 84, right? It says determine the y-intercept of the tangent of f. What is the y-intercept, right? Remember the fact that we're dealing with tangent, and tangent is a straight line, right? So we know the fact that it's equals to y is equals to mx plus c. The c represents, remember when we were doing functions, the c represents the y-intercept. So we're basically solving for c here, because the coordinate here is going to be 0 is to c. So we're solving for the value of c, right? So that's what we know. So it tells us the fact that it has a slope, right? Slope also means gradient of 40 and touches if at the point with the x coordinate. So they tell us that the x coordinate is an integer, right? So now they gave us the slope, and we need, remember the fact that to solve for c, we need the complete coordinate, right? So what do we know? We know the fact that we can find x with the gradient, because we know the fact that f prime x gives us gradient, right? And we know that gradient is 40, so it's the same as f prime is equals to 40, right? So now we can find f prime here, so let's do that. So it's going to be f prime is equals to what? Is equals to 6x squared, right? So it's going to be minus 46x, right? Then it's going to be plus what? It's going to be plus 80, right? But we already know that f prime, like the first derivative is equals to 40. So this is going to be 40 is equals to 6x squared minus 46x plus 80, right? And the reason why this is 40 because of this relationship, DC. It's from that relationship. Take the 40 to the other side because we want to solve for x. So it's going to be 0 is equals to 6x squared minus 46x plus 40, right? So now divide throughout by 2. So you're going to have 0 is equals to 3x squared, right? Minus 23x, then it's going to be plus 20. Factorize this. You can use the quadratic formula. So when you factorize this, you're going to have 3x, right? Minus 20. Then you're going to have x minus 1, right? So therefore, we have x is equals to what? Is equals to 20 divided by 3. Or x is equals to 1. And here they tell us the fact that the x coordinate, right, needs to be an integer. So this one is not going to be an applicable because of its what? It's a fraction. And 1 is an integer. So our answer is this one, right? So the x coordinate on the point of contact is going to be this x value, right? So now we need to substitute this 1 here in the original to find y, right? So we're going to find f of 1. Then this is going to be 2. This is going to be L cubed minus 23 That's going to be 1 all squared plus 80. That's going to be 1. This is going to be minus 84, right? And when you paste that into the calculator, you're going to get negative 25, right? So now our point of contact here to find C is what? It's going to be 1 is to negative 25, right? So now we know the fact that's going to be 1 is to 25. So now we know the fact that Y is equals to M. Our M is 40, so it's going to be 40, then X plus C, right? So we're going to substitute 1 is to negative 25, right? To solve for C. So it's going to be negative 25 is equals to 40. Then it's going to be 1. Then it's going to be plus C. Take that to the other side. So it's going to be negative 25 minus 40, which is going to give you what? Negative 65 is equals to C. So now the complete coordinate, remember it's 0 is to C, meaning it's going to be the same as 0 is to negative 65. And that's how you would solve this question. So now what we're going to do, we're going to do the cubic graph, right? So the first thing that we're going to discuss is the equation of the cubic graph, which is the equation, right? So the first thing that I'm going to look at A, right? And A, with all the graphs that we have been doing, A does the same thing here. It gives us the shape, right? So A is here to give us the shape, right? So now we need to discuss when A is positive and when A is negative, right? So when A is positive, so when A is greater than 0, right? Then the shape of the graph, this is how the graph would look, right? So the graph will go from down going like this. So this is the shape of the graph, right? This is when A is greater than 0, right? Then when A is less than 0, then this is how the graph will look. It will look like this, right? So this is the graph when A is positive, and this is the graph when A is negative. So to remember when it's positive, just remember the fact that you need to first start at the maximum before you go to the minimum, right? So just remember that when it's positive, you start from going up, right? Then you go down. And when it's negative, you need to start from minimum, then you go to maximum. So this is the graph for A, right? So now we're going to talk about intercepts, right? So as you know, the fact that we have X and Y intercept. So we're going to talk about the y-intercept, right? So in the y-intercept, this is the following, right? So we need to find what? We need to find D. So the D value gives us the y-intercept. So if we know that the D value gives us the y-intercept, then therefore the coordinate for the y-intercept is going to be 0 is to D, right? Or you can use the method of let x, let x equals to 0. But if you have an equation and you expand this D value will always give you the y-intercept. In today's video, what we're going to do is we're going to do solving cube equations. So when solving cube equation, the first thing that you need to do is you need to check whether you can factorize by grouping. And to do that, what you need to do is you need to check the coefficient of x cubed and x squared. Then you need to check the coefficient of x and the constant, which is 16. If the coefficients where you divide this 2 and this 2 together, if you get the same value, then you can use grouping. So let's do that. If we take the coefficient of x cubed, the coefficient of x cubed is 1. So you're going to say 1 divided by the coefficient of x squared is 1. So 1 divided by 1 is going to give you 1. Then we're going to check here. If you take the coefficient of x, it's going to be 16. I'm just going to ignore the negative side. Then the coefficient, the constant is going to be what? It's going to be 16 again. 16 divided by 16 is going to give you what? It's going to give you 1. So we see the fact that when we divide the coefficient of x cubed and x squared, we get 1. And also when we divide the coefficient of 16 and the coefficient of x and just the constant, we get 1. Since it's the same thing, we can use grouping. So let's do that part. So when we group, we're going to group the 1 in yellow and the 1 in red together. Just to make it simple for this example, I'm going to do it on the side. So let's take the 1 in yellow. The 1 in yellow is x cubed plus x squared. What's the common factor here? If you don't know how to find the common factor, I have a video about that. But here we take the one with the lowest degree, which is in our case here is x squared. So if we say equals to x squared, open bracket, here what's going to be left is just x. Then here what's going to be left is what is 1. So you're going to say plus 1. And that's for the first part. Then let's do this one using common factor outside. So if we have negative 16, right? Here when we take it out, we do include the negative 16, right? Negative 16x minus 16. What do we see? Our common factor here is negative 16. If we take out negative 16, you're going to have negative 16, open bracket. Whenever you take out something that has a negative, the signs inside the bracket are going to change. What's going to be remaining? Just x. And here, this, when you take out negative 16, what's going to happen is you're going to have plus 1. So this, you're done taking the common factor. What do we see? We see the fact that x plus 1 and x plus 1 is common. Meaning when we put it back here, what's going to happen is we're going to have another common factor. What you're going to do now is when we're going to write this part, the answer, which is you're going to say, here in yellow, you're going to substitute it with here. So you're going to say x squared, open bracket, x plus 1. Then you're going to take this one, which is going to be negative 16, open bracket, x plus 1. Then that's what you have, right? Then we see the fact that, as I said, we have x plus 1 is a common factor. Let's take that out. So you're going to have x plus 1, then open bracket. What's going to be left when you take out x plus 1? You're going to be left with x squared minus 16. And again, if you do not understand how to find how to take out the common factor, I have a video about it, so you can check it down the description, or I'm going to have an eye on top. So what do we see here? We see the fact that we have factorized this, but this one, it's a difference of 2 squares. Let me highlight it. This one is a difference of 2 squares. Also, I have a video on that. So if you don't understand the difference of 2 squared, you can actually check the video that I have on it. A difference of 2 squares is that you need to have 2 terms, and both of them need to have different size, which is one needs to be positive and the other one needs to be negative. And they both need to be perfect square root. So let's check whether they're perfect square root. Square root of x squared is going to give you x. So x squared is a perfect square root. Then square root of 16 is going to give you what? 4. That meaning 16 is a perfect square root. Then what you do, you take the ones that you just found inside the square root and do 2 brackets. So that's what I'm going to do. You're going to say x plus 1, open bracket. Then you're going to have 2 brackets. Then it's going to be what? X here and x here. Taking the x here. Then you're going to say 4 here. Then you're going to say 4 here. Then you're going to say plus or minus. Since this is solving cubic equations, right? This is equated to 0. This whole thing is equated to 0. So the 0, you need to say equals to 0 here, equals to 0 here, and equals to 0 here. So what's going to happen is, since we're solving cubic equations, we need to solve for each x value. So what happens is you equate each bracket by 0. So you're going to say x plus 1 is equals to 0. Then you're going to say x plus 4 is equals to 0. Or you're going to say what? X minus 4 is equals to 0. Then we're gonna take the one without the x to the other side. So we're solving for x. So you're going to say x. When you take this positive 1 to the other side, it's going to become negative 1. So that's our first value. Or when we take this 4 to the other side, it's going to be x is equals to negative 4 because it's positive this side. When you take it to the other side, it's going to become what? Negative. Or when we take this negative 4 to the other side, it's going to be positive. So it's going to be x is equals to positive 4. And this will be your final answers. So let's do another question. Again with this one, since it's similar to number 3, what we're going to do is I'm going to give you can pause. You can pause, then do the question, then unpause, then you'll see the solution and how I did it so that you can check whether you understand or not. So let's do this one. Since it's similar to number 3, we all know the fact that there's no common factor. So we're not going to factorize by grouping. So there isn't any common factors here. So what we're going to do is we're going to right away go to the synthetic, right? But the first thing first is that we need to find what? We need to find the factors of 24, right? So the factors of 24 is 1 multiplied by 24. Then the second one is going to be 2 multiplied by 12. Then the third one is going to be 3 multiplied by 8. Then we have 4 multiplied by 6. And these are going to be your factors, right? Then you're going to say plus or minus, plus or minus, plus or minus. And it's going to be plus or minus here. Also plus or minus, plus or minus, plus or minus, plus or minus. Then we're going to use those factors to check, do a trial on which one, when we substitute it, we're going to get what? A 0. Very important. This is equals to 0. Very important that when you do that, Anna, we start with the one with the lowest number. So we're going to start with plus or minus 1, plus or minus 2, plus or minus 3. We're going to go downwards. Then we're going to basically do it from smallest to biggest. So let's do that. So we're going to start with -1. So I'm going to do it in red. Just going to do it here. It's going to be open bracket -1, close bracket, plus cubed, then open bracket is going to be -1 all squared plus 26, open bracket -1 plus 24 is equals to. And another thing, another tip is that when you substitute in the calculator, please don't forget to put it inside the bracket, because if you don't do that, your answer is going to be distorted and you're not going to get the right values, right? And you're not going to know which factors work. So moving on, when we paste this into the calculator, what you're going to get is a +6. So +6 is not equals to 0. So this one is not the right one. So now let's go back and substitute. Let's change this negative into a positive and see what do we get. And when we do that, we get a +60. Remember, use your bracket. Brackets are your best friends, right? So you're going to get a +60. So -1 and +1 does not work. So we need to move to +2 and -2. So let's do that. So I'm just going to cancel here inside the bracket. Then it's going to be what? -2 first. We're going to start with -2 and check that one. So when we substitute -2, we're going to get a 0. So -2 is going to give us a 0. Remember, brackets are your best friend. Don't forget to put in the bracket. I know I'm saying this too much. So we see the fact that when we substitute -2, it's going to give us 0. So we're going to say here, x is equals to -2. So this is the number that's going to go here. So now what we're going to do is we need to find the coefficients so that they can come here. The coefficient of x cubed is 1 here. Then the coefficient of x squared is 9. Then the coefficient of x is 26, and the constant is 24. So you're going to write those numbers here. It's going to be 1, 9, 26, and 24. Then your factor that you got is -2. Then what you're going to do is we're going to drop the first number, which is in our case is 1, and we're going to write it here. Then what you're going to do is you're going to say 1 multiplied by -2. So you're going to say 1 multiplied by -2. It's going to give you what? -2. Then this -2, you're going to write it here. Then you're going to add the 2. So you're going to say 9 plus open bracket -2. It's going to give you what? It's going to give you 7. So the 7, you're going to write it down here. So you're going to give you 7, then you're going to write it down here. Repeat the process. You're going to say 7 multiply. So you're going to say 7 multiplied by -2. And you're going to get what? You're going to get -14. So you're going to get 7 multiplied by -2. You're going to get -14. Then that -14, you're going to write it here. Then you're going to add the 2. So you're going to say 26 plus open bracket -14. And that's going to give you +12. So here, that's where you're going to write +12. Repeat the process. You're going to say 12 multiplied by -2, which is going to give you 24. Then the 24 is going to come here. Then you're going to add this 2. When you add this 2, when you say 24, if you say 24 plus -24, what you're going to get a 0. So that's what's going to come here. Remember something. Remember, as I told you that this one, it represents the coefficient of x squared, and this one represents the coefficient of x, and this is just a constant, right? this one, first we need to change it. It's going to go to the other side. So it's going to be x plus 2 is equals to 0. So that's going to be our first bracket. So it's going to be open bracket x plus 2. Then this one is going to be x squared because it's multiplied by 1 plus, since this is positive, 7x plus 12. Close bracket. Then now we need to factorize this. Let me clean this side so that we can factorize this one. So to factorize this one, we need to find the effect of c is going to be 1 multiplied by 12. Then it's going to be 3 multiplied by 4. Then we need to add them together so that we get a positive, what? 7, right? So if we add 3 plus 4, what do we get? We get a 7. So these are going to be your factors. Again, if you do not understand this section, I have a video about it. So I'll link it up so that you guys can watch it. So now what's going to be, this is equals to 0. So what's going to happen is we have two brackets here. It's going to be x plus 2, open bracket. It's going to be what? X plus 3. Then close bracket is going to be x plus 4. Taking those two factors here and there and clicking their signs. This is positive and positive, right? Then this is going to be equals to 0. So now, since we're solving cubic equations, we need to solve for them, right? So we're going to equate all. So we're going to equate every bracket by 0. So you're going to have x plus 2 is equals to 0. Then the second one, or we're going to say x plus 3 is equals to 0. And the last one, or x plus 4 is equals to 0. Then x is going to be equals to negative 2. Or x is going to be equals to negative 3, or x is going to be equals to negative 4. And this will be your final answers. So let's do example 1, that is under what? Under intercepts, right? So the first question says, given that f of x is equals to 2x cubed minus 23x squared plus 80x minus 84, then it says 8.1. So 8.1, so let me just take out my pen. So it says 8.3.1, right? Prove that x minus 2 is a factor. How do we prove that something is a factor? We substitute. Remember the fact that x minus 2 is the same as saying x minus 2 is equals to 0, meaning that x is equals to 2, right? Taking the 2 to the other side. So to prove that this is a factor, we need to substitute this 2 inside f of x. So that's what we're going to do. So we're going to say f of 2 is going to be equals to what? To 2, open bracket, 2 all cubed, right? Not squared, minus 23, open bracket, 2, right? All squared, plus 18. Then you're going to say what? You're going to say 2, right? Then you're going to say minus 84, right? So you punch that into the calculator, you're going to get it to be 0. If it gives you 0, then this is a factor. If it does not give you 0, then this 2 will not be a factor. But since we got 0 in our case, then therefore this is going to be a factor, right? So now let's move on to the second question, right? Which says the fact that hence otherwise factorize fully, right? So we know the fact that 8.3.2, right? We need to factorize this. So we know the fact that f of x, right, is equals to what? Is equals to 2x cubed minus 23x squared, right, plus 80x minus 84. Since they gave us a factor, meaning we're going to use the method of synthetic, right, to factorize this. So remember the fact that we have a factor of 2, so we're going to do that. So it's going to be 2 here. Then you're going to do like this, then the 2 is going to be here, right? Then we're going to take all the coefficients and write them down here. So it's going to be 2, then here's going to be negative 23, then here's going to be plus 80, then the last one is negative 84, right? Then remember the first thing that we do is we drop the first term, right? So which is going to be 2 here, then we multiply the 2. So it's going to be 2 multiplied by 2, which is going to give you what? Positive 4. So it's going to be positive 4. Then we add this 2. So it's going to be negative 23 plus 4, which will give you negative 19. Then we repeat. We're going to say 2 multiplied by negative 80, which is going to give you negative 38. Right? Then you're going to add the 2. So it's going to be 80 minus 38, which is going to give you 42. Right? Then you're going to say 42, right? Multiplied by what? Multiplied by 2, which is going to give you positive 84. Then you're going to add the 2, negative 84. Then you're going to say plus 84 is going to give you 0, right? So these are going to be your factors. So your two bracket, when we factorize this fully, is going to be f of x, right? Now is equals to the first bracket being this one, right? So it's going to be x minus 2. Then it's going to be this 2. So this coefficient represents x squared. So it's going to be 2x squared. It's going to be minus 19x, right? So then it's going to be plus what? Plus 42, right? So remember the fact that we need to factorize this fully. So first what I'm going to do, so remember the fact that we need to factorize this fully. So what I mean this one, now we need to factorize this quadratic. So when we factorize that quadratic, it's going to be f of x is equals to open bracket x minus 2, right? Then you're going to have 2x, right? Minus 7. Then you're going to have x, right? Minus 6, right? Then we are done factorizing this fully. So now what we're going to do, example 2, right? It says, given that f of x is equals to negative x cubed minus x squared plus x plus 10, right? The first question, which is 10.1, it says write down the coordinate of the y-intercept. Remember that the y-intercept is d, and in our case, d is 10. So we know that d is equals to 10, and therefore our coordinate is going to be 0 is to 10, right? So we're done writing the y, or write down the coordinate of the y-intercept. So we're done with that. So now we're going to move on to 10.2. It says show that 2 is to 0 is the only x-intercept, right? So to do that is that we know the fact that this is a factor. This is one of the factors. 2 is one of the factors. So we're going to use synthetic to basically find the other ones, right? So we know the fact that this is going to be 2. Then here the coefficient, so it's going to be negative 1, right? It's going to be negative 1 again. Then it's going to be positive 1. Then it's going to be 10, right? So the first thing is we drop negative 1. So it's going to be negative 1. So it's going to be 2 multiplied by negative 1, which is going to give us negative 2. Then we're going to add the 2, right? So when we add the 2, we're going to get negative 3, right? So it's going to be 2 multiplied by negative 3, which is going to give you negative 6, right? Then we're going to add, so it's going to be 1 minus negative 6, which is going to give you negative 5, right? So it's going to be 5 multiplied by 2, which is going to give you what? Negative 10, right? Then these 2 are going to cancel out because it's going to be 10 plus negative 10, which is going to give you 0, right? So now if we had to, they say the fact that to show that this is the only x-intercept, meaning we need to let y equals to 0, right? So remember the fact that in the previous question they said factorize. That is why we used f of x. Here they say we need to check whether this is the only x-intercept, meaning we need to let y equals to 0. So this is the same as saying 0 is equals to what? F of x changes to what? To 0, right? So it's going to be 0. Then this is going to be this 2. Remember the fact that this is the same as, this is written as the same as x is equals to 2. Meaning if we want a bracket, we're going to take it to the other side. So it's going to be x minus 2 is equals to 0. So the factor here is going to be x minus 2, right? Then here we're going to form the other, the quadratic function, which is going to be negative x squared, right? Then it's going to be negative 3x, and that's going to be negative 5, right? So I'm going to take this bracket in front because I want to take out the negative. So it's going to be 0 is equals to negative x squared minus 3x, then minus 5, then open bracket, it's going to be x minus 2, right? Take out the negative inside the bracket, so it's going to be negative, open bracket. Everything that was negative is going to become positive, so all of them. So it's going to be x squared plus 3x, right? Then it's going to be plus 5, then open bracket is going to be x minus 2, right? So now we can divide throughout by a negative, right? So this is going to be 0. So if we divide this side by a negative, it's still going to be 0. So our answers here is going to be x squared plus 3x plus 5. Then we're going to say x minus 2. Then now we're going to what? We're going to use quadratic formula to factorize this portion. So let's do that, right? So we know the vector is going to be x is equals to what? To negative b, then plus or minus square root, right, of b squared, right, minus 4ac, and this is going to be divided by what? This is going to be divided by 2a, right? So here we know that a is equals to what? To positive 1, right? B is equals to 3, and C is equals to 5, right? So now we're going to substitute A, B, and C in here. So it's going to be x is equals to what? To negative. B is 3, so it's going to be 3 plus or minus the square root, right, of what? Square root of 3 here, right? Or squared minus 4, then it's going to be 1, then it's going to be 5, right? So that whole thing is going to be divided by what? It's going to be divided by 2a, right? Let's simplify this. So this one is going to be just equals to negative 3. Then punch everything that is inside the square root inside. Put that inside your calculator. Don't put the square root yet. Don't put the square root. Just punch the numbers that are outside, that are inside. So it's going to be 3 squared, then minus 4, then it's going to be 1, then it's going to be 5, right? So you're going to get negative 11. So this is going to be plus or minus negative 11 and divided by what? By 2, right? So now what do we see? We see that the problem, let me just take my highlighter. We see the problem is this one, is that it's a negative number, and a negative square root is going to make this whole thing undefined. Since this negative, this number is a negative, we can say the fact that this is undefined. So x is undefined. So x is equals to undefined. So since we know the fact that this x is undefined, this bracket is undefined, right? So since we know that this bracket here, right, is undefined, we can conclude the fact that 2 is to 0 is the only x-intercept. So therefore, we can conclude that 2 is to 0 is the only x-intercept. And that's how you prove that 2 is to 0 is the only intercept of f. So that's how you would prove this. So now we're going to do example 3, right? Example 3 is more or less similar to example 2, but here we need to find the factor that is genuinely the one that only factor, right? So it says, given that f of x, and I rewrote f of x properly here, is equals to 2x cubed minus 5x squared plus 4, then they say we need to prove that this has only one root. This means what? It means the fact that we're looking for x-intercept, right? So it means the fact that we're looking for x-intercept because we let it equals to 0, right? X-intercept. And remember that root is the x, right? It's the x-intercept too. So just wanted to recap that, right? So now, since we know the fact that we're looking for x-intercept, I'm going to rewrite this whole thing. So it's going to be 0 is equals to 2x cubed minus 5x squared plus 4x. So we need to basically factorize this, right? So first thing, the nice thing is that we see the fact that every term has an x, so I can take out x as a common factor here. So it's going to be x is equals, so x open bracket, not it's equals to, then this is going to be 2x squared minus what? Minus 5x, then it's going to be plus 4, right? So now we're going to factorize this, right? So if we factorize this, if we get, if we get the terms, then this, right, this thing is wrong, then this, our equation has more than, this function has more than one root. But if we get undefined, then this equation is what? Has only one root, which is going to be 0, right? So let's do that. So we have the following. So I'm going to use the quadratic formula, which is going to be x is equals to what? Is equals to negative b plus or minus square root, right, of b squared minus 4ac, right? And this whole thing is going to be divided by 2a. So here we know that a is equals to 2, b is equals to negative 5, then c is equals to 4. So let's substitute that. So x is going to be equals to negative 5, right? Then plus or minus is going to be the square root, right, of what? Of -5 all squared, right? Then it's going to be minus 4, open bracket, it's going to be 2, then it's going to be 4, right? Then that whole thing divided by what? Divided by 2 multiplied by 2. Then let's simplify this. This is going to be a negative, and a negative is going to give you a positive. Then it's going to be plus or minus. That's going to be square root. Punch everything that's inside the square root, right? So it's going to be -5 all squared minus 4. Then it's going to be 2. Then it's going to be 4, right? Which is going to give us -7. So this is going to be -7. And this is going to be divided by 4, right? Since this is negative, we know the fact that it's going to give us an answer of undefined. Since this that's inside the square root is negative, then we know the fact that this bracket here is going to be undefined, right? So we know the fact that x here is going to be undefined. So x is equals to undefined. So therefore, if we had to equate each bracket by 0 here, is that our answer here is basically x is equals to 0, or it would be like 2x squared minus 5x plus 4 is equals to 0. And after factorizing this, remember the fact that we got what? We got the fact that this is undefined. So therefore, we can conclude that x equals to 0 is the only what? Only root, right? Only real root. And that's how you would do this question. So example 4 says the fact that given that f of x is equals to x cubed, right? Minus 4x squared minus 11x plus 30. It says use the fact that f of 2 is equals to 0, then write down the factor of f of x. So basically, they want us to rewrite this in terms of factor, right? Factor is what? Factor is this. Let's just go up. Factor is this. This is a factor, right? So let me just highlight it so that you can see this is the factor. So they want us to write this, right, in terms of, so they want us to write this in this term, right? So that is a factor. Just know that, right? So we need to, so basically that's what we need to do. So let me just take out my pen. We see the fact that f of 2 is equals to 0. It is a factor because if we substitute 2 here, we're going to get 0. So here our factor is basically what? Since it's positive, it's going to be x minus 2. Because of this, it's the same as saying what? X is equals to 2. Take it to the other side, right? Which is going to be x minus 2 is equals to 0, right? So this is going to give us, making this our bracket. So this will be your factor, right? So that's how you would do this question. So now moving to stationary point, also known as what? As stationary points. I forgot an S there. Also known as turning points, right? So the first thing that you need to understand with stationary points or turning point is that to find them, you need to find the first derivative and equate it to what? Equate it to 0, right? So let's do an example. So we're going to do example 1, right? So example 1, we need to find the coordinate of the what? Of the turning point. So how do we do that? We find the first derivative, right? Then we equate it to 0. So that's what we're going to do. So the first derivative here, right? It's going to be equals to what? To 3x squared, right? There's going to be minus 12x, right? Minus 12x, and it's going to be plus 9. Because remember that 4 is going to give us what? It's going to give us a 0, negative 4. Then remember the fact that we need to equate this by 0 because of f prime is equals to 0. So this is going to be 0 is equals to 3x squared minus 12x plus 9, right? So now what we're going to do is we're going to divide throughout by 3. So it's going to be 0 is equals to x squared, right? Because it's going to be 3 divided by 3, which is going to be 1. That's why it's x squared. That's going to be negative 12 divided by 3, which is going to give you what? Negative 4x then it's going to be 9 divided by 3, which is going to give you a positive 3, right? So now we can factorize. So it's going to be 0 is equals to what? 0 is going to be equals to x minus 3. Then it's going to be x minus 1, right? So we know the fact that x is going to be equals to positive 3 or x is going to be equals to positive 1. So now this is the x coordinate of the turning point, right? So now to find the complete coordinate, we're going to substitute 3 and 1 into the original, right? So it's going to be f of 3, right? So it's going to be what? It's going to be 3 all cubed minus 6. It's going to be 3, right? All squared plus 9. Then it's going to be 3. Then it's going to be minus 4. When you pass that into the calculator, you're going to get the following. You're going to get negative 4, right? So we're going to find f of 1 now, which is going to be 1 all cubed minus 6. Then it's going to be 1 all squared plus 9. That's going to be 1 minus 4, right? So when you pass that into the calculator, you're going to get 0, right? So now our 2 coordinate here is going to be 3 is to negative 4, right? Because we substituted 3 to get 4. So that is why it's the coordinate like that. And here is going to be 1 is to 0, right? Because we substituted 1 to get 0. So that's how you will find your turning point or stationary point. So now what we're going to do, we're going to do example 2, right? So with example 2, it says f of x is equals to what? Is equals to negative 3 plus x squared plus 8x minus 12, right? Is this write down the coordinate of the turning point of h of x, and h of x is equals to f of x minus 3. So it's going to be h of x is equals to f of x, right, minus 3. So what I'm going to do is I'm going to basically substitute f of x here. So it's going to be h of x is equals to, I'm going to open my bracket, it's going to be negative x cubed plus x squared plus what? Plus 8x, right, minus 12. Then this whole thing is going to be minus what? Minus 3, right? So after doing that, we're going to basically simplify this. So it's going to be h of x is equals to what? To negative x cubed. There's going to be plus x squared, right? Then it's going to be what? It's going to be plus 8x. Then it's going to be negative 12, right? Negative 12 minus 3, which is going to give us negative 15. So this is going to be negative 15, right? So we're going to find the first derivative. So we're going to find the first derivative because that's how we find the turning point, right? So it's going to be h prime is equals to negative 3x squared, right? Then take the 2 in front, so it's going to be plus 2x, right? Then it's going to be plus 8, right? So equate this by 0 because that's how you find the turning point. So it's f prime is equals to 0. So it's going to be 0 is equals to negative 3x squared, right? Plus 2x, right? Plus 8. So divide throughout by a negative. So 0 divided by a negative. Okay, let's just do this. Take out the negative first. So it's going to be negative. Then it's going to be 3x squared. Everything that was negative becomes positive, and everything that was positive becomes negative. So it's going to be 3x squared minus 2x. That's going to be minus 8, right? So divide by negative. So this side is going to be 0 divided by negative 1, which is going to be just 0. And this is going to give us what? This is going to be 3x squared minus 2x minus 8, right? So let me just erase that. So you can use your quadratic formula to factorize this. So if I factorize this, I'm going to get the following. I'm going to get 0 is equals to, open bracket, I'm going to get 3x squared, not 3x squared, 3x plus 4, open bracket, you're going to get x minus 2, right? So now after having this, right, you're going to do what? You're going to basically know that x is going to be equals to what? To negative 4 over 3 or x is going to be equals to positive 2, right? So now we're going to substitute this x equals to negative 4 over 3 and x is equals to 2 into f of x, h of x, right? Because that's the turning points that we're looking for, right? So we're going to look for h of negative 4 over 3, right? and also h of 2. So let's do that. So here it's going to be what? Remember the fact that we're looking at this one, so it's going to be negative, open bracket, negative 4 over 3, right? Plus, then it's going to be negative, this is cubed. This is going to be negative 4 over 3 all squared, plus 8, then it's going to be negative 4 over 3, then it's going to be minus 15, right? So then here's going to be negative, then it's going to be 2 cubed, plus, then it's going to be 2 squared, plus 8, then it's going to be 2, then it's going to be minus 15. So let's punch that into the calculator. So when we punch that into the calculator, it's going to be negative, open bracket, negative, then it's going to be 4 over 3, all cubed, right? So it's going to be all cubed, then it's going to be plus, then it's going to be negative 4 over 3, right? Then that's going to be all squared, that's going to be plus 8, then it's going to be negative 4 over 3, right? Then it's going to be minus 15, which is going to give us what? Which is going to give us negative 500. So it's going to be negative 581. 581, did a mistake there. So this is going to be 500, negative 581 divided by what? Divided by 27, right? Then here we're going to get the following. So when we substitute 2 inside, we're going to get the following. So let me just substitute my 2 inside. So you're going to get the following. So you're going to get negative 3, right? So here our 2 coordinate is going to be the following. It's going to be the one that matches up with negative 4 over 3, right? So negative 4 over 3 is going to be what? Negative 581 divided by 27, right? And the other coordinate is going to be 2 is to negative 3, right? And that's how you would solve this question. So now what we're going to do, we're going to do example 3, right? It says f of x is equals to x cubed plus x squared minus x minus 2. So it says write down the coordinate of the turning point h if h is defined as this, right? So we know the fact that h of x is basically equals to 2 f of x, right, minus 4. So we're going to substitute f of x, so it's going to be h of x is equals to 2, then open bracket is going to be x cubed, right, plus x squared minus x minus 2, right? So this is going to be what? Minus 4, right? Distribute the 2. So it's going to be h of x is equals to what? Is equals to 2x cubed, right? Then it's going to be plus 2x squared minus 2x. Then it's going to be minus 4. Then this is going to be minus 4. So h of x is now equals to what? It's equals to 2, right? X cubed, right? Plus 2x squared minus 2x. Then this is going to be minus 8, right? So remember the fact that we're looking for the turning point. So we're going to find the first derivative of this turning point. So it's going to give us what? If we differentiate if we find the first prime, it's going to be x, 6x, because it's going to be 2 multiplied by 3. So it's going to be 6x, then to the power 2. Then this one is going to be plus 4x. Then this is going to be minus 2, right? Then remember that we're finding turning point, meaning h prime is basically equals to 0. So we're going to say 0 is equals to what? To 6x squared, right? Plus 4x minus 2. Divide throughout by 2, right? So it's going to be 0 is equals to, this is going to be 3x squared, because 6 divided by 2 is going to give us what? It's going to give us 3. Then this is going to be plus 2x. Then the last one is going to be minus 1, right? So now what we're going to do, we're going to factorize. So this is going to be the same as 3x, right, minus 1. Then the other bracket is going to be x plus 1, right? So x here is going to be equals to a positive or quarter, right? Or x is going to be equals to negative 1, right? So now remember, we need to find the coordinates. So we need to find f of 1, not f, h, because we're looking for that turning point. Did a mistake there. So we're going to look at h, and I'm just going to highlight the h, right? So we're going to use this one, right? So we're going to look for h of what? We're going to look for h of 1 over 3, right? So when we look for h of 1 over 3, so it's going to be what? It's going to be 2 open bracket 1 over 3 on cube, right? Then it's going to be plus 2, then it's going to be 1 over 3 all squared minus 2. It's going to be 1 over 3, then it's going to be minus 8, right? So punch that into the calculator, you're going to get the following. It's going to be 2 open bracket 1 over 3, right? Then this is all cubed, right? Then it's going to be plus 2, then it's going to be 1 over 3. So it's going to be 1 over 3, right? Then that's going to be all squared minus 2, that's going to be 1 over 3, right? Which is going to be, then it's going to be minus 8. So you're going to get your answer as being equals to negative 226 divided by 27, right? So making our coordinate here to being 1 is to 3 is to what? Is to being negative 226 divided by 27. So this is the coordinate for when it's 1 over 3. So now we're going to look for h of negative 1, right? So it's going to be 2 open bracket negative 1 all cubed plus 2, then it's going to be negative 1 all squared, then it's going to be a negative 1 here, then it's going to be negative 8. So let's punch that into the calculator. It's going to be 2 negative 1 all cubed, right? So it's going to be plus, then it's going to be negative. So it's going to be negative 1 again, but now it's going to be all squared minus 2, open bracket negative 1. Then it's going to be minus 8, which is you're going to get your answers being negative 6, right? So the coordinate here is going to be negative 1 is to negative 6. And that's how you would find the turning point for this question. So now I want to talk about the relationship of the turning point of f of x. So this is f of x, right? And the x coordinate of f prime, right? So the relationship of the turning point is that we see the fact that this is the turning point, right? So let's say the x coordinate of the turning point. So let's call it negative a, and let's call this positive b, right? So the relationship between the two is that f prime, right? F prime, so let me just do this, right? The x, right, coordinate, the x coordinate of the turning point, right? Turning point of f of x is equal to the x-intercept of f prime. And this makes sense, right? Why am I saying this makes sense? Is that remember the fact that when we're looking for the turning point of f of x, what do? We say f prime is equals to 0, right? So if we take this as being a function, right? And we know the fact that this is a quadratic, right? So we know the fact that this is a quadratic function, right? This is a quadratic function, right? So if we take this, what does this mean, right? When we equate, when we say f of x is equals to 0, do you agree the fact that this is it's us finding the x-intercept, right? Because finding the x-intercept, we say x-intercept, we say let y equals to 0. And this is exactly what we did here, right? So that is why the x-coordinate of the turning point of f of x, it's exactly, or it's equals to the x-intercept of what? Of f prime. So now, how would we sketch this graph, right? Since this f of x is what? It goes up and it goes down, right? And that means that our a here is what? Is greater than 0 for f of x, right? So meaning, if I had to sketch the quadratic here, is that when a is greater than 0 for f prime, which is the quadratic, right? That means so for, let me just write it here, for a greater than 0 for f prime, remember the fact that f prime is the quadratic, right? So this means it's going to create a smiley face, right? So our 2 points here are going to be the turning point. So our graph for f prime is going to pass through here and it's going to pass through here. So just a rough sketch, this is how the f prime is going to look. So this is how f prime is going to look. Right? So this is how it's going to look. So meaning if they give you, so let me just take another color. If they give you the red graph, which is f prime, right? If they give you the red graph and they give you the x-intercept, right? You can basically find the turning point of f of x, right? So that's what I want you to do. Is that this relationship is that if you have this 2, you can basically find the turning point, the x-coordinate of the turning point of f of x. So this is a very important relationship between the 2 graphs, right? So now let's do example 6, right? It says, let me just change my pen. It says the graph of y is equals to f prime, where f is a cubic graph. So we know the fact that f is a cubic graph, right? So we know the fact that f is a cubic graph is sketched below. But below, what did they sketch? Do you see the fact that they sketched the f prime? So the first derivative, which is a quadratic. So they say use the graph to answer the following question, right? At which values of x does the graph f have a local minimum, right? So looking at our graph, we see the fact that what we given, right? Looking at this, we know the fact that these 2, right, are turning points. So we know the fact that x equals to -4 is a turning point, and also x equals to 1 is a turning point, right? So here we're looking for the x value. So the value of x for this graph f, very important for f to have a local minimum, right? So we need to basically sketch this one in terms of f, right? So we are given what? We are given the following. We are given the first derivative, right? So we're given that f prime. And when it's a set face, we know that a is less than 0, not greater than 0. So we know the fact that x is going to be, a is going to be less than 0 because it's a set face, right? So we know the fact that this graph has when a is less than 0, right? So we need to translate this graph into being f. So we need to sketch roughly the graph of less than 0 of a cubic function, right? So this is what's going to happen. It's going to look like this, right? So this is the graph of a cubic function when it's less than what? Less than 0, less than 0, right? When a is negative. So this point here, remember the fact that the x-coordinate, let's go back. Remember the fact that the x-coordinate of the turning point of f is equals to the x-intercept of f prime. Since we're given that f prime, right, the x-intercept is -4 and 1, we know the fact that this point here is -4 and this point here is 1, right? So remember the fact that we're looking for the local minimum. This is the local minimum, right? And this is the local maximum. So therefore, the x-coordinate for the local minimum, so the x-coordinate for the local minimum, right, is basically equals to x is equals to -4. Because you see the fact that here, that's where the local minimum is. So that's how you would answer this question. So now we're going to move to increasing and decreasing, and increasing or decreasing. So we're going to do a question about increasing and decreasing. Very important with increasing and decreasing, we need one thing. We need turning points, right? So we need turning points. So that's what we need to answer this question. So your answer is going to be in terms of your turning points, right? Because where your turning points, right, changes is when the graph changes from being increasing to decreasing or decreasing to increasing, right? So first, what we're going to do is we're going to do the first question. It says determine the values of x for which g is strictly decreasing. So when they say strictly, right, our answer needs to be in squares. So our answer needs to be included, right? So your answer needs to be included like this because it says strictly. So now I'm going to highlight the portion. So we know the fact that our graph is divided into turning points. So let me just take this, and I'm just going to take my pen and I'm just going to do this. They already divided the portion here, right? So now I'm going to start from negative So I'm going to start from negative infinity to 1 and check whether our graph is increasing or decreasing, right? So I'm going to highlight it. So it's going to be, I want to highlight, not pen. So I'm going to highlight it. So from negative infinity till 1, right, what happens is that this portion here, right? So what we're going to do is that we're going to check from going from this direction, from going from this direction, going like this. Are we going down or are we going up, right? So from going from this direction to this, the yellow part, do you see the fact that we're going down? Right? So that means this part is for decreasing. This part is for decreasing, right? So again, I'm going to take another color for highlighter. Then I'm just going to images highlighter, right? I'm just going to take another color, which is green, right? So I see from this portion here going to, from negative 1 going to 2, right? What do I see? I see the fact that, remember the fact that we're going in which direction? We're going in this direction, right? We're going in this direction. What do I see? I see the fact that, let me just take a different color. I see the fact that my graph is increasing. Do you see that? Going in that portion. Do you see the fact that my arrows are going up, right? So meaning this portion is going to represent increasing, right? Then take my highlighter, take back to yellow, right? Is that if I go from 2 till positive infinity, right? What do I see? I see the fact that my graph is going to be what? Decreasing, right? Because remember the fact that we're going in this direction. Always you're going to go in this direction from negative infinity till positive infinity, right? So till positive infinity. So we see the fact that our graph is decreasing, right? So to answer the first question, it says, determine the values of x for which g is strictly what? Strictly increasing. So we see the fact that from negative infinity till 1, our graph is what? It's decreasing, right? So that's not our answer. But from 1 till positive 2, our graph is increasing. So our answer here is going to be x is an element, right? From where? From negative 1 till 2, right? So that's going to be your answer. So that's going to represent the strictly increasing. So the green part represents the strictly increasing. Then number 2, it says, determine the values of x for which g is strictly decreasing, right? So we see the fact that it's decreasing on the yellow parts. Do you see the fact that the arrows are going down? So our answer is going to be from x is an element from negative infinity till negative 1 included, or it's from where? It's from 2 till positive infinity, right? So that's going to be your answer for strictly increasing and strictly decreasing. So that's how you would answer it. Just remember the fact that we always go from negative to positive to see whether it's increasing or decreasing, right? So this is how you would answer this question. So now let's do example 2. But before we do example 2, you need to understand the relationship, right? So you need to understand the relationship between increasing or decreasing and f prime, right? So you need to understand this relationship. So the first thing so I'm just going to put a tick right here, is that when f of x, right, when the cubic graph, which is f of x, is increasing, then we can say what? We can find the first derivative, right? When the first derivative, right? When the first derivative is greater than 0. So this and this are exactly the same thing. You're looking for the same thing, right? And another thing is that when f of x is decreasing, so here since they said strictly, you can say equals to, right? So this is decreasing, right? Then we can find the relationship when f prime is less than and equals to 0. So this is a very important, what you call this relationship, because we're going to use this relationship to basically solve this question, right? So it says for a certain function, if, right, the first derivative is given as f prime is equals to 3x squared plus 8x minus 3. It says determine the values of x for which f is strictly increasing. Do you see the fact that here, what did they do? They basically gave us the f prime, but they want us to find when f, which is the cubic, is increasing. So what do we know? We know that that relationship is from here. So we know the fact that this is the relationship when it's strictly increasing. This is the relationship, right? So that's what we're going to do. We're going to solve inequality here, right? So we're going to say f prime of x strictly increasing means is greater than and equals to 0. Substitute this by this, by the f prime that they gave us. So it's going to be 3x squared, right, plus 8x minus 3 is greater than and equals to 0, right? Then now we're going to factorize this. So when we factorize this, we're going to have two brackets. It's going to be 3x minus 1, right? And the reason why we're factorizing, we're looking for critical values. Then it's going to be x plus 1, right? It's going to be greater than and equals to 0. Then here it's going to be what? X is going to be equals to 1 over 3, right? Or it's going to be x is going to be equals to negative 1. And this is your critical values. You need your critical values to basically draw your number line. So this is going to be the number line, right? We start by the negative. So this is going to be negative 1. Now this is going to be 1 over 3, right? Then you're going to draw dotted lines going down like this by the critical values that you just put down, right? Then this is from negative infinity and this is positive infinity, right? Then you're going to pick a number from negative infinity till negative 1, which is I picked as being negative 5, right? Then you're going to pick a number between negative 1 and 1 over 3, which is I picked as being 0. Then pick a number between, so let me just do this. Pick a number between 1 over 3 and 8, which is I picked as being 2, right? Then what we're going to do is that we're going to basically substitute negative 5 here into the first derivative, right? So I'm going to substitute negative 5 here, right? Remember the fact that the reason I'm substituting here because of I'm finding the inequality of f prime, right? So I'm going to substitute there. Then I'm going to also substitute 0 in the first derivative and also substitute 2. So let's do that. So it's going to be here. It's going to be 3 negative 5, right? All squared plus what? Plus 8. Then it's going to be negative 5. Then it's going to be minus 3. And this is going to give us what? This is going to give us 32. We're only interested to this. We're only interested on the sign. So it's going to be what? It's going to be plus here. It's going to be positive, right? Then it's going to be for 0. So for 0, it's going to be like this. Let's substitute. And we're going to get a negative 3, which means the fact that negative sign here. Then it's going to be 3. Then it's going to be 2. It's going to be plus 8. So it's going to be 0. It's going to be 2 here minus 3. We're going to get 25. Positive, so it's going to be positive. So here we're going to put at negative 5. Remember, we got a 32 and which was positive. So here it's going to be positive, right? Then for 0, we got negative. So here it's going to be negatives. Then at 2, we got what? We got a positive. So here it's going to be positive. So greater than 0 means what? Means positives, right? Greater than 0 means positives, right? So now we're going to highlight where it's positive. So it's going to be positive here and here. So that's going to be where our answer is going to be between, right? So our answer for this one, so let me take my pen. So for f prime of x is greater than or equals to 0, my answer is going to be from when x is an element from negative infinity till what? Till negative 1, including, right? Or, since it's greater than or equals to, or it's going to be from 1 over 3, right? Till positive infinity, right? So this is going to be our answer for what? For when it's, when f of x is increasing, which is also represents this, right? So this will be your answer. When f of x is increasing. So now in green, I'm going to highlight when f of x is decreasing. So when it's decreasing, it's going to be negative, which means this, right? Right? So here we're looking for what? Let me just write it down. We're looking for when f of x is decreasing, right? Which is the same as looking for when f prime is less than and equals to 0. And our answer is going to be x is an element, right, from -1 till 1/3. So that will be your answer for when f of x is decreasing. So this represents when it's decreasing, which now we translated to f prime is less than and equals to 0. And this will be your answer. I hope that made sense. So now let's do example 3, right? So let me just take my pen. It says the graph y is equals to f prime, where f is a cubic function is sketched below, right? So here it says use the graph to answer the following question. So 10.1, it says for which values of x is the graph y equals to f of what you call as f prime is decreasing, right? This is different from saying f of x is decreasing, right? Here, they're not talking about when f of x is increasing, but they're talking about when f prime is what is decreasing. So meaning here, we need to find the turning point of this quadratic function. And since we have the x-intercept here, we can find the turning point by finding what? By equating them, by adding them together and dividing by 2, which we're going to get the x-intercept of the turning point. So it's going to be the same thing that we've been doing here, but here we're going to use it. We're going to use it, but in a sense of a quadratic. I hope that makes sense, right? So now let's find the x-coordinate, right? The x-coordinate of the turning point. And the reason why is that the x-coordinate of the turning point is going to divide this function from increasing to decreasing. So let's do that. So we know the fact that we can find it by the x-intercept. So it's going to be x is equals to -4 plus 1 divided by 2, which is you're going to get your answer as being what? If you say -4 plus 1 divided by 2, you're going to get your answer as -3 divided by 2, right? So now we have divided our graph into being 2 parts, right? At the x-coordinate of the turning point, right? So now we're going to do the same thing. We're going to go from -infinity till +infinity, right? We're going to check, is our graph going up or down, right? So let me just highlight the first portion. So let me just take my pen again, then highlight the first portion in yellow. So we see the figure from -infinity till the x-coordinate of the turning point, which is -3/2. What do we see, right? Taking my pen, we see that the graph is going up. Do you see that? So our graph is going up like this, right? So this portion is going to represent what? It's going to represent the increasing part. Then if I take my highlighter, but now change my color and go from -3/2 till +infinity, what do I see? I see that my graph is going down. Do you see that? So I see that my graph is going down, right? So here to conclude, when f prime, right, is decreasing, right, then my answer's from negative. So x is going to be an element from where? From negative. Since they didn't say strictly, right, we're going to put a curved bracket because there's no strictly. So it's going to be from -3/2 till +infinity, right? So this represents the green part, right? So now when they say f prime, if they ask you that f prime is increasing, then your answer will be from -infinity till what? Till 3/2. So your answer is going to be x from -infinity till -3/2. Let me just highlight for increasing and decreasing. So let's go here. So remember that this one represents 4 when it's decreasing, then the yellow one represents 4 when it's increasing. So let me just highlight that. So this is 4 when it's increasing. So this is how you would answer this question. So now we're going to do example 4, right? So let me just take out my pen. It says the graph of f of x is equals to -x cubed plus ax squared plus bx plus c. Don't matter, don't mind this. Just know the fact that this is how the cubic graph looks, right? And they tell us that the x-intercepts are indicated. Also, that doesn't matter, right? So what matters is the question. It says for which values of x will f prime, right, will f prime be less than 0? Remember the relationship between what? Between increasing and decreasing and f prime, right? If it says f prime of x, right, is less than 0, what does this mean? That means the fact that we're looking for when f of x, which is the cubic function, which is what we have in the diagram, is decreasing. So that's what we're looking for, right? And remember the fact that we need to divide our graph into turning points, which is I already have the 2 points here, which is negative 1.4 and 3,22, right? So we're going to start. So let me just do this. You're going to start from negative infinity till positive 1, right? We're going to check whether that portion from negative infinity till 1 from the first turning point, which is 1.45, is it increasing or decreasing? Remember the fact that we're going in this direction, right? From negative infinity till 1.45, we see that our graph is going down. Do you see that? So our graph here is going down, right? Then from 1.45 till 322, we see that our graph is going up. Do you see that? Our graph is going to be going up. And then from 3.22 till positive infinity, we see that our graph is going down, right? So we are looking for when our graph is going down, right? So I'm going to highlight that portions. So where our graph is going down is going to be here, which represents decreasing, and here only, right? So that's going to represent decreasing, right? So our answer here is going to be x is an element, right, from negative infinity till 1,45, right? Or from 3,22 till what? Till positive infinity. So that's how you would answer this question. So now we're going to move to determining the equation. This is where most of your marks are going to be because of this type of question. The minimum that can give you is like 4 marks and the maximum is around 6 to 7 marks, right? So let's do this first example. And the first example is taking the relationship between f prime. So let me just write this. So it's taking the relationship between g prime, right? So here we're given g prime. And from given the quadratic, they want you to determine the cubic function, right? So here, Nane, we see the fact that we have two things. We have turning points, right? Remember the fact that the x-coordinate of the turning point is equals to what? It's equals to the following. It's equals to the x-intercept of the g prime, right? So the first question says, determine the x-coordinate of the turning point of g. So we know the fact that the x-coordinate is going to be x is equals to negative 2, right? And x is equals to what? Is equals to 1. So this is the x-coordinate of the turning point, right? Then number 2, it says what? It says, given that g of x is equals to ax cubed plus bx squared plus cx, calculate a, b, and c, right? So here, to answer this question, Nane, since the information we have is on g of x, g prime of x, right? We need to find g prime of x of this form, of the form a, b, and c. So we need to change this into being g prime of x so that we can be able to solve this entire equation and find a, b, and c, right? And the reason why is that, remember the fact that I cannot use the g of x the way it is because of the information that they gave us is from g prime. I hope that makes sense. So first we need to transform this g of x, the one that has a, b, and c, into being g prime, then use that to basically answer our question. Let's do that, right? So the first thing that we're going to do is that we're going to find g prime of x, right? And that's going to be equals to what? It's going to be equals to 3a. Wait, okay, let me just do that. Let me just do the following so that when you read this, it makes sense. Let me just erase this. So what I just said, I said since, right, since the information, so it can make sense, right? Since the information we have, right, we have is on g prime of x, right? We need to find g prime of x, right? To solve for A, B, C, right? So we see the fact that we have g of x as being equals to, and I'm not talking about this one, the one that we given in the formation, we're talking about this one. We see the fact that we have ax cubed, right? Plus bx squared plus c. So we're going to find g prime of x of this one. So it's going to be g prime, and we're going to equals to 3a squared, right? X squared, right? So let me just clean that up properly. So that's going to be x squared, right? So it's going to be x squared. Then we're going to have plus 2bx, right? And this is going to be plus c, right? So that's why we know. Then this one, now this function here, right, is this one here. It represents this one. What do we see? We see the fact that from this, because this is a quadratic, remember the fact that this is a quadratic, right? So this is a quadratic, right? So since this is a quadratic, what do we know? From the graph, so from the graph, right, we know the fact that C is going to be what? C is the y-intercept. Remember that C is the y-intercept. So since C is the y-intercept, and we're given as the y-intercept as being -6 here, right? What can we say? We can say the fact that C is equals to what? Is equals to -6. So here we already found C as being -6 because of this is a quadratic and C represents the y-intercept. I hope that makes sense, right? So now with that said, right, we're going to use this 2, right? We know the fact that the coordinate here is going to be -2 is to 0, and here is going to be 1 is to 0, right? We're going to use this 2 coordinate to basically solve for A and B. And the reason why is that, remember the fact that we have 2 unknowns, meaning we're going to need 2 coordinates to basically solve those unknowns, right? So now I'm going to rewrite this by putting C as being 6. So it's going to be G prime now, right? Is equals to what? Is equals to 3ax squared plus 2bx, that is going to be -6, right? Then now, and I'm going to just name this 1, right? So now we're going to substitute -2 is to 0, right? Into 1, right? So that's what we're going to do. So let's do that. So it's going to be 0. Remember the fact that G prime is going to be 0. Then it's going to be 3a. Then it's going to be -2, right? Then it's going to be all squared. Then this is going to be plus. Then it's going to be what? It's going to be 2, right? Then it's going to be b. Then it's going to be -2. Then it's going to be -6, right? Simplify that. When we simplify that, we're going to have the following. We're going to have 0 is equals to 12a, right? Then we're going to have -4, right? -4b. Then it's going to be -6. And that I'm going to call it as being equation 1, right? Then after doing that, now remember the fact that we need 2 equations because we have 2 unknowns. So now we're going to substitute 1 is to 0 into 1, right? So no, let's not name this one. Let's call it star, this one. So into star, right? So when we substitute that into star, what we're going to do is going to be 0 is equals to, then it's going to be 3a, open bracket, right? It's going to be 1 all squared plus 2b, then it's going to be 1, it's going to be -6, right? Let's simplify that. It's going to be 0 is equals to what? Is equals to 3a, right? Plus 2b -6, right? Then we're going to take the 6 to the other side. So what I did is I took 6 and 3 to the other side, right? So I'm going to divide both sides by what? I'm going to divide both sides by 2. So it's going to be 6 divided by 2 is just going to give us 3, right? And 3 divided by 2 is going to give us what? Negative 3 over 2a, and this is going to be b. And this I'm going to call it equation 2, right? So now we have equation 1. So let me just rewrite equation 1 here. Remember that equation 1 was 0 is equals to 12a, right, minus 4b minus 6. And this was equation 1, right? So what I'm going to do right now is that I'm going to substitute, right? I'm going to substitute equation 2 into equation 1, right? So that's what I'm going to do. So I'm going to substitute, right, equation 2 into 1. So now wherever I see b in equation 1, I'm going to substitute by this. So it's going to be 0 is equals to 12a. Then it's going to be minus 4. Then the b, right, it's going to be 3 minus 3 over 2a, right? Then it's going to be minus 6, right? So now let's clean this up. So it's going to be 0 is equals to what? To 12a. Then it's going to be negative 4 multiplied by 3, which is going to give you negative 12. That's going to be negative 4 multiplied by 3 over 2, which is going to give you what? It's going to give you a plus 6a. Then it's going to be what? Negative 6. Let's clean it up. Let's group like terms. So it's going to be equals to 0 is equals to negative 6, right? Then plus 6a. Take the negative 6 to the other side. So it's going to be 6 is equals to what? To 6a. Divide both sides by 6. So a is going to be equals to 1. So a is going to be equals to 1. So now substitute a equals to 1 into equation 2. So into 2 because of it's in terms of b, right? So it's going to be what? It's going to be b is equals to what? It's going to be equals to 3 minus 3 over 2. Then it's going to be 1. Then when you punch that into the calculator, you're going to get your b as being 3 is 2, 3 over 2, right? So this is going to be your b, right? So therefore, remember that we need to write g of x. So therefore, our g of x now, right? We have, remember the fact that on the other side, we solved that c is equals to 6. So we remember the fact that we had c as being equals to negative 6, right? So therefore, g of x is going to be, then a is 1, so it's going to be just x cubed here. Then it's going to be plus 3 over 2 x squared. Then it's going to be plus what? Not plus, it's going to be negative 6x. So let me just erase this. So it's going to be negative 6x. And that's how you would find your graph. This is how you find your cubic graph if you're given what? If you're given the, the quadratic or the x-intercept of the turning points. So now let's do example 2, right? It says the graph of g of x is equals to ax cubed, right? Plus bx squared plus cx, right? And they say the fact that a cubic function having the y-intercept, so we see in the fact that it has a y-intercept at 0, is given below, and the x-intercept of the turning point, so they gave us the x-intercept of the turning point, are negative 1 and 2, right? So here they say the fact that if g prime is equals to negative 6x squared plus 6x plus 12, determine the equation of g. So do you see the fact that they actually gave us the actual function of g prime, right? So what we're going to do is that since, let me just write it. So this is since we are given g prime, right? So we're given g prime and it's actual, like it's an actual function, right? Since we're given g prime, right, we can find g prime of this one, the one with the alphabets, right? So we can find the g prime with the one with the alphabet to determine the cubic function, right? So we can find the g prime of the one with the alphabet. So it's going to be what? It's going to be 3ax squared, right? Plus 2bx, right? Plus c, right? So now, since we know the fact that the one with the alphabet and the one with the numbers is this one, right? 6, so this is 6x plus 12, right? This 2 are exactly the same thing, right? They are equal to each other. So they are equal to each other. So these two are equals to each other, right? So let me just rewrite this equal. So these two are identical to each other. Since we know the fact that these two are identical with each other, then we can do the following, right? We can equate this and make them equals to each other because this is the same thing. Then take this and this, right? And this and equate them to each other. So that's what we're going to do, right? So we're going to say 3a squared, not 3a squared, 3a, because it's just the coefficient of x squared, right? So let me just erase. Okay. So you're going to say 3a is equals to -6. So now I can solve for a. So a is going to be equals to -6 divided by 3, which is you're going to get -2, right? Then you're going to say 2b is equals to 6. Divide both sides by 2. So b is going to be equals to positive what? It's going to be equals to positive 3, right? Then the last one is going to be c is going to be equals to positive 12, right? Now you have a, b, and c. So now we can rewrite g of x. So g of x right now is going to be equals to a is -2, then it's going to be x cubed, right? Then b is +3, then it's going to be x squared. Then c is going to be plus 12x. And that's how you would find your g of x if you're given the actual function of g prime, right? So that's how you would do it. So now we're going to do example 3, right? It says the function f of x is equals to -3x cubed plus ax squared plus bx plus c is sketched below, right? They say the turning point of the graph f is t, right? Which is this point, and it's s, which is that point, right? Then let me just change my color. It says show that a is equals to 21, b is equals to 60, and c is equals to what? It's equals to 43. So the first thing we're going to do is that first we need to find, right? We need to find g prime of x. And the reason why we're doing that is because of if we find g prime of x, the c is going to disappear. And again, is that we know the relationship between the turning points, right? Is that by finding g prime of x, right, we know the fact that this relationship is going to hold about g prime of x is equals to 0. So I'm going to use that relationship to basically solve for a and b. So let's do that. So we're going to find g prime of x because, right, c is going to go away. C is going to go away. And that's what we want, right? Meaning we're gonna have less things to deal with first, right? So since it's gonna go away, so g prime of x is gonna be equals to, it's gonna be -6x squared, right? Then it's gonna be plus what? Plus, then it's gonna be 2ax, right? Then it's going to be plus b. And remember that c here is a constant. That is why it's going to go away, right? Then now, knowing that, remember the following relationship. Remember that the x-coordinate, right? The x-coordinate of the turning point, which is we do have, right, of the turning point is the x-intercept, right, of x-intercept of what? Of f prime, right? So that means the fact that the x-intercept, our coordinate here for the x-intercept is going to be 2 is to 0, right, for f prime. And also it's going to be what? It's going to be 5 is to 0, right? So now we're going to use 2 is to 0 and 5 is to 0 and substitute here to find our two equations to solve simultaneous because we have two unknowns, right? So I'm going to say substitute 2 is to 0 into what? Into f prime, right? So let's do that. So it's going to be 0 is equals to what? It's equals to -6, open bracket. It's going to be 2 all squared plus 2a, then it's going to be 2 here, then it's going to be plus b, right? So let's simplify that. So we're going to have the following. We're going to have 0 is equals to negative what? Negative 24, right? Then it's going to be plus what? Plus 4a, then it's going to be plus b. And this I'm going to call it equation 1, right? So this is going to be equation 1. So now I'm going to substitute 5 is to 0 into what? Into f prime, right? And remember the fact that we're looking for what? For the second equation. So it's going to be 0 is equals to negative 6. Then it's going to be 5 all squared plus 2. Then a, then it's going to be 5. Then it's going to be plus b, right? Let's simplify that. It's going to be 0 is equals to what? It's equals to negative 150, right? Plus 10a, that's going to be plus b. Take the negative 50 and add 10a to the other side. So it's going to be 150, right? Minus 10a is equals to b. And this is, I'm going to call it equation 2, right? So let me just go to the next page. We know the fact that equation 1 is what? It's actually 24 is equals to 4a, right? So it's equals to 4a plus b. So this is equation 1. Let me just go back. And I think I didn't simplify it here. So let me just say it's going to be 24 is equals to what? To 4a plus b. So this is actually equation 1. Let me just erase this part, right? The simplified version of it, right? So that is going to be equation 1. And we know the fact that equation 2 here in our case is going to be what? It's going to be b is basically equals to 150, right? Minus 10a. So now what we're going to do is we're going to substitute equation. This is equation 2, right? So we're going to substitute equation 2 into 1. So let's do that. So we're going to take 1. So it's just going to be 24 is equals to, wherever I see b, I'm going to substitute by this. So it's going to be 4a, then plus, then it's going to be 150 minus 10a, right? Simplify this. So you're going to have 24 is equals to 4a, right? Plus 150 minus 10a, right? So let's clean this up. So we're going to take the numbers to the one side. So when we take the numbers to one side, it's going to be 24 minus 150, which is going to be negative 126 is equals to what? Then it's going to be 4 minus 10a. So it's going to be negative 6a. Divide both sides by what? By negative 6. So a is going to be equals to positive 21. So we are sorted with finding this a, right? Now we're going to move to finding b. So now we're going to substitute a equals to 21 into what? Into b, right? So it's going to be b is equals to 150 minus 10, open bracket 21. Punch that into the calculator. You're going to find your b to be negative 60. So now we are sorted. So now we can rewrite f of x, this equation, right? Substituting a and b, right? So let's do that. So we're going to say f of x is going to be equals to negative 2x cubed, right? Plus what? Plus 21x, right? Then we're going to say minus 60x, then this is going to be plus c. So now remember the fact that they gave us a complete point for the turning point. You can substitute either t or s to solve for what? To solve for c. So you can take either one of them, right? So what I'm going to take t. So I'm going to say substitute t, right? Which is 2 is to negative 9, right? Into f of x. And this f of x, right? So I mean this f of x, right? So when I substitute that, I'm going to have negative 9 is equals to what? Is equals to negative 2. Then it's going to be 2 all cubed. Plus 21. Then it's going to be 2. That's going to be minus 60. Then it's going to be 2. Then it's going to be plus c, right? So let's clean this up. So it's going to be negative 9 is equals to what? It's equals to negative 15. 2 plus c. Take the negative 52 to the other side. So it's going to be negative 9 plus 52. which is going to give us C as being equals to 43, which is exactly this. So this will be your final answer. Let me just highlight them. So A, then B, and C. And this is how you would solve this question. So now we're going to do example 4, right? It says a cubic function f of x is equals to negative 2x cubed plus bx plus cx plus d cuts through the x-axis, right? So let me just take my pen. So it cuts through the x-axis at 3 is to 0, negative 3 over 2 is to 0, and 1 is to 0. What do we see this? This is what? This is our x-intercept. Do you see that? So they gave us the x-intercept here, right? So they gave us all the x-intercepts. So the first question, it says, show that h of x is equals to negative 2x cubed minus 7x plus, plus 9. So here, how we will do it is that since we have all 3 x-intercepts, right? So since we have all 3 x-intercepts, right? And the nice thing is that they gave us A, right? And A is equals to negative 2. What can we do? We can do the following. We can use, right? We can use this formula. So we can use this formula. So we can use this formula to solve the equation. So we can use this formula to solve for h of x, right? So this formula is going to be y is equals to y2, a open bracket x minus x1, right? Then you're going to say x minus x2, then it's going to be x minus x3, right? So now x1, x2, and x3. So we need to find this bracket. So for the first one, it's going to be, we know the fact that x is going to be equals to negative 3, right? It's the same as x. Take it to the other side. So it's going to be plus 3 is equals to 0. So this will be our first bracket. So the other one is x is equals to negative 3 over 2. So take it to the other side. It's going to be the same as x plus 3 over 2 is equals to 0. This is going to represent our second bracket. Then the last one is going to be x is equals to 1. Take it to the other side. So it's going to be x minus 1 is equals to 0. So we have our 1, 2, 3 brackets here. So let's substitute them. So it's going to be what? It's going to be the same as h of x. Remember the fact that a here is equals to negative 2, right? So it's going to be equals to negative 2. So it's going to be negative 2. Then you're going to open your bracket. I'm going to start with the one with the fraction. So it's going to be x plus 3 over 2, right? Then here's we're going to have what? We're going to have x, right, plus 3. Then we're going to have x minus 1, right? So now we're going to expand this, right? So it's going to be h of x is equals to negative 2. Open bracket is going to be x plus 3 over 2, right? Then here we're going to expand it. So when we expand it, we're going to have the following. We're going to have x squared, right, minus x. That's going to be plus 3x. Then we're going to have minus 3, right? Then h of x now is going to be equals to what? Let's clean up this bracket first. So it's going to be negative 2. Then you're going to have x plus 3 over 2. Then you're going to have what? You're going to have x squared, right, plus 2x. Then it's going to be minus 3, right? So therefore, h of x, right? Now we're going to distribute the 2 inside the first bracket, right? So when we substitute the 2 inside the first bracket, it's going to be 2 multiplied by x. So it's going to be negative 2x. That's going to be negative 2 multiplied by 3 over 2. So it's going to give you what? It's going to give you negative what? It's going to give you negative 3. So this is going to give you negative 3, right? Then this is going to be x squared plus 2x then minus 3, right? So now we're going to distribute the negative 2 and negative 3 into this bracket. So you're going to have h of x here is equals to the following. It's going to be negative 2x cubed, right? Then it's going to be negative 4x squared, right? Then it's going to be plus what? Plus 6x. Then for the negative 3, it's going to be negative 3x squared. And then it's going to be minus 6 x, right? Then it's going to be plus 9, right? So now let's clean it up by grouping like terms. So h of x is going to be equals to what? To negative 2x cubed, right? Minus 7x squared. Then it's going to be plus 9, which is exactly what they want. So this is how you would solve this question. So now we're going to do example 5, right? It says, given that h of x is equals to negative x cubed plus ax squared plus bx, and g of x is equals to negative 12x, then they tell us that P and Q are the turning points on the graph H, right? So that's what we know. We know the fact that P and Q are the turning point. So this is a turning point and this is a turning point. And they tell us that H passes through the origin. And the first question that we're going to answer, they say the fact that show that A is equals to 3 divided by 2 and B is equals to 6, right? So here, if we're looking at our information, what do we have? We only have this Q as being a complete coordinate, right? And what is nice about this Q is that since we have two unknowns, which is A and B, right? We can use this Q, right, to substitute first on h of x to find the first equation. Then we can use the relationship between that, the turning point, right, of what? A turning point, the x coordinate of the turning point of a cubic function is equals to what? To the x coordinate of the x-intercept of h prime. So we can use the fact that when we look for h prime, right, then our coordinate here is going to be the x-intercept, which is going to be 2 is to 0. So we can use that relationship to find our second equation, right? So here I'm going to say since we given Q, right, as being 2 is to 10, right, as a turning point, right? So we can substitute first. Remember the fact that we need two equations to basically solve for simultaneous because there's two unknowns. So we're going to substitute 2 is to 10, right, into what? Into h of x. So let's do that. So it's going to be 10 is equals to what? Is equals to negative open bracket 2 all cubed, right, plus a, then it's going to be 2 all squared, then it's going to be plus b, then it's going to be 2, right? Simplify that, it's going to be 10 is equals to what? 10 is going to be equals to negative 8, right? Then it's going to be plus what? Plus 4a, then it's going to be plus 2b, right? Take the a to the other side, so it's going to be 10 plus 8, which is going to give us 18. So it's going to be 18 is equals to what? To 4a plus 2b. And this will give us what? Equation 1, right? So this is how the first equation will be found, right? So now we know the relationship between h prime, right, and the x-intercept. So that's what we're going to do. So we're going to substitute 2 is to 0, right, because that's the x-intercept, into h prime, right? So that's what we're going to do. So we're going to do what? We need to first find h prime. So h prime is going to be equals to what? It's going to be negative 3x squared, right? There's going to be plus 2x, right? So it's going to be negative 3x squared. Then it's going to be 2ax, right? Then it's going to be plus b. So substitute 2 is to 0. So it's going to be 0 is equals to what? Is equals to negative 3. Then it's going to be 2 all squared plus 2a. Then it's going to be 2 here. Then it's going to be plus b, right? Simplify that. We're going to get that 0 is equals to what? Is equals to negative 12, right? And then we're going to have what? We're going to have plus what? Plus 4a. Then it's going to be plus b, right? Take it to the other side. So it's going to be what? It's going to be 12 minus 4a, right, is equals to b. And this is going to be our second equation, right? So now what we're going to do is we're going to substitute 2 is into 1. So we're going to substitute 2 into 1, right? So when we do that, it's going to be 18 is equals to, wherever I see b, I'm going to substitute by this. So it's going to be 4a, right? So it's going to be 4a then it's going to be plus 2, then it's going to be 12 minus 4a, right? So now let's clean it up. It's going to be 18 is equals to 4a. Then it's going to be what? It's going to be plus 24 here. So it's going to be plus 24. Then it's going to be what? Negative 8a, right? 18 minus 24. So it's going to be 18 minus 24. It's going to give us what? It's going to give us negative 6. So it's going to be negative 6 is equals to what? It's equals to 4, right? Minus 8, which is going to give us negative 4. So it's going to be negative 4, right? So therefore, a is going to be equals to negative 6 divided by 4, which is going to give us what? 3 over 2. So it's going to be 3 over 2. So that's going to be a. So I'm just going to solve b here, right? So I'm going to say substitute a equals to 3 over 2, which is we got this one, which is nice, right? Into what? Into the second equation. So into 2, right? So if we say b is equals to what? To 12 minus 4, then it's going to be what? It's going to be 3 over 2. Place that into the calculator, you're going to get that b is equals to what? Is equals to 6, which is we got this. And that's how you would solve this question. So now let's do example 6, right? It says if a certain function, if the first derivative of the function, so they gave us the first derivative, right? They say if it's further given that f of x is equals to this, which is in terms of a, b, c, and d, and they tell us one important extra information. They tell us that f at 0 is equals to negative 6, right? Negative 18, sorry. So what's this? This is actually the y-intercept. And I'm going to just show you y is equals to the y-intercept. Remember to find the y-intercept. What do we say? We say let x equals to 0. So meaning we're looking for f at 0, right? And if we substitute 0, we're basically getting the y-intercept, which is negative 18. So remember again from our function, if it's in terms of a, b, and c, this d represents the y-intercept, right? So here we already found d because d is going to be equals to a negative 18. So we know that d is going to be equals to negative 18, right? So with that said, is that now we're going to, since we are given f prime like this, right? We're going to use this one. So we're going to differentiate this one and basically solve for a, b, and c, right? So that's what we're going to do. So we're going to take f prime of the one in alphabet, right? And then we're going to equate the coefficient of x squared, x, and 3 together to find a, b, and c. So here, when we differentiate this one, we're going to get the following. We're going to get 3ax squared, right? That's going to be plus 2bx. That's going to be plus c, right? So we know the fact that this one and f prime, the one that they gave us, is going to be equals to 3x squared, right? Plus 8x minus 3, right? So now we're going to equate these two together. This is a similar question that we have done. So we're going to equate those together, right? So let's do that. So we're going to have the following. We know the fact that 3a is equals to 3, right? So therefore a is going to be equals to 1, right? So a is going to be equals to 1. Then we know the fact that 2b is equals to 8. Therefore b is going to be equals to 4, right? Then here we know that c is going to be equals to negative 3, right? And remember the fact that we already know that d is equals to what? d is going to be equals to negative 18. So now let's rewrite this function f of x, this one, right? The cubic function, substituting a, b, c, and d. So let's do that. So f of x now is going to be equals to the following. It's going to be equals to x cubed because it's 1. Then it's going to be plus 4x squared, right? Then it's going to be minus 3x. Then the last one is going to be minus 18. And that's how you would solve this question. So now we're going to do example 7, right? It says sketch below is the graph, right? It's the graph f of x is equals to x cubed plus ax squared plus bx plus c, right? And it tells us the fact that the x-intercept of f at 3 is to 0, right? And they tell us that m, where m lies on the negative x-axis, right? So what do we see about m? We see the fact that m is two things. M is the turning point and also the x-intercept, right? And they tell us the fact that k is to 0 is to 3 is the y-intercept, right, which is there. Then they tell us that m and n are turning points, right? So if we have a question like this where our graph, right, one of the x-intercept is also the turning point, then this graph is basically it's in this form. So right, so this graph is basically in this form, which is going to be x minus, I'm going to say x1, right, all squared, and x minus x2, right? So this graph, right, is basically it's in this form like this, right? It's in this form. And so we're going to use this relationship, the fact that it's in this form, to basically calculate this function, right? So to determine the function f of x, right? So right now, what do we see? We see the fact that we have the x-intercept, which is going to represent x2. And here, remember the fact that x is going to be equals to 3. Therefore, the bracket there is going to be x minus 3, right? So here, I'm going to name this x-intercept here, or this x coordinate at mx, right? So I'm going to name it xm. Since it's in the negative, right? Since this is negative, it's going to be negative xm, right? So since it's negative, it's the same as saying the fact that x is equals to negative xm. So take it to the other side, it's the same as x plus xm, right? So this bracket here is going to represent the one with the square, right? I hope that makes sense. So now I'm going to rewrite this equation, right, in that form. And remember the fact that in our original function, right, they gave us a as being what? As being equals to 1. So we had a as being 1, right? So here it's going to be what? It's going to be f of x, right, is equals to what? To 1, right? So I'm not going to write it. So it's going to be x plus xm, right? And since at m is the turning point and also the x-intercept is going to get the square, then the extra coordinate, which is going to be what? Which is x minus 3, right? So now looking at our equation, looking at our function f of x, the problem is m, right? But that's nice because we already have k, right? So we can substitute k to find our m, right? So that's what we're going to do. So we're going to substitute k, right, which is 0 is to negative 3, right, to solve for xm, right? So that's what we're going to do. So we're going to have negative 3 is equals to, then this is going to be 0 plus xm, right, all squared. Then it's going to be what? It's going to be 0 minus 3, right? So this is going to give us what? This is going to be negative 3 is equals to just xm all squared. And this is going to be multiplied by negative 3. So divide both sides. So it's going to be divide both sides by negative 3. So it's going to give you a positive 1 is equals to xm all squared, right? So let me just write xm all squared is equals to 1. Square root both sides. So it's going to be xm, right, is equals to what? To plus or minus 1, right? So since it's plus or minus 1, remember the fact that m is on the negative x-axis. So xm here, it's basically equals to what? Is equals to negative, no, xm here, right? Remember the fact that we're looking for xm in this situation, right? You see the fact that xm here is positive, right? Not here. We're not looking at it in this form, but we're looking at it from the bracket. It was positive, right? So we need a positive xm. So xm is going to be equals to positive 1, right? So we know the fact that here, substituting xm, we're going to say positive 1. So it's going to be what? It's going to be f of x now is equals to what? To x plus 1, right? All squared. Then it's going to be x minus 3, right? Then we're going to expand it so we can look like this. So it's going to be f of x is equals to what? Is equals to, here it's going to be what? X squared plus 2x, right? Then it's going to be plus 1. Then it's going to be x minus 3. Take the minus x minus 3 bracket in front. So it's going to be f of x is equals to x minus 3. Then it's going to be x squared plus 2x. Then plus 1, right? Distribute the x and negative 3. So it's going to be f of x here is going to be equals to the following. Going to be x cubed, right? Then it's going to be plus x squared, 2x squared. Then it's going to be plus what? It's going to be plus 1x, right? then it's going to be minus what? It's going to be minus 3, then x squared, right? Then it's going to be minus 6x, then it's going to be what? Minus what? Minus 3, right? So let's clean that up. So f of x is going to be equals to what? To x cubed, right? Minus x squared. That's going to be minus 5x. Then it's going to be minus 3, which is going to be exactly like what they want from us. And that's how you would solve this question. So now we're going to do sketching, right? As you know, the fact that with sketching, you're going to need a couple of things so that you can sketch. So in our case, we're going to need the following. We're going to need the sign of A. Remember that the sign of A is going to give us the shape. Then we're going to need the intercept, both x and y intercept. Then we're going to need the turning point, right? So we have an example, says sketch f of x is equals to x cubed minus x, 3x squared minus 4, right? So remember the fact that the first thing that we're going to need is what? Is A, which is going to give us the shape. So I'm going to say for the first one, A, right? We're going to need A. In our case, A is equals to 1. Remember that A is the coefficient of x cubed, right? So it's going to be equals to 1, meaning it's greater than 0. Meaning roughly that the shape of this graph needs to look like this. Since it's what is greater than 1, meaning it's positive. So it's going to start by having a maximum, then having a minimum, right? So this is going to be the shape, right? So now we're going to do the second part, which is the intercept, right? So I'm going to say intercepts, right? So we're going to do the intercept. Then the first thing that we're going to look for is going to be the y-intercept, right? So it's going to be the y-intercept, right? And you can use the one that says let x equals to 0, which is the one that I'm going to use. Or you can use the one, the fact that the d value, right? In our case, we see the fact that there is no d value. It's actually equals to 0. So actually here, the y-intercept is going to be what? It's going to be 0 is to 0, right? Or you can use this one saying the fact that y-intercept let x equals to 0, meaning we're going to say y is equals to, wherever we see x, we put 0. So it's going to be 0 all cubed minus 3, then it's going to be 0 all squared minus 4. I'm just showing you another method, right? Then this is going to be 0, and you're going to get this as being 0, which is the same as what we got if we use the d value situation, right? So here we know that our y-intercept is going to be what? It's going to be 0 is to 0, right? So that's how you would find your y-intercept. So now what we're going to do is we're going to find the x-intercept. I just went to the next page because there isn't space here. So here I'm going to find the x-intercept, right? And remember the fact that to find x-intercept is what? Let y equals to 0. So in our case, our y is what? Is f of x. So it's going to be what? It's going to be 0 is equals to what? Is equals to x cubed, right? Minus 3x squared minus 4, right? Minus 4x. In this case, the nice thing is that every term has what? Has an x. So I can take out x as being a common factor. So it's going to be 0 is equals to x open bracket. It's going to be x squared, right? Minus 3x, then it's going to be minus 4, right? So this is what we have. So now I'm going to factorize this part. So it's going to be 0 is equals to x, open bracket, factorize this. You're going to have x plus 1, then it's going to be x minus 4, right? So now we know the fact that x is going to be equals to 0. So x is going to be equals to negative 1. Or the last one is x is going to be equals to positive 4. So the coordinate of the x-intercept jet is going to be what? It's going to be 0 is to 0, right? Then we're going to have negative 1 is to 0. And the last one is going to be 4 is to 0, right? So that's how you would find your intercept. So we're done with the intercept. Then the last part, what we're going to do is we're going to find the turning points, right? Also known as the stationary point. So number 3, we're finding turning point, right? Turning point, right? Remember to find the turning point is if prime is equals to 0. So let's find the first derivative. So it's going to be f prime, right? Of x is going to be equals to what? It's going to be equals to 3 3x squared, right, minus 6x, then it's going to be minus 4. Then we're going to equate this by 0 because we're looking for f prime is equals to 0. So it's going to be 0 is equals to 3x squared minus 6x minus 4. Then we're going to factorize this. So when we factorize it, we're going to have the following. Since we cannot factorize per normal, what we're going to use the quadratic, right? So let me just do this. Let me erase the 0, right? So it's going to be what? It's going to be x is equals to negative b plus or minus, then this is going to be the square root of b squared minus 4ac, right? And this is going to be divided by 2, right? Then we know the fact that here a is equals to 3, b is equals to negative 6, and c is equals to negative 4. So let's substitute. So we're going to have x is equals to minus open bracket negative 6. That's going to be plus or minus square root, right? Then it's going to be negative 6 all squared minus 4. Then it's going to be 3. Then it's going to be what? Negative 4, right? Then this whole thing is going to be divided by what? It's going to be divided by 2 multiplied by 3, right? Then now we're going to punish this whole thing by just adding the negative, right? So it's going to be x is equals to negative 0,53, right? Then we're going to substitute, put this in the calculator, but now adding what? Adding positive, so it's going to be x is equals to what? Is equals to 2,53, right? So this is the x coordinate of the turning point. Now we need to find the complete coordinate, so we need to substitute this one and this one into the original, which is f, right? Meaning here, right? So we're going to find f of negative 0,53, right? Which is going to be equals to, open bracket, negative 0,53 all cubed minus 3. Then it's going to be negative 53 all squared minus 4. Then it's going to be negative 0,53. Then you're going to get your answer here as being 1,13, right? So this is for 0,53. So the coordinate just going to be 0,53 is to 1,13, right? So now we're going to substitute 2,53. So it's going to be f for 2,53. Then it's going to be equals to 2,53, right, all cubed minus 3, then open bracket, 2,53, right, all squared minus 4, then it's going to be 2,53, right? And that's going to give us what? That's going to give us negative 13,13, right? So our coordinate here for another turning point is going to be 2,53 is to what? Is to negative 13,13. And these are your two turning points, right? So now we have our turning point, we have our intercept and our A, right? So now we can sketch the graph. So if we go to the next page, I'm just going to write everything that we need. Remember the fact that the y-intercept, I'm just going to write it here. Remember the fact that the y-intercept of 0 is to 0, right? This was the y-intercept, right? Then we have that the x-intercept was the following. It was also 0 is to 0, right? Then the other one was what? Was negative 1 is to 0. And the third one was 4 is to 0, right? Then we had our two turning points, which we had as 0,53 is to what? Is to 1,13, right? And we had another turning point, which is what? Which is 2,53 is to what? Is to negative 13,13, right? So that's what we have. And we know the fact that A is greater than 0, meaning our shape needs to look something like this. We need to start by having a maximum, then we're going to go to a minimum, right? So knowing all that, we can sketch our graph, right? So let's just sketch our graph. So I'm just going to draw a Cartesian plane like this, right? So I'm going to draw my Cartesian plane and we're going to put all important points, right? So we're going to start with the intercept, right? We know the fact that I'm just going to do it with a different color. So we know the fact that we have an x-intercept at 0, 0, right? Which is also the y-intercept. Then we have -1. So this is going to be -1. So there's a point here. Then we have 4. So this is going to be 1, right? So this is 0, this is 1, this is 2, this is 3, and this is going to be 4. So there's a point here, right? So where our point crosses is where our x-intercept is going to be. So we are done with this situation, right? So now let's deal with the turning point. Remember the fact that the first one was -0,53. So it's going to be somewhere here in between here. This is going to be -0,53, right? So it's to what? It's to 1. So 1,13. So it's going to be 1. And this is 2. So it needs to be somewhere here, right? So the turning point needs to be somewhere here. So this is the first turning point, right? Then the second one is 2,53. So it needs to be between 2 and 3. So it's going to be somewhere here, right? So it's to 13. So I'll just say 13 is here. So it's going to just go down like this. 13,13. So this is going to be 13,13, right? So this is a turning point. So your graph is going to go up and curve here, right? And it's going to go down and curve here. So let's do that. So let's connect. So it's going to go like this, right? Then it's going to go down. Remember the fact that it cuts through the x-axis. Then it comes down and like this. Then it cuts through at 4 like this, right? So now let's put our turning points to coordinate. We know the fact that this is 0,53 is to 1,13, right? And here's going to be 2,53 is to -13,13, right? So that's that. And here it's going to be what is -1 and 0. This is 0, 0, right? And this one is 4 is to 0. And this is how you would sketch your graphs. So now let's do example 2 under sketching, right? This is like kind of like a word problem, right? So it says, given that f of x is equals to what? F of x is equals to x, open bracket, x minus 3, all squared, right? And it says the fact that with f prime at 1 is equals to f prime at 3, which is equals to 0, right? What does this mean, right? So what does this mean, right? This, they gave us what? They gave us the x coordinate, right? So here they gave us the x coordinate of the turning point, right? So remember the fact that to find the, to find the x coordinate of the turning point, you need to find f prime, right? F prime of x is equals to 0. So here we already found x, what x was, right? So we saw the fact that for the first one is f prime at 1 is equals to 0, meaning here x is equals to 1. And the second one is f3, right, is equals to 0, meaning here x is equals to 3. So x equals to 1 and x equals to 3 are what? Are the x coordinate of the turning point. I hope that makes sense. Then here they tell us the fact that f1 is equals to 4. So they tell us the fact that f1 is equals to 4. Remember the fact that f1 is what? Is the x coordinate of the turning point. So this is the complete coordinate of the, so this is the complete, right, coordinate, one of it, right, of the turning point. Turning point, right? I hope that makes sense, right? So we know the fact that now we have a complete coordinate of the turning point, and we have, we have another point at 3, right? So with that said, now let's look at the equation, because the equation is going to tell us more information, right? Before we do that, let me just read the equation. It says, sketch the graph if, clearly indicate the intercept and the axis of the turning points, right? So now, if we look at our function f of x, right? So we're going to take a look at f of x, right? So we're going to take a look at f of x. We see the following, right? So if we take a look at f of x, and this x, if we find the x-intercept, right? So if we find the x-intercept, so find the x-intercept, right? We know the fact that this is going to be 0 is equals to x. This is already factorized, right? So this is going to be x minus 3, right? So this, our x-intercept is going to be x is equals to 0 and x is equals to positive 3, right? So our coordinate here is going to be 0 is to 0, and the other one is going to be 3 is to 0, right? So that's what we see, right? So we sorted if we find the x-intercept. Another thing with this equation, especially this type of equation, where it looks like this, right? If you have a value, then the other one is squared. It's a bracket, meaning x minus whatever number, right? All squared. This part that's in the bracket, and this part, do you see this part, right? Is very crucial because it means two things, right? So this gives us what? It gives us the turning point, right? The x coordinate of the turning point. So it gives us actually the turning point, not the x coordinate. The turning point, and also the x-intercept. So the x-intercept, right? So this 3 here, right? This coordinate here is two things. It's the x-intercept, as we know, right? And it's also the turning point, right? So we have two turning points now, right? And we know how do we have two turning points. Remember the fact that they told us again that f prime at 3 is equals to 0. So they already told us the fact that 3 is actually one of the turning point. I hope that makes sense. So to complete our points here, right? We have the turning point, right? So we have the turning point. So our turning point is going to be what? It's going to be 3 is to 0, as we know here. And we have, as in what here, it tells us the fact that it's 1 is to 4. So this here is going to be 1 is to 4, right? So, and 1 is to 4, right? Then we have our x-intercept here. And our x-intercept is going to be 0 is to 0. And we're going to have what? So it's going to be 0 is to 0. Then we're going to have what? We're going to have 3 is to 0, right? Then now, if you substitute, if we look for the y-intercept, it's going to be 0 to 0, because if you substitute 0 here, the whole thing is going to be 0. So this is going to be what? Our x-intercept here is going to be 0 is to 0, right? So we know the fact that, our y-intercept, if we substitute 0 at x, it's going to be what? It's going to be 0 is to 0, right? So here, if we substitute, our y-intercept is going to be 0 is to 0, right? And now let's look at the shape. So we know that a is equals to, do you see the fact that here it's a positive number, positive 1? So we see that 1, right, is a, which is greater than 0, meaning our graph needs to look like this, right? So we have all the information that we need to sketch this graph. So let's sketch the graph here. So now let's start with our intercept. We know the fact that it's going to go through, and let me just change my color. Right? It's going to go through here, right? Which is one of the x-intercepts. Then at 3, so it's going to be 1, 2, then it's going to be 3. So it's going to go through again here, right? And remember that 3 is also the turning point, right? So we are done with the intercept, and we're also done with the y-intercept. So we've sorted with that one, right? So now let's deal with the turning point. Remember the first one is 1 is to 4. So this is going to be 1, 2, 3, then 4 is here, right? So it's 1 is to 4, meaning it's going to be this point here, right? So this point is going to be 1 is to 4, right? So we have that. Then another turning point is what? Is 0 is to 3. So remember the fact that our graph goes up. So here it's going to go up. Then at 3 is going to curve and come down like that, right? So now let's connect the points. So it's going to be like this, right? So it's going to be like this. Then here it's going to curve. Remember that 3 is the x-intercept and also the turning point, and it's going to go like this. And this is going to be your graph for this question. So now we're going to move to point of inflation, right? So point of inflation, if they say the fact that determine the x-coordinate of point of inflation, right? And I'm also going to determine the entire coordinate, but let's just answer this first part. Is it what you're looking for, right? Just remember this, point of inflation means the following. Let me just take my pen. This, right, just means the fact that you're looking for the second derivative, right? And we're going to equate it to 0 and so for x. That's what it means, right? So in our case, since our graph is in terms of g, so it's going to be g of x is equals to negative 2x cubed minus 3x squared plus 12x plus 20, right? So we're looking for first the first derivative of that. Remember the fact that we need to find the second derivative. So it's going to be the first derivative. And when you find the first derivative, it's going to be negative 2x, right? So it's going to be, sorry, did a mistake there. I haven't differentiate anything. So it's going to be the following. It's going to be negative 6x squared, right? Minus 6x, right? Then it's going to be what? Plus 12. So this is for the first derivative. Then the second derivative basically is taking this one, right, and differentiating it again, right? So it's going to be negative 6 multiplied by 2, right? Then it's going to be what? It's going to be 2 minus 1, right? So you're taking this first derivative as being the original function, so you can differentiate it again, right? So this is going to be minus 6, then multiplied by 1, right? So it's going to be x, 1 minus 1, then this one is a constant. So when we simplify this, it's going to be what? It's going to be the following. It's going to be negative 12x, right? Then it's going to be minus 6, right? So this is going to be, we need to equate it by 0. So it's going to be 0 is equals to negative 12x minus 6. Then take the negative 12x to the other side. So it's going to be 12x is equals to negative 6, right? So therefore, x is going to be equals to what? X is going to be equals to negative 6 divided by 12, which is going to be negative 1 over 2, right? So this is the x coordinate of the point of inflation. So if they say they want the full coordinate, right? Coordinate. What you're going to do is you're basically going to take this x, right, and substitute it back into the original. Remember that we're dealing with g, not with f. So you're going to take this x and substitute it back here, right? So it's going to be g add negative a half is equals to what? Is equals to negative 2 open bracket negative 1 over 2 all cubed, right? Minus 3, then open bracket negative 1 over 2 all squared, right? Plus 12 negative 1 over 2, then it's going to be plus 20. Punch that into the calculator. So you're going to have negative 2 open bracket negative 1 over 2, right? Then this is going to be all cubed first. Then it's going to be minus what? Minus 3. Then negative 1 over 2, right? All squared plus 12. Then it's going to be negative 1 over 5, right? Then it's going to be plus 20. Then it's going to give you what? It's going to give you 27 divided by 2. So our complete coordinate of the point of inflation here is going to be what? Negative 1 over 2 is 27 divided by 2, right? So this will be the complete coordinate for this point of inflation. I hope that makes sense. So now we're going to move to concavity, right? Concavity needs the point of inflation, right? So to find when something is concave up or concave down, we need the point of inflation because of that's where it divides our graph from going up or from being concave up and concave down. So to understand this whole concept, first you need to find what? So first, if they ask you to find whether something is concave up, concave down, remember the fact that first, right? So let me just write it down, right? First, find, right? The point of inflation. So your answer needs to be in terms of this point of inflation, right? So let's do that. So we're given that f of x is equals to what? To this, so I'm just going to substitute any B, and C. So it's going to be the same as f of x here. It's equals to negative 2x cubed, right? Then it's going to be plus 21 x squared. Then it's going to be minus 60 x. Then it's going to be plus 43, right? So first we need to find what? We need to find the point of inflation. So it's going to be the first derivative for this, which is going to give us the following, which is going to give us negative 6, right? So it's going to give us negative 6 x squared, right? Then it's going to be plus 42, right? X, then it's going to be minus 60. Then we're going to find the second derivative, right? Which is going to give us what? Which is going to give us negative 12x. Then it's going to be plus 42. Equate this by 0 because we need to find the x coordinate, right? We don't need the complete coordinate. We just need the x coordinate because our answer needs to be in terms of x. So it's going to be negative 12x plus 42. Take the negative 12 to the other side. So it's going to be 12x is equals to 42. Divide both sides by what? Divide both sides by 12. So x is going to be equals to 3,5, right? So this, our answer is going to be between 3,5. So 3,5 might be somewhere here, right? Just going to estimate it. So it's going to be somewhere here, right? So this is going to be 3,5. It's going to be somewhere here, right? So this 3,5, this point of inflation is the one that divides our graph from being concave up to concave down, right? Do you see this portion here? Let me just take my highlighter. Do you see this portion here? Our graph is concave up. How do we know the fact that it's concave up? Do you see the fact that it's up? Do you see the fact that this part is up? Do you see that? So it's going to be concave up, right? And then the second portion of it, which is, let me just highlight it. The second portion of it, which is this one, right, is going to be considered concave down, right? So this point here is going to be considered concave down, right? So how do we write our answer, right? So for the first one, right, it says for which values of x will f be concave up, right? So do you see the fact that we start from negative infinity till positive infinity, right? So from negative infinity till the point of inflation, right? Do you see the fact that our graph is concave up, right? So we know the fact that x, right, is an element, right, from where? So we're dealing with concave up, right? So it's this one. So it's going to be from negative infinity, right, till what? Till 3,5. So that's going to be considered as being what? As being concave up. So this is concave. And you can see by the dome how it looks. The yellow one looks up and the green one looks down, right? So this will be considered as being concave up, right? Then number 2 is from 3. So it's going to be x is an element from 3,5, right, till positive infinity. And that will be considered concave down, right? So that would be considered concave down, right? So let me just highlight it. So we know the fact that the green one is for concave down and the yellow one is for concave up, right? So that's how you find concavity of concave up and concave down. So now example 2, it says, given that f of x is equals to x open bracket x minus 3 all squared, right? They say 8.3 for which values of x, right? Well, y equals to negative f of x will be concave down, right? So we need to find the equation y, right? Because do you see the fact that they gave us y in terms of like negative x? So let's find that. Then after finding that, we need to find the point of inflation because that's where it divides our graph of being concave up to concave down. Then we can answer the question, right? So the first thing is that we need to rewrite f of x in terms of individual terms. So let's expand this, right? Before we look for y. So let's do that. So it's going to be f of x first is equals to what? Is equals to x open bracket x minus 3, right? This is going to be all squared, right? So we know the fact that now f of x is going to be equals to what? Let's expand x minus 3 all squared. So it's going to be x open bracket, it's going to be what? It's going to be x squared, right, minus 6x, right? Then it's going to be plus 9, right? Distribute the x, so it's going to be f of x is going to be equals to what? To x cubed, right? Minus 6x squared, that's going to be plus 9x, right? So we have expanded this. So now we're going to look at what they want from us, which is y. So we see that y is equals to what? To negative f of x, right? So whenever I see f of x, I'm going to substitute by this. So it's going to be y is equals to negative open bracket x cubed, right? Minus 6x squared plus 9x, right? So we have that, right? Then after that, I'm just going to distribute the negative. So it's going to be y is equals to what? To negative x cubed plus 6x squared. And it's going to be minus 9x, right? Remember the fact that if we're going to talk about concave up or concave down or concavity in general, we need to find what? The point of inflation. And how do you find the point of inflation? In our case is finding y double prime, right? So let's find the first derivative of this function. So it's going to be y prime, right? Is equals to what? It's equals to negative 3x squared, right? Plus 12x, right? Then it's going to be minus 9. So find the second derivative. Remember the fact that this is equated to 0, which is going to get the following, which is going to be negative 6x, right? Then it's going to be plus 12. Then equate this by 0. So it's going to be 0 is equals to negative 6x plus 12. Take the 6x to the other side. So it's going to be 6x is equals to 12. Therefore, x here is going to be equals to what? It's going to be equals to 2. So this is our point of inflation, right? So now we need to understand where is it concave up or concave down. What do we need? We need to know the shape of the graph, right? So the shape of the graph from our equation, right? Remember the fact that we're looking for concavity of y. So we need to look at this one, not the f of x, but this one, right? Because that's what we're looking for. We're looking for concavity for this one, right? So we see the following. We see the fact that in here, a, right, is equals to negative 1. Meaning if a is equals to negative 1, meaning it's less than 0, meaning our shape is going to look like this, right? Our graph is going to look like this. It doesn't need to be perfect. You just need to know the shape, right? So I'm just going to draw a rough sketch. It's going to look like this, right? No. This is for when it's positive. Remember the fact that it needs to start from minimum. So let me take my eraser. It needs to start from minimum than maximum. So let's do that. Did a mistake. So it's going to look like this, right? So our shape is going to look like this. Minimum, then maximum, right? So remember the fact that concavity, what you call this point of inflation, divides when the graph goes from being a minimum to a maximum or a maximum to a minimum. So let's say the point is here, 2 is here. It really doesn't matter. You just need to mark it where it is, right? Do you see the fact that here, right? So this highlighted part, let me just highlight it. This portion right here, remember the fact that we're looking for concave down. Do you see the fact that this portion here is going to represent concave down, right? So from 2, right, from 2 till positive infinity is going to represent concave down. So with that said, our answer is going to be what? It's going to be the following. It's going to be when x is an element from 2 till positive infinity, because that's where it represents concave down. So that's how you would answer this question. So now let's do this question. It's a little bit different from what we've been doing. In this case, they gave us just f prime and not the original function, and they want us to find concavity, right? So it says for a certain function f, the first derivative is given as f prime is equals to 3x squared plus 8x minus 3. Then they say for which values of x will f be concave down, right? So now, remember the fact that concavity, what do we need? We need our point of inflation. So here the nice thing is that they gave us the first derivative, so we just need to find the second derivative, right? So it's going to be the second derivative. Then we're just going to differentiate this, which is going to give us what? Which is going to give us 6, right? X minus going to be plus 8, right? So after doing that, it's going to be 0 is equals to 6. X plus 8. Take the 6x to the other side, so it's going to be negative 6x. is equals to 8, then it's going to be x is going to be equal to what? To negative 4 divided by 3, right? So this is our point of what? Of inflation, right? Now we need to know how the graph looks so that we can know when the graph changes from being a maximum to a minimum or a minimum to a maximum, right? So what we're going to use the information from this one, right? So let me just do this, from, right, f prime, right, we know the fact that a here, and this is a quadratic, right? We know that a is equals to positive 3, right, which is greater than 0, right? So from that, we know the fact that since a is greater than 0, therefore, we can conclude that f prime is going to take the same a, right, in terms of sign, not the actual value. So we know the fact that in terms of sign, a is also going to be greater than 0, meaning our graph is going to look like something like this. So it's going to start from maximum to minimum, right? So it's going to be something like this. Our graph is going to be something like this, right? So this is our graph. And our point of inflation is going to be like this one here, which is going to be negative 4 over 3, right? So this point is going to be negative 4 over 3. Then remember the fact that we're looking for when it's concave down. This section here represents when it's concave down, right? So our answer is going to be what? It's going to be from negative infinity till negative 4 over 3. So our answer here is going to be x is an element from negative infinity till negative 4 over 3. And that's how you would answer this question. Just remember the fact that if they give you the first derivative, is that whatever sign that this a takes is going to be the same sign, not the value that the cubic function is going to take. And that's what you're going to use to basically sketch your graph to know when it's changing from being a maximum to a minimum. I hope that made sense. So now let's look at example 4, right? So it's a sketch, as we can see, but what's important is the question. It says the graph h is concave down for when x is less than k, right? And even if we didn't know what k is, looking at the sketch, is that we know the fact that concave down is this portion, right? So it's going to be somewhere here. So the k value is somewhere here, right? So the k value is somewhere here. This is going to be the k value, right? So with that said, we know the fact that this is from negative infinity till k. And negative infinity till k means this and negative infinity. So this and from x is an element from negative infinity till k, it's exactly the same thing, right? I write it like this because it's easy for students to understand, right? So I don't write it like the inequality one because it confuses a lot of people, right? But this and this, right, is the same thing. So if you're looking at the memo doing a past paper and you see this answer, just know the fact that you're correct. There's nothing wrong with your answer, right? So now what do we see? We see the fact that k is what? K is actually what? The point of inflation, right? So they say calculate the value of k. Do you see the fact that we just need to look for the second derivative and equate it to 0, right? It's going to be h of x, remember? In our case, h of x is equals to what? It's equals to x cubed, right? So it's this one, x cubed, right? Minus 7x squared. Then it's going to be plus 14x. It's going to be minus 8, right? So it's going to be the first derivative of this. So it's going to be what? It's going to be equals to 3x squared, right? Minus 14x. That's going to be plus 14, right? So it's going to be the double prime because we're looking for point of inflation. It's equals to 6x. That's going to be minus 14, right? So therefore, it's going to be 0 here is equals to 6x minus 14. So therefore, we're going to have what? We're going to have negative 6x is equals to negative 14. Since they both negative, so it's the same as 6x is equals to 14. Divide both sides by 6. So it's going to be x is equals to what? 7 divided by what? 7 divided by 3. Remember the fact that k, as I said, is the point of inflation, and this x is also the point of inflation. So therefore, we know that k is equals to what? To 7 divided by 3. So that's how you would find the value of k. So now example 5, I'm not going to read the details. I just want to look at the question. It says is the graph concave up or concave down at the point 0 to 20? So I'm gonna highlight that point. The 0 to 20 is this point, right? So they're asking us, is the graph under the concave up or under the concave down at the y-intercept, right? So how to determine whether it's concave up and concave down? We need to first find the point of inflation, right? So that's what we're going to do. So we're going to do the following. We know the fact that g of x is this one. So we're going to look for the first derivative of that, which is going to be equals to what? It's going to be equals to 3x squared, right? Plus 2x. That's going to be minus 16. Look for the second derivative, right? Because we're looking for the point of inflation. So it's going to be 6x, right? Then it's going to be plus 2, right? Then it's going to be 0 is equals to 6x plus 2. Take the 6 to the other side. So it's going to be negative 6x is equals to 2. Divide both sides by 6. So x is going to be equals to what? To negative 1 over 3, right? So where is negative 1 over 3? It needs to be here, somewhere here. So this is what? This is negative 1 over 3, right? So this is where the graph changes from concave up to concave down, right? So do you see the fact that I'm just going to highlight it? Do you see? Let me just take my highlighter. Do you see from this portion here, right? This green part, right? Do you see the fact that that represents what? That represents concave down, and this portion here, do you see the fact that it represents concave up, right? So let me just write it. This one represents yes. So this one represents concave down, right? And this one represents concave up. Do you see the fact that the point 0 to 20, this y-intercept is part of the blue graph? So therefore, it's part of concave up. So this point here is part of concave up because of it's part of the blue portion, right? I hope that made sense. So now we're going to do example 6, right? It says, given that h of x is equals to negative x cubed plus 3 divided by 2x squared plus 6x, right? Then they say the fact that shown that the concavity of h changes at x is equals to 2, right? So this in basic terms, right, we just need to do the following. We need to basically explain where it's concave up and concave down. But first we need to basically show the fact that the point of inflation is equals to 1 over 2. Then after that, explain the portion that is concave up and the portion that's concave down, right? So let's do that. So first we need to find h of x, right? So we know the fact that we need to find h prime of x. So that's going to be equals to what? It's going to be equals to negative 3x squared, right? Then it's going to be plus 3x, right? Because it's going to be 2 multiplied by 3 divided by 2, which is going to give you 3. Then it's going to be plus 6, right? So now we're going to find the second derivative, which is going to give us the following, which is going to be negative 6x, right? Then it's going to be plus 3, right? So this is going to be 0 is equals to negative 6x plus 3. Then take the negative 6 to the other side. So it's going to be 6x is equals to 3. Divide both sides by 6. So it's going to be x is equals to 1 over 2. So we have shown the fact that x is equals to 1 over 2, right? So now let's sketch the graph, right? Let's sketch this graph so we can understand where it's concave up and concave down, right? Since here a is what? A is negative. So we see the fact that a is equals to what? To negative 1, meaning it's less than 0, meaning our graph is going to look something like this. So it's going to look something like this. Remember the fact that you don't need intercept, you just need the shape. So since it's negative, it's going to start from minimum going to maximum. So it's going to be something like this, right? So let me just do this. This is negative infinity. This is positive infinity, right? And our half is going to be somewhere here, right? So this is going to be 1 over 2. This is where the graph changes. Let me just do it with a different color. This point is where the graph changes from concave up and concave down. So the question wants us to explain why the graph is concave up and concave down, right? So we know the fact that this portion represents concave up, right? And we know that this portion is going to represent concave down, right? So let's explain that. Let's write it down, right? So we're going to say, it's fine. Let me just write it with it. So I'm going to say 4, right, x, right, from x till negative infinity till 1/2. We know that h is up, right, is concave up. So that's your answer. Then we know 4x, right, from a half till positive infinity. So x is from a half till positive infinity. We know that h is concave down. And that's basically your answer for this question. So now we're going to move to inequality, right, under cubic functions. So the first one says, given that f of x is equals to, they give us, then they tell us the fact that they're looking for when x, right, multiplied by f prime is less than 0, right? So here, the easiest way to basically do this equation is to first sketch out roughly a sketch of this one, right, from f prime. What do we know the relationship between the cubic graph and f prime? Remember the following. So let me just take my different color. Remember the following, right? Remember that the x-coordinate, right? The x-coordinate of the turning point of the turning point, right, is the what? Is the x-intercept, right? So it's the x-intercept. So it's the x-intercept of f prime. This relationship is going to be very important for this question, right? So now what we're going to do is that we're going to draw f prime, right? And we're also going to draw x, right? So this x is the same as saying y is equals to x. This x is represented by y is equals to x. So let's do that, right? So let's sketch that. So let's sketch f of f prime, right? That's why we have the sketch here. So we're going to have the following. Do you see the fact that our x-intercept for the turning point is -1/3 and 3? So it's going to be somewhere here. It's going to be -1/3 and 3 is going to be here. So this is 1, this is 2, and this is 3. So 3 is going to be here. And since this, do you see the fact that that's called by going up then going down, meaning this a is greater than 0, and we see the fact that here a is equal to +1, right? So this is going to be a smiley face. So our graph is going to look like this. Right? So our graph is going to look like this. This is f prime, right? So now we're going to draw what? We're going to draw, and I'm going to change my color. I'm going to draw y is equals to x, which y equals to x represents this one. So it's going to go through like this. So it's just going to be a positive line. Under functions, I've done a similar question like this, right? What we're doing right now is similar to what we did when we did functions. So this is going to be the graph that you're going to be answering your question, right? So now remember the fact that x multiplied by f prime of x is less than 0 means the following, right? It means we're looking for when the red graph is positive, then multiply it. Remember, less than 0 means negative. Multiply it by what? Meaning this one needs to be negative. Then we're going to get a negative, right? Or this one can be negative. This x can be negative, right? Then this one is going to be positive, meaning when we multiply, we're going to get a negative. So we're looking for what? When we multiply the two y, right? The two y-x's. Remember, this is y positive and this is y negative, right? We're looking for when we multiply when one of them is in the negative y-axis and the other one is in the positive y-axis. But since our answer needs to be in terms of x, we need to divide our graph in terms of the x values, right? So here we need to mark out the intercepts, right? So the intercept that we're going to mark here, remember the fact that the y prime has at here, this is the x-intercept, and y is equals to 0, y is equals to x, right? Has the y-intercept here at 0, 0, right? Then there's another here, y-intercept, right? X-intercept, sorry. So this is going to be the first portion, this is going to be the second portion, this is going to be the third portion, and this is going to be the fourth portion, right? So we're going to basically look at our portions and check, do they satisfy this part? From negative infinity till negative 1/3. Do you see the fact that the blue graph is at the top and the red graph is at the bottom? Do you see the fact that one is in the positive y-axis and the other one is in the negative? So this satisfies our condition here, right? Then do you see at negative 1/3 till 0, both of them are in the negative, so this side does not satisfy. Then from 0 till positive 3, one is in the positive, then the other one is in the negative, so this satisfies. Then this red continues and extend. Then from 3 till positive infinity, do you see the fact that both of them are in the positive? So this one does not satisfy, right? So I'm going to highlight the portion there it satisfies. So let me just highlight. This is the portions where it satisfies. So it's going to satisfy this portion here, right? Where I marked it off, put a tick. Then and also this portion here. So that portion that I'm just highlighting is going to be where your answer is going to lie, right? I hope that makes sense, right? So our answer here is going to be what? It's going to be, let me just change my pen. It's going to be when x is an element from where, since it's less than it's not equals to, so it's going to be from negative infinity till negative 1/3, right? Till where, or not till where, or it's going to be from 0 till 3. And this is how your answer would look like. It's going to be from the yellow portion from negative infinity till negative 1/3, then from 0 till 3. And this is how you would do this question. Remember the fact that it's very crucial to draw this graph so that you can basically get it, and use the same method that we use under inequality when we did when we did functions under quadratic. This and that method is exactly the same thing. The only thing that you just need to understand is that you need to know on how to sketch this, and it's very simple because of you just drawing this is just a quadratic function, right? You're just drawing quadratic function and putting a line and answering it the exact same way that you did under functions in inequality. So now we're going to do example 2, right? Example 2 says for which values of x is g of x, which is the one that we have here is g of x, multiplied by g prime of x, right? Is less than 0. So here what we need to do is that we need to sketch this one on top of this one so that we can answer the question, right? So we know the fact that the relationship is that here, this 0 is going to be the y-intercept, the turning points, the the x coordinate of the turning points, right, is going to be the x-intercept for g prime. So I'm just going to draw a dotted line, right, so we can know where the g prime is going to cut, and it's going to cut here at 14 divided by 3, right, so it's going to cut here. Then here it's 0 and 36, so it's going to cut here. So it's going to cut here at 0, right? So it's going to cut here at 0, right? So our g prime, since g of x is positive, it's going to be a smiley face. So it's going to cut here and cut there, right? So it's going to go like this. It's going to go like this. Right? It's going to go like this. So here we're looking for when g of x, right, which is the original, the one that's already sketched, multiplied by g prime of x, which is the one that I just sketched, is less than 0. So I'm looking for when one is in the negative and the other one is in the positive, because less than 0 means negative. So I'm looking for when this one is negative, meaning this one needs to be positive, right? Because a negative multiplied by a positive is going to give you a negative. And if this one is positive, then this one needs to be negative. because negative and positive is going to give you negative, right? So I'm looking for when they're in different, different y-axis, right? But first we need to divide our graph in the y-intercept. So here this at 2, right? Here at 3, and also here at 6 are my y-intercept for the cubic. Then at 0 and 14/3 is the y-intercept for the g prime, right? So let's divide the portions so that we can write our answer and divide the section so we can evaluate it first. Then here at 0, because it's for the g prime. Then here at 3. Then here at 14/3. Then here at 6. So we have 1, 2, 3, 4, 5, 6 portions, right? And it's from negative infinity till negative 2, from 2 till 0, from 0 till 3, from 3 till 14/3, then from 14/3 to 6, then from 6 to positive infinity, right? So remember the fact that I'm just going to highlight so that we can see it properly. I'm just going to highlight it. So it's going to be, the cubic function is going to be the yellow one. Remember the fact that I'm looking for when they're in different y-intercept, right? So this is going to be like this. Then the other one is going to look like this. So I'm looking for when one is in the yellow and the other one is in the green, right? So that's what I'm looking for. Then this one is going to extend like this, and also this one extends, right? So now let's answer the question, right? So I'm just going to take where is the correct answer and put across where it's wrong, right? From negative infinity till negative 2. Do you see the fact that the green is in the positive y-axis while the yellow is in the negative? So this one satisfies because of we need when it's different sides. Then from negative 2 till 0, do you see the fact that they're both positive? So this does not satisfy. From 0 till 3, green is on the negative y-axis while the yellow one is in the positive. So this satisfied. From 3 till 14/3, do you see the fact that they both in the negative? So this does not satisfy. Then from 14/3 till 6, do you see the fact that green is on top and the yellow one is on the negative? So this satisfied. But from 6 to positive infinity, this does not satisfy because they both in the positive y-axis, right? So I'm just going to highlight where our answer is, right? So I'm just going to take my highlighter. Our answer is going to be here, right? So answer is going to be here. Then our answer is going to be also here. And our answer is going to be here. Right? So let's write our answer. So our answer is going to be x is an element from negative infinity till negative 2, right? Or, right, it's from 0 till 3. Or the last portion is from 14/3 till what? Till 6. And this will be how you would answer this question. Now let's do example 3. It says we're looking for when f of x, right, is less than 0, meaning we're looking for anything that is when f of x is in the negative x-axis, right? So we're looking for when f of x is in the negative, so this portion here, right? So this is the internal portion, right? So this is the entire portion. Remember the fact that we need to write our answers in terms of what? In terms of x, right? So now we need this x coordinate. Let me just write it down because this is going to be -1 and 0, right? So our answer, do you see the fact that our graph is in the negative from negative infinity till here 3? Because from 3 going up, right, do you see the fact that it's in the positive? So our answer here is going to be x is an element from negative infinity till 3, but x cannot be equals to -1. the reason why x cannot be -1, remember the fact that here, f prime of x, right? F prime of x is the same as we're looking for when the graph is in y, when f of x, so this is the same as when f of x is in the negative, right? Negative y-axis, right? Do you agree the fact that here at -1, right, the y is equals to 0? 0, right, is not positive or negative. So at this point here, when y is equals to 0, y is not positive or negative. So our answer cannot exist at that point. Because remember that the y-intercept, the y-coordinate for -1 is 0. And 0 cannot be what? Positive or negative. So that is why it's from -infinity till 3, but this does not satisfy this point here at x is equals to -1. I hope that made sense. So now we're going to move to extra questions, right? So let's look at the first one. It says that given that f of x is equals to 3x cubed, right? And the first question says, solve for when f of x is equals to f prime, right? So this is 9.1, right? So we need to first find f prime, then equate f of x with f prime. So let's do that. So f prime, in our case, is going to be equals to what? It's equals to 9x squared. So we're going to look for when f of x is equals to f prime, which is going to give us what? Which is going to be 3x cubed, right? Is equals to 9x squared, right? Then what I'm going to do is I'm going to take this 9x squared to the other side. So it's going to be 3x cubed, right, minus 9x squared is equals to 0. Then we're going to take out 3x squared as a common factor. So it's going to be 3x squared. Then you're going to have what? You're going to have x minus what? Minus 3 is equals to 0. Then here's the same as 3x squared is equals to 0. Or it's going to be x minus 3 is equals to 0. This one is the same as x squared is equals to 0, right? Divide both sides by 3, which is going to give you 0, which is x squared. When you square root 0, it's going to give you 0. So this is going to be the same as x is equals to 3. Then here it's going to be x is equals to positive 3. And this will be your final answer for this question, right? Then it says, for the second point, it says what? It says the graph f and f prime and f double prime, right? What you call this, passes through the point 0, 0, right? Then the first one says, for which of the following will 0, 0 be a stationary point? So the two, right, that are going to have stationary point is the following. So it's 4 for 9.2, so 9.2.1. It's going to be for f, right, and f prime, right? So remember the fact that both f and f prime have turning point. So remember that, remember that f and f prime have turning points. And f double prime is a linear function, so it does not have a turning point, right? So that 2 is going to have turning points, right? Then the next question, which is 9.2.2, it says, explain the difference, if any, if the stationary points referred in 9.2, right? So the following is that at the point, right? So at the point 0, 0, right? Looking at this graph, right? At the point 0, 0, is that the following is going to happen. If you had to sketch this graph, right, it's going to be like this. So it's going to be something like this, right? So the concavity, right, or the point where it changes from local minimum to local maximum, it's here at 0, 0, right? So this point here, 0, 0, is actually where concavity happens is also known as the point of inflation, right? So at 0, 0, right, is what? This is the point. This is the point of inflation of what? Of what? Of f, right? And it's also the turning point. So that point also, right, it is also the turning point of what? Of f prime. And let me just show you why it's also the turning point of f prime, right? If now I had to sketch this one, right? Do you see the fact that our graph, since it's not moving left or right, it doesn't have P and Q. Our graph is going to just look like this. Do you see the fact that that's where the turning point is? So that is why we're saying it's the point of inflation for f, and it's also the turning point for f prime. I hope that made sense, right? Then 9 point, let me just go to the next page because I don't have space. So 9.3 says determine the vertical distance between f prime and f double prime. So we already have f prime, remember? So f prime, we already have it as 9x squared, right? So now we need to look for our f double prime and find the vertical distance, right? And what is the vertical distance? The vertical distance between these two is basically the following, right? It's basically f double prime, right? At what? At 1 minus what? F prime at 1. So this is the vertical distance. This is the vertical distance, right? So this is the vertical distance. So we need f double prime to basically solve this question, right? So f double prime is going to give us the following. It's going to be equals to what? To 18x, right? So it's going to be the same as what? This is the same as, remember that vertical distance, as I said, is going to be equals to f double prime, right? The end one minus the one that's before, right? So it's going to be f double prime minus f at 1, which is going to be the same as what? This one is going to be 18, open bracket 1 minus 9, 1 squared. Punch that into the calculator. You're going to get that your vertical distance is going to be equals to 1, right? And then this was 9.3. And now we're going to move to 9.4. It says, for which values of x? Well, f of x minus f minus x, which is, do you see the fact that it's going to be, if you take this one, remember the fact that it's f of x minus f of x is equals to f prime. You can rewrite it as f of x minus f prime is equals to 0. So this can be rewritten as this one, right? So the fact that it's less than 0, this is inequality, right? So this is the same as we're looking for when f of x minus f prime of x is less than 0, right? So this, we already solved it, and we had the following. We had that 3x squared, open bracket x minus 3, right, is what? Is less than 0. Do you see the fact that this is squared? This x is squared, meaning here at 0, at point 0, right, is the x-intercept, and it's also the turning point because the x is squared, and it's also the turning point, right? So if we had to do just a rough sketch of this, right? So our graph would look like this. It would look like this here at, since it's positive, so it's going to be maximum. Then it's going to go like this. So this is going to be 3, and this is going to be 0, right? We're looking for when this is less than 0, meaning we're looking for when the y, this represents y, right? When the y-axis are basically, we're looking for when the graph is in the negative y-axis. So we're looking at this, right? So our answer here is going to be what? It's going to be from negative infinity till 3. So our answer is going to be from negative infinity till 3. But since here, this turning point, right, Do you see the fact that the turning point and the x-intercept is like the similar question that we did, this one, right? Our graph cannot exist at that point. So, but x cannot be equals to 0. So now let's do example 2, right? It says a cubic function has the following properties. So let's look at the properties. It says f of a half, then f of 3, then f of -1 is equals to 0. This is what? This are the x-intercepts, right? So let's write the coordinate. It's basically 1 over 2 is to 0. That's the first one. The other one is 3 is to 0, right? And the last one is -1 is to 0, right? So now the second part says what? Says f prime is equals to 2, right? Is equals to f prime at -1 over 3, then is equals to 0. These are what? Are the x coordinate of the turning point, right? So here, this is the x coordinate of the turning point. So it's going to be x is equals to 2 because we don't know the y. And also we have x is equals to -1 over 3. Then it tells us that the graph decreases between what? Between -1 over 3 and 2. So meaning it decreases, meaning the graph is going to go down like this, right? From -1 over 2. So from -1 over 2, -1 over 3, and 2. That's what they mean, right? So meaning -1 over 3 is going to be the maximum and 2 is going to be the what? It's going to be the minimum. So the graph is going to go like this, right? So this is how the situation looks, right? So it says draw a possible sketch of what you call this of if and clearly indicate the x coordinate, right, of the turning point and all the intercepts. So let's just draw a live sketch. So like this, let's mark first the x-intercept, right? So we know the fact that the x-intercept is a half. So it's going to be 1, and then 2, then 3. Then here it's going to be -1, right? So let's mark them. So I'm going to mark them in red. So here at -1, right? Then it's going to be a half, which is between what? Between 0 and 1. So it's going to be here, right? Then it's going to be 3. So it's going to be here. So this is where the graph is going to cut, right? Then remember the x, the x coordinates of the setting point is going to be where? So the first one is at -1 over 3. So that one is going to be the maximum. So it needs to be somewhere here. This is -1 over 3. Then the other one is at 2, which is going to be here. This needs to be the minimum, right? So this is how it's going to be. So this is going to be 2. So we know the fact that the graph needs to curve here and it's going to curve here. So let's just connect everything. So the graph is going to go like this. So this is the sketch. So this is how the graph will look. So now let's do example 3, right? It says sketch below is the graph f of x is equals to open bracket x minus 2, then all squared, right? So then it's going to be x minus k, and g of x is equals to what? To mx plus 12. Then they tell us the fact that a and d are the x-intercepts. So a and d are the x-intercept of f, right? And they tell us the fact that b is what? Is a common y-intercept. So we see the fact that b is the common y-intercept. And they tell us that c and d are the turning points, as we can see. And they tell us that the straight line passes through a, right? So 8.1, right, says write down the coordinate of b. Remember the fact that f of x and g of x share what? Share the y-intercept. Meaning now my b coordinate, right, the x-intercept for it is going to be what? It's going to be equals to the y coordinate. The y coordinate is going to be equals to what? It's going to be equals to 12 because this point is going to be 12, right? I hope that made sense because of f of x and g of x share the same what? The same y-intercept. And if we have a straight line, this point C is actually the y-intercept, which is going to be 0 is to 12, and this is going to be the y coordinate. Hope that makes sense. Right? Then now we're going to move to 8.2. They say calculate the coordinate of 8, right? Since we have this as being what? As being 0 is to 12, right? And we already know this one. Remember the fact that this is in the form of when one of the x-intercept is also the turning point. So this point is 2 because of, do you see the fact that this is the x-intercept and it's also the turning point? And this point K here, right? Or this point A-intercept is here, which is the point K, which is going to be the same as what? As negative K, right? So this is the point here, right? So this point here represents this one. This one represents this one, right? So this point here is this one here, right? So now what we need to do is that we need to calculate what? We need to calculate this point here, K, right? But I'm not going to name it K because of here that K is negative, and it might confuse us in terms of the final answer. So I'm going to name it XA, right? Then I'm going to relate it back here. So I'm going to name it XA. But remember that XA is in the negative. So this is going to be negative XA, right? So I'm going to rewrite this function, putting XA, right? So I'm going to say f of x, right, is equals to, open bracket, x, then it's going to be minus 2 whole squared, then it's going to be x plus XA, right? Then now, remember the fact that we have the y-intercept, so we can substitute that 0 is to 12 here to basically calculate what? This XA. So let's do that. So it's going to be f, right? So what I'm going to do is substitute, right? So I'm going to substitute what? We're going to substitute 0 is to 12 to basically solve for XA, right? Because remember that XA is related to this K. So let's do that. So it's going to be 12 is equals to, open bracket, it's going to be 0 minus 2 all squared, right? Then it's going to be what? It's going to be 0 plus XA, right? So now it's going to be 12 is equals to, this one is going to be 4XA, right? Then it's going to be what? Then this is going to be 12, right? So this is going to be 12 is equals, so 12 divided, okay, it's going to be 12 divided by 4 is equals to XA. This is also, yeah, this is just XA, right? Then therefore, XA is going to be equals to what? It's going to be equals to negative 12 divided by 4, which is going to be equals to, it's going to give us, it's going to give us what? Positive 3, right? So 3, it says, if K is equals to negative 3, calculate the coordinate of C, right? So now we know the fact that basically we know the fact that here it's going to be positive 3, right? If we just translate it back, because this point, remember, is what? It's basically negative 3. So when we put it back here, it's going to be positive inside the original function here, right? So this negative K was just to trick you guys, to be honest, right? So the original function is going to be this one plus 3 because of, remember that this one is on the negative. So f of x now it's going to look like this. It's going to be what? It's going to be x minus 2, right, all squared. Then this is going to be x, right, plus what? Plus 3, right? So the first we're going to expand that, because remember the fact that we're looking for the calculate the coordinate of C. We're looking for the turning point. So first I'm going to expand it before I differentiate it. So it's going to be f of x is equals to what? Is equals to x plus 3. Then expand the other side, which is I'm going to get x squared, right? X squared minus 4x, right? Then it's going to be what? Plus, right? So distributed. So it's going to be f of x. Let's clean it up. So it's going to be x cubed, right? So it's going to be x cubed minus x squared. Then it's going to be minus 8x. Then it's going to be plus 12, right? So now we're going to find the first derivative. So it's going to be f prime is equals to what? To 3x squared, right? Minus 2x, right? Then it's going to be minus 8. And this is going to be equals to 0. This is going to be 3x squared minus 2x minus 8. Factorize that. We're going to get 0 is going to be equals to what? It's going to be equals to 3x minus what? what you call 3x minus, not minus, plus what? Plus 4. There's going to be x minus 2. Right? So x here is going to be equals to what? It's going to be equals to 4 over 3. Or x is going to be equals to 2. Right? So now remember that we're looking for the coordinate c. C is this one, right? So c is in the negative, so it's negative 4 over 3. So this one represents c, and this one's going to represent 2, which we already have here, right? So now we know the fact that to get the complete coordinate of c, we need to substitute negative 4 over 3. So it's going to be negative 4 over 3, right, is equals to what? We're going to substitute it back into the original. So it's going to be the following. It's going to be negative 4 over 3, right, minus 2 all squared. Then it's going to be negative 4 over 3, then plus 3, right? Punch that into the calculator. You're going to get your what? You're going to get your c value to be what? The y coordinate to be 500 divided by 27. Therefore, the c is going to be equals to what? To negative 4 over 3 is to 527. 500 divided by 27. And this will be your c value for this question. So now let's do example 4, right? It says if g is a cubic function, and they tell you the following information, right? So the first one, it says g at 3 is equals to g prime at 3 is equals to 0. So first, let's evaluate what's g at 3 equals to 0, right? This is the x-intercept, right? This is the x-intercept, meaning it's going to be 3 is to 0, right? G prime at 3 is equals to 0 is the x coordinate, right, of the turning point. So what does that mean? So what does that mean, right? So turning point. So what does that mean? It means the fact that at 3 is equals to 0 is what is the turning point, and also the what? The x-intercept. So that's what it means, right? So at that point is the turning point, and it's also the x-intercept. Then the next information, they tell us g at 0 is equals to 27. This is what? This is the y-intercept, right? Because of it's going to be 0 is to 27. Then they tell us the fact that g double prime is greater than 0. So when they say g double prime of x is greater than 7, is greater than 0, sorry. This means what? When you find a second derivative and it's greater than 0, meaning this is concave up, right? When x is equals to 3, so when x is equals to 3, so when x is less than 3, sorry, this means this is 3 is also the point of inflation. Because remember, concavity is determined by the point of inflation. So this is the point of inflation, right? Then this part tells us the fact that is less than and equals to 0, meaning this is concave down, and where is it concave down? Is when x is what? When x is greater than 3, right? Because remember, 3 is the point of inflation. So what do we know? We know the fact that the point 3, x is equals to 3, has the following properties. Is the x-intercept, right? It's the turning point. And also the last thing is the point of inflation. So if the graph has if one point has 3 properties, right, then the graph for this is going to look like this. Remember the fact that it's going to look like this. First, let's mark where 3 is. 3 is going to be here, right? So anything that is less than, remember the fact that here is less than 3. So it's from negative infinity till 3. It needs to be concave down. So it needs to be like this, right? So our graph here is going to do like this. Do you see? It's going to curve and just go down because of it is the turning point, is the point of inflation, and it's also what? It's the turning point, it's the x-intercept, and it's also the point of inflation. So it's going to look like this. So our graph is going to look like this. Do you see the fact that it goes, then it curves in, which represents concave up. Then here at the bottom, it's going to represent concave down. So this is how your graph is going to look, and this point is going to be 27. So this is how your graph is going to look. So the minute one point has all these properties, just remember the fact that this is how it's going to curve here, right? So I hope that makes sense. So now, welcome to the last session of calculus, which is applications of differentiable calculus, right? Which is also known as optimization problems, right? So before we get on to anything, let's discuss the nodes and what are we looking for, because I believe the fact that if you know where you're going and what you're looking for, it makes it easy to know what to do when you get to the test, right? So the first thing that you need to understand, first you need to understand. First you need to understand. So you need to understand. So this is not okay. So first you need to understand. Let me just erase this part, right? First you need to understand what you're looking for. As I said, what you are looking for, right? So you need to understand what you're looking for, right? And what we're looking for here, we're looking for the maximum or the minimum. So here we're looking for what? We're looking for the maximum, right? The maximum something or the minimum of something, right? Or the minimum of something, right? So we know the fact that we're looking for the maximum of something and the minimum of something, right? And it could come with other words in terms of the lower cost or the highest cost, anything that has to do with something being high or something being low, right? That's what we're looking for, right? From understanding the fact that we're looking for the maximum and the minimum, you need to understand which two graphs, right? Or which situation gives us the maximum and the minimum, right? Turning point, right? Turning points gives us, right? So gives us the maximum or, right, the minimum, right? So turning points is going to be the one that gives us the maximum and minimum. And that is why here, every time when you answer a question, there's a point where you need to find the first derivative and equate it to 0. Because remember the fact that this one, right, gives us what? Gives us turning point. I hope that makes sense, right? So that is why you always need to find the first derivative of something. The minute they say, find the maximum of something or find the minimum or the lowest cost, depending on whatever situation you're looking at, right? So now we need to know graphically where is the maximum, right? And where is the minimum. And first I'm going to just look at the quadratic function, right? So looking at the quadratic function, if A, right? If A is positive, do you see the fact that this is going to give us what? This is going to give us the minimum, right? This is going to give us the minimum. I wrote maximum by mistake. So this is going to give us the minimum. Let me just correct that. So this is going to give us the minimum, right? So you need to understand what is the minimum. Do you see the fact that the minimum, I'm just going to change my color so that this can make sense. Do you see the fact that here on the x-axis, this is just the x-coordinate, right? The x-coordinate is just a value where the minimum is going to be. But the minimum value, right, it's actually what? It's going to be actually the what? The y-intercept, right? So the y-coordinate of the turning point is going to give us what? This is going to be the one that gives us the minimum value, right? So that is why in most questions, after finding this x-coordinate, we substitute it back into the original function to find whatever minimum or maximum. I hope that makes sense. So this y, right? Sorry. So this y, right, gives us what? Is the one that gives us the minimum, right? So this is when we're dealing with quadratic, right? So now, let's say now we're looking for the maximum, right? And our graph looks like this, right? So here, what gives us the maximum is going to be what? So let me just change my color. This gives us what? Where the maximum point is, or the maximum value, right? So let's say this is x. This y here, right, is the one that gives us the what? The maximum value. Right? So it's the one that gives us the maximum value. And this point is where the maximum is going to be happening, right? So this is where the maximum is going to be happening, right here. So this is where the maximum value is, right? By the turning point. Why we look for the first derivative. So this is what? This is when a is less than 0. Another important thing, you can see through this, the fact that you knowing how the shape looks when you're given maybe your function is a quadratic, right? You knowing when a is positive and when a is negative, knowing the shape is going to be easy for you to determine the maximum and minimum, right? So again, we have another situation, and when it comes to if the function that the situation that you're dealing with, and you get a function that is a quadratic, that is very easy because of you know the fact that a quadratic function only has one turning point, right? It gets tricky in terms of knowing the shape when you have like a cubic function, right? So you know the fact that a cubic function, and I'm just going to draw one when a is greater than 0, right? So it gets tricky when your cubic function now, right? Now your actual equation or the equation that you just created is what? It's a cubic function. And the reason why I'm saying when it comes to the cubic function, you need to know is because of, do you see the fact that the cubic function has what? Has a maximum, right? And it has a minimum. So the question could ask you, find the maximum, right? You can't take both of them because of the other one represents maximum and the other one represents minimum, right? So you need to know which one you're dealing with so that you can pick the right one and substitute back so that you can get the proper what? The proper maximum value if they want this, which is going to be the y coordinate of the turning point or the minimum value, right? So this is why it's very important to know your shapes, right? So now with that said, I want to talk about when they give you a function, right, that you don't know the shape, right? So here's a situation where they give you a function and they want the maximum or minimum, and let's say the fact that, for instance, you have 3 turning points, right? You find the first derivative, you factorize, and you get the fact that you have 3 turning points. How would you know which one to pick, right? And to know which one we pick, we're going to use this one, right? This finding the optimum point, right, is going to be the one that's going to tell us for which one to pick, right? So let's say we have how many points? We have maybe x is equals to a1, right? Then a2. This is after finding f prime, right? So a1, a2, then a3, and x is equals to a3, right? And they say they want the maximum point, right? They want the maximum point, right? So how would you do that, right? Is that if you find if you find the second derivative, right, and you substitute your a value, which is the ones that you got after finding your first derivative, right? And if your answer is less than 0, meaning the fact that your answer is negative, right? That means that point is at the what? At the local maximum, right? Then right? So if it's negative after substituting, you're going to get the local maximum, right? But if you find the second derivative and substitute your a, it could be a1, a2, and a3, and you find that your answer is positive, right? Then it's going to be at local minimum, right? So when it's positive, it gives local minimum after finding the second derivative. But when it's negative, it's going to give you what? Local maximum. I hope that made sense, right? This idea of substituting and checking where it is local minimum and local maximum is going to make sense when we do an example, right? So right now, don't worry about it. We're going to do a question that actually involves us using this two tools, right, to determine where is it local maximum and local minimum, right? So next up, we're going to do examples that are regarding with application. So now we're going to move to questions that involve helper function, right? So with helper function, I'm just going to write the notes here, right? Is that we need to understand the following situation when we're dealing with questions that involve helper functions. You're going to have a question where it's going to need a helper function to basically solve what you want, right? So in your question, you're going to have two types of questions. So you're going to have two types of what? Two types of functions. So you're going to have two types, right, of functions, right? One of them is going to be the helper function. Right? And how do we know the fact that something is a helper function? It always equals to some value, right? So it always has a value. So this is when you know the fact that this is going to be a helper function, right? Then the second equation or the second function is going to be what? The one that you need to find the maximum or minimum, right? So the one that we going, right, to find f prime, right? F prime of whatever. I'm just saying f prime of x because I just want to make it general, right? So what's going to happen is that this helper function is going to help the one that you need to differentiate. Because normally this one is going to have two variables and you need to reduce it to only have one variable so that you can differentiate it, right? So that's how it's going to be. That's how we're going to deal with questions that have helper functions, right? So now let's just do an example, right, that deals with us basically finding the helper function and using the other one to help us find what? To find the maximum of something, right? So let's just read this question, right? So it says the sum of two positive numbers is 10, right? So we need the sum of two positive numbers, right? So first we're going to let, because they didn't tell us what are those numbers, so I'm going to say let x and y, right? You can name it anything, w, k, it really doesn't matter. Just name it two variables, right? Let x and y be two positive numbers. Do you see? Two positive numbers, two positive, right, numbers, and we know the fact that the sum of the two positive numbers, meaning we adding, so it's going to be x plus y, right, is going to be equals to 10, right? And since this is equals to 10, remember I said the helper function is equals to a value. This is going to be regarded as what? This is going to be regarded as the helper function because it's the one that has the value, right? So this is going to be regarded as the helper function, right? So we know the fact that x plus y is equals to 10. So let's continue and read the situation. It says one of the numbers, so it says one of the numbers, right? So either x or y is it is multiplied, so they are multiplying each other. So one of the numbers is multiplied, right, by the square of the other one, right? So what's happening here is that one of the number between x and y, right, they are multiplying with the other one, but the other one being squared. So let's just translate that, right? So what is multiplication? Multiplication is what is, what you call this? Is m, right? So I'm going to name, because we're multiplying two of them, so I'm going to say m is equals to what? Multiply the two numbers, so I'm going to square the last one. So it's going to be x multiplied by y all squared, right? Do you see the fact that for one of the numbers, which is x, is multiplied by another one, which is y, but the other one is also squared. So I just squared y. It really doesn't matter. Even if you squared x, right, it was going to be perfect, right? So let's continue reading the question, right? It says, if each of the number is greater than 0, right, then the number, they say the fact that the numbers that make the product, so multiplication and product is the same thing, right? That makes this product, right, is what you call this? Find the numbers, yes. So it says find the numbers that makes this product, which is this multiplication. I named it M, or let's just name it P, so that we know the thing that we're looking for that. So I'm just going to erase this. And I'm going to name it P, right? So here's I say the thing that find the numbers that make this product, which is this one, right, a maximum. Do you see the fact that this is the one that we are differentiating? So we're going to find our P prime, right? But looking at this, the problem is that the one that we need to differentiate, right, has X and Y. And you guys are not taught on how to differentiate using having two variables. You guys are not taught that at all, right? So what needs to happen is that you need to change this function P, right, to have only one variable. It could be in terms of X or it can be in terms of Y, right? So that's what we're going to do. So first, since we have the helper function, do you see the fact that the helper function is those two variables, then a and a number, right? So what I can do is I can take the helper function. I'm just going to do it here. Is that we know the fact that X plus Y is equals to what? Is equals to 10. So I'm going to make Y the subject. So it's going to be Y is equals to 10 minus X, right? So you see the fact that if I substitute here Y, everything is going to be in terms of X. So that's what I'm going to do. And I'm going to name this 1, right? So I'm going to substitute 1 into P, right? So it's going to be P now is going to be equals to what? It's going to be equals to X, open bracket, is going to be 10 minus X, right? So it's going to be all squared. Do you see the fact that now P is in terms of only one variable? Do you see why this is called the helper function? Because it helps P to only have one variable, right? So now I'm going to expand it because I need to differentiate it, but I'm going to call it P of X, right? Because everything is in terms of X is equals to X. So let's expand this one, right? When we expand it, we're going to get 100, right? Minus what? Minus 2x, right? Then it's going to be plus what? Plus x squared, right? Then distribute the x, so it's going to be P. Then it's going to be x is equals to what? To 100x, right? Then it's going to be minus 20x squared. Then it's going to be plus x cubed, right? So that's what you're going to have. And since everything is in its terms, so we can find the first derivative, right? Which is going to give us what? When you're finding the first derivative, it's going to give us 100, right? Minus 40x, right? Then it's going to be plus 3x, right? 3x squared, right? Then now what we're going to do is we're going to factorize it. So it's going to be, remember the fact that here, the maximum we're looking for what? Here we're looking for in P prime of X, we're looking for the turning point is equals to 0. So this is going to be equals to 0 is equals to 100 minus 4 minus 40x. And it's going to be plus 3x squared, right? Let me just rewrite it, making those 3x squared in front. So it's going to be 0 is equals to 3x squared minus 40x. Then it's going to be plus 100, right? Then factorize this. So it's going to be 0 is equals to open bracket, right? We're going to have 3x minus what? Minus 10, right? If you can factorize this, you can use the quadratic. Then it's going to be what here? Going to be x minus 10, right? So x is basically going to be equals to what? It's going to be equals to 10 divided by 3. Or it's going to be x is equals to what? X is equals to 10, right? So now looking at this, let's go back to the question and check what they want. They said the thing that find the numbers, guys. They didn't say find the maximum, right? They said find the numbers that when you multiply, you get the maximum, right? So here we already found one of the numbers, which is x, right? Now we need to find y because that's another number. When we multiply them together, we get a maximum, and that is why we differentiated, because maximum means what? We need to differentiate. I hope that makes sense, right? So from this two x values, we need to check which one, right, is the maximum. Because remember the fact that a cubic function, and how do we see the fact that it's a cubic? Let me just highlight. Do you see the fact that this is the original P, right? Do you see the fact that the coefficient of x squared, right, is positive? So we see the fact that, and the coefficient of x cubed, right? So we see the fact that this is the, what you call it, this is the cubic because the highest power is 3, right? Hope that makes sense. And we see the fact that a there is what? Is positive. So we see the fact that here a is what is greater than 0 because a is equals to 1. So our function looks like this, right? And I'm just going to draw a rough sketch, not exactly like this. We see the fact that it's going to go to maximum, then it's going to come back to minimum, right? So meaning, since 10 over 3 is the smallest, it's going to be the one that's here. So this is going to be 10 divided by 3. And for the minimum, it's going to be here, which is 10 because it's greater than 10 over 3, right? So meaning what's happening is that our maximum is happening at when x, right, is equals to, this is the maximum, right? So x, the maximum, right, the maximum number here is when x is equals to 10 divided by 3, right? So now we need to find the y, right? The y value, so that when we multiply them together, we get what? A maximum. So remember the fact that we had a function that was already in terms of what? In terms of y. So what are we going to do is we're going to substitute, right? X equals to 10 divided by 3 into 1 to get y. To get y, right? So that's what we're going to do. So it's going to be y is equals to what? Is equals to 10 minus what? Minus 10 divided by 3. Place that into the calculator. You're going to get that your y is going to be what? It's going to be 20 divided by 3. So when we multiply these two numbers, right, we're going to get the maximum product. So that's what it means. If we had to multiply these two numbers, we're going to get the what? We're going to get the maximum product. So this is going to be your two answers. So this two, this one, and this one is going to be your two answers, because when you multiply them together, you're going to get your maximum product. This is going to make the product maximum. I hope that makes sense. So now we're going to do example 2, right? So let me just take my highlighter. Is this a drinking cup, right? Is a shape of a cylinder. So we see the fact that the drinking cup is in the shape of a cylinder. We must hold what? 400 which was milliliters of liquid when full. What is this 400, right? What is this 200 milliliters, right? In terms of function, this is the volume. So this holds a volume of what? A volume of 200 milliliters. I hope that makes sense, right? So now the first question, 10.1, it says shows that the height of the glass can be expressed like this, right? So right in this question, right? Since they gave us, right, how much water the drinking cup, drinking cup holds, right? Drinking glass, right, holds. We know the fact that since they gave us how much the drinking cup holds, right, means that the volume is the helper function, which makes sense, right? Which means it's going to be the helper function. The reason why it's going to be the helper function is because they told us how much volume this is, right? So they gave us the variable for that, right? So this is going to be the helper function, right? So with that said, the first question, 10.1, right? They say the fact they show that the height can be expressed like this, right? Here they're actually looking for the helper function. So here they're looking for the helper function. So we are looking for the helper function, right? So since we're looking for the helper function and we know for a fact that the helper function is the volume, right? So we're going to use the equation of the volume of a cylinder. So the equation of a volume of a cylinder is V is equals to what? Is equals to pi r squared h, right? So remember the fact that we need to make this in terms of what? In terms of h. So we know the fact that the volume is given as being 200, and this is going to be equals to pi r squared h. Divide both sides by what? By pi r. So it's going to be 200 because we're looking for h. H needs to be the subject, so it's going to be 200 pi r squared is equals to h, right? So this, right, so therefore, let me just say that, therefore h is equals to 200 pi r squared. So this will be your helper function, which is this one, right? Then the second part, it says, show that the total surface area of the glass can be expressed in this way, right? So here, right, so 10.2, we need to find the surface area, right? But do you see the fact that our surface area is in terms of r? So first, let's find the surface area. So we know the fact that surface area, right? So surface area, right? Area, okay, is equals to what? Is equals to the surface area of a cylinder is equals to pi, right? Pi r h plus what? Plus pi r squared, right? So now surface area, I'm just going to name it S, is going to be equals to what? So now remember the fact that everything is in terms of h, right? So in terms of r, sorry, here everything is in terms of r. So we need to substitute this h here. So let me just do this before. Let me erase this part. So we see the fact that everything here, what they want is in terms of r, right? So what we're going to do is we're going to substitute h is equals to 200 divided by pi r squared into what? Into here, the surface area, right? So that everything can be in terms of r, right? So into the surface area. So it's going to be what? I'm just going to name it S now. Surface area, I'm going to name it S. It's going to be equals to 2 pi r, open bracket, is going to be 200 divided by pi r squared. That's going to be plus pi r squared. Let's clean this up. It's going to be S, since everything is in terms of r, so it's going to be S of r is equals to what? Then it's going to be 2 multiplied by what? It's going to be 2 multiplied by 200, which is going to give you 400, right? Then you pi here, and this one is going to cancel out. Then this r here, because it's going to be 1, right? So it's going to be what? It's going to be r, it's going to be 1 minus 2, right? And this is going to be plus pi r squared. Let's clean this up. So let me clean it up here. It's going to be what? It's going to be 1 minus r, which is going to be just negative r, which is when we take it down. So let me just do this. It's going to be 400, right? R negative 1, then it's going to be plus pi r squared, which is going to be the following, which is going to be, here I'm going to write the final answer, which is going to be the same as the surface area of r is basically equals to what? To 400 divided by r plus pi r squared, right? So this is exactly what they wanted there, right? So now we're going to move here, and it says, hence determine the value of r, right, for which the total surface area of the glass is minimum, right? Do you see what we need here? We need to find the minimum value, right? So we need to find the minimum value of the surface area, and this is the formula for that, right? So 10.3, right, we're looking for the minimum, so we need to differentiate it, right? So we need to find S prime of r, but remember the fact that we're only solving for r, we're not looking for the maximum value, but we're looking for just r, so we're going to solve for r, right? So I'm going to say S of r is equals to what? Is equals to pi. I'm just going to take the r on top, right, so we can differentiate it. So it's going to be pi r squared plus what? Plus 400, right, r to the power negative 1, right? So this is going to be S prime. Remember the fact that we're looking for x prime when it's equals to 0, because we're looking for the turning point. So it's going to be S prime at r is equals to what? It's going to be 2 pi r. Then here it's going to be negative 400, right? R to the power negative 2, because it's going to be negative 1 minus 1, which is going to be negative 2, right? So this is going to be 0 is equals to 2 pi r, right? This is going to be what? Minus 400, right? I'm just going to take the r squared to the power negative 1 to the power negative 2 to the denominator, so it's going to be positive, right? So this is going to be the same, taking the 1 with the negative, so I'm going to say 400 is equals to r squared is equals to what? Is equals to 2 pi r, right? Take the r to the other side, so you're going to have 400 is equals to 2 pi r multiplied by r squared. That's going to give us cubed, so it's going to be 400 is equals to 2 pi r cubed, right? So divide here by 2 pi, so it's going to be what? It's going to be 400 divided by 2 pi is equals to r cubed, right? So then when you're done, this, when we simplify it, we're basically going to have the following. It's going to be what? It's going to be equals to 200, right, divided by pi, right? Then now, and 200 divided by pi is equals to what? It's going to be equals to r cubed, right? So now we're going to cube root both sides. So it's going to be the cube root, right, of 200 divided by pi is equals to the cube root of r cubed, right? So since this is an even number, we don't need to do plus or minus. So it's just going to be r is equals to, remember, we're just looking for r. So after here, we're done. So it's going to be the cube root, right, of what? Of 200 divided by what? By pi, which is going to give us what? Which is going to give us 3,99. And this will be your final answer on how to find r when the surface area is minimal. I hope that makes sense. So now let's do example 3, right? So let me just take my highlighter. It says a rain gauge is in the shape of a cone, as you can see in the diagram. Then they say water flows into the gauge, the height, right? So the height of water is h, which is they named this here, h centimeters. And they tell us the fact that when the radius is r centimeter, which is they named it here, then they tell us that the angle between the cone edge and the radius is what, which is they see here is equals to 60, as shown in the diagram, right? Before we answer the following question, let's just see what they gave us, right? So in our situation here, the helper function, right? The helper function, right, is the one, is going to be this right angle triangle. And the reason why the helper function, so the helper function is, that we just write it, is the right angle triangle, right? So it's going to be right angle triangle, right, inside, so inside the cone. And the reason why this is going to be the helper function is because, right, is because we are given, we are given the 60 degrees, right? So we're going to use the 60 degrees to basically solve. They were not bored, to be honest, to give us that 60 degrees, right, as a value, is that we needed to use it, right? So this is going to be the helper function, right? So the first one, the first question, it says determine r in terms of h. And when they say determine r in terms of h, meaning r needs to be only in terms of h, not with other values, right? It just need to be in terms of h only, right? So here, what do we see? We see the following. As I said, the fact that the helper function here, right, we're looking for the helper function, because they want us to determine something in terms of the other one, right? So we're looking for the helper function. Since we're looking for the helper function, so for 10.1, right? So here we know from the diagram, right? So I'm just going to rewrite the diagram. So this is the diagram, right? And this is 90 degrees and the 60 is here, right? So we know the fact that this is h and this is r, right? So I can find what? I can find using what? Using trig, what? I can find using trig my, the 60 in terms of h and r, right? So what do I know? I know the fact that this is opposite and this is adjacent. So we know the fact that what is opposite and adjacent is 10. So we know the fact that 10 of 60 degrees is basically equals to what? It's equals to h divided by r, right? So now remember that we need to find everything r in terms of h. So I need to make r the subject. So multiply to the other side. So it's going to make r multiplied by 10. 60 degrees is equals to h, right? So divide both sides by 60. So it's going to be r is equals to h divided by what? By 10. 60 degrees, right? So find tan 60. So R is basically equals to what? 2h divided by square root of 3, because tan of 60 is equals to root 3, right? And that's how you would find the first question, which is the helper function, right? So it says, let me just go to the next part, the next page. So we know the fact that R, first, before I continue, is equals to h divided by what? Divided by root 3, right? So the next question says, determine the derivative, right? So here they tell us the derivative, right, of the volume, right, of the water with respect to h, right? So meaning our function first needs to be in terms of h, then we're going to find the first derivative, right? When this is equals to what, then we're going to substitute 9, right? So we need to find volume, the first, what they're looking for. So 10.2, here the question, if I had to translate it into numbers, we're looking for the first derivative of h when, no, we're looking for the first derivative of h, right? Then after finding the first derivative, we need to find the first derivative at 9. So that's what we're looking for. We're looking at the volume, right? But the first derivative of the volume when it's equals to 9. So knowing that, let's find the first derivative. Let's find volume first. So volume, right? From looking at this diagram, right? From this diagram, they gave you guys this diagram just to trick you. You need to pick the right whole, guys, for the volume. So here our volume is going to be equals to what? It's actually equals to this one. That is the volume of a what? Of a cone. So volume here is equals to what? To 1/3, right? Pi r squared, right? Then it's going to be h, right? So remember the fact that this is just the helper function so that you guys are not confused. We're going to use that one because we need everything to be in terms of what? We need everything to be in terms of h. So we know the fact that volume of h now, because we're substituting r with this one, is going to be 1/3. Then it's going to be pi, open bracket, is going to be h. Then it's going to be root 3. Then this is going to be all squared. Then this is going to be h, right? Let's clean this up. It's going to be the volume of h, right, is equals to what? To 1/3. Then this is going to be pi, then it's going to be h squared, then this is going to be divided by 3, right? Then this is going to be h, right? Let's clean that up. This, when we clean that up, is going to be the volume of h is equals to, this h and h is going to give us what? It's going to give us h cubed, right? So it's going to be 1 multiplied by pi multiplied by h cubed, right? Which is going to give us just h cubed pi, right? And this is going to be divided by what? 3 multiplied by 3, because they're both in the denominator, is going to be equals to 9. And this is how your volume function looks, right? So now remember the fact that we need to find the first derivative of the volume in respect to h, and that's what we're going to do. So it's going to be h prime, v prime, right, is equals to the following. So it's going to be equals to, take the 3 in front. So it's going to be 3h, that's going to be squared whole pi divided by 9. Let's clean that up. So when we clean that up, we're just going to have the following, which is going to be 1/3 pi h squared, right? But remember the fact that we're looking for this one, right? This is the one that we're looking for. So you're going to find v prime at 9. So wherever we see h, you're going to substitute by what? By 9. So it's going to be equals to what? It's going to be 1/3. Then it's going to be pi. Then here it's going to be 9 all squared. Simplify that. You're going to get your answer. Paste that into the calculator. So you're going to get 27 pi. And that will be your final answer for this question. So now let's take a look at example 4, right? So it says the following, right? It says a rectangle box is constructed in such a way that the length, right, of the box is 3 times of the width, right? So which one is the width? The width is this x value. So that is the width. So meaning the fact that the length is now equals to 3 times, so it's equals to 3x, right? So that is the first information that they gave us. Then now let's continue reading the question. It says the material to construct the top, right, and the bottom of the box cost what? 100 Rand per square meter. The fact that they tell us per square meter, meaning the fact that area is going to play a role because of its square meter, right? And they said the fact that the material to use to construct the sides, right, is 50 Rand per square meter, right? And they said that they tell us the fact that the box must have a volume of what? Of 9 meters per cubed, right? And they tell us the fact that the width, they also tell us that the width is equals to x meters, right? So here, what do we see? They gave us volume, right? So they gave us volume as being 9 meters per cubed, meaning volume is going to be the helper function in our situation. So here we know the fact that volume, right, which is equals to 9 meters per cubed is the helper function. So that is the first thing that we need to see. This is going to be the helper function, guys. I hope that makes sense. So now, for us to answer this question, since we see the fact that we're calculating cost of the top, the bottom, and the sides, I'm going to reconstruct this whole thing, right, in a flat way, right, not in 3D. So we see the fact that this is going to be, let me just construct it. So this is going to be the base, right, which is the bottom part, right? And this one is going to be the side. And this is going to be the top part, right? So this is going to be the two sides here. And this is going to be the other side. And these two sides are the gray part, right? Then this is going to be the sides here, which is going to be this one here. So if you had to deconstruct your box, this is how it's going to look, right? So that everything makes sense, I'm going to highlight the one that cost 100 Rand with one color. So the one that cost 100 Rand is going to be the one in yellow, which is going to be the top and bottom. So this one is going to be the one that costs what? 100 Rand per square meter. So meaning the area of this is going to cost 100 Rand, and this portion here, right, it's going to be the one that costs 100 per square meter, right? Then I'm going to highlight the rest, right? These ones are just going to be the sides. So let me just do this. So this one is the sides, right? So these are the sides that are going to be in green. So the sides are going to be in green. Alright, so we know the fact that these are the sides. So the sides are going to be the one in green, which costs 50 Rand per square meter. Right, so this is how it looks. Okay, we sorted. So now let's name the sides, right? So here, from looking at our diagram, right, let's name the sides. We see we're going to start with the gray one. We see the fact that the gray one is the height, right? So the height is going to be here. Do you see that? That is going to be the height, right? Then, so it's going to be what? It's going to be this one. It's going to be this portion here. Do you see this portion here, right? It's going to be this portion here. This portion here where I'm emphasizing, and that's going to be x, right? So if this is x, this one is x2 because it's a rectangle, and those two are both heights, right? So here, since this one is a height, meaning this one is also h, and also this is going to be x, meaning this is going to be x, and this is going to be h here because it's the same, and this is going to be h, meaning this one is h, right? Then this one is the length. Remember that we know that the length is equal to 3x. So this is going to be 3x because that's how our width is. And this is going to be 3x. And I'm just going to name 3x where it needs to go. So this is going to be 3x, right? So now this one is h, meaning this one is also h. So this is going to be h and this is going to be h, right? And do you see the fact that the top and bottom one, this is x, so this means the fact that this is x here. I hope that made sense. So that's how you would label this diagram, right? So it's going to be labels, but using this as the reference to know where each side stands, right? So this is your entire diagram, right? So knowing that this is the entire diagram, they tell us the fact that the first question, determine 10.1, determine the expression of the height h in the box in terms of x, right? So here they're actually looking for the helper function, right? Because we need to determine one variable in terms of the other one, which means the fact that we're looking for the helper function. So since we know the fact that we're looking for the helper function, we know what? We know the fact that they gave us volume as being equals to 9 meters per cube. So we're looking for volume. Then after looking for volume, we're going to make what? We're going to make H the subject, right? So let's do that. So 11.1, right? Remember the fact that we're looking for volume, and volume of what? Volume of this, what? Of this, box is equals to what? To length times breadth times height, right? So it's not going to be length times breadth times height, but it's going to be, it's going to be length times breadth times height. Breadth is also known as the width, né? So it's just not the fact that breadth is also known as the width, right? We know the fact that the volume is 9, so it's going to be 9 is equals to length is 3x, breadth, which is the width, is equals to x, then height is just h, right? So this is going to be 9 is equals to what? To 3x squared multiplied by h. Remember the fact that we need to make h the subject. So I'm going to take the 3 and divide it to the other side. So it's going to be 9 divided by 3x squared is equals to h. Therefore, h is going to be equals to what? Is equals to 3 divided by x squared. So h is going to be in terms of what? It's going to be in terms of 8, right? So now I'm going to need the same diagram, so I need to answer everything here, right? So the next question, it says, show that the cost, right? Let's just do the cost here, right? It says, show that the cost, right, is equals to what? Is equals to this variable. And what do we see? We see the fact that cost is in terms of x. So everything, meaning there's going to be a point where we need to use the helper function, right? So that everything is going to be in terms of h, right? So now the cost, right? So where can I write it? So let me just do it here. So the cost here, what do we see? We see the fact that this one, before let me move on, this one, this 2 is 2 of them. So I can find one, right? One of them, then just multiply it by 2 because I'm going to be dealing with 2 of them, right? This one, so this one and this one is 2 of them. So I can find the area, because remember the cost is per square, so it's area. So I can find the area of 1 and multiply by 2. Then the cost of this one, I can find one of them and multiply by 2 because it's 2 of them. And also this 2, I can find 1 and just multiply by 2, right? So the cost here, so let me just do it. I think I can do it here. So the cost here, right, is going to be equals to, and let me just do it like this so that it makes sense. I'm going to divide them in different colors. So we have yellow, green, let's make orange, but let's make red, right? So I'm just going to do this one for red so that it makes sense. Then I can highlight what we're doing, right? So it's going to be the area of the yellow ones, right? So it's going to be area, right? Area of yellow, right? Multiplied by the cost, right? And this whole thing, right? This one is going to be multiplied by 2, right? So the area, so it's going to be the area of the yellow one, right? Then this whole thing multiplied by this whole thing multiplied by 2, right? So let me just do this. Even the cost, so it's going to be the whole thing multiplied by 2. So it's going to be this whole thing multiplied by 2 because it's 2 of them. Then plus it's going to be 2 of the area, right? Of what? Of the green one, right? Then multiplied by its cost again, right? Then it's going to be the last one plus 2 multiplied by the area, right? So it's going to be the area of the red one, right? Then multiplied by the cost. So knowing that, let's find the area of the yellow. So cost, right, is going to be equal to the following. The area of the yellow one is going to be x multiplied by 2x, right? So this is 3x, so it's going to be x multiplied by 3x. Remember the fact that this is 3. So it's going to be 2 open bracket. It's going to be x multiplied by 3x, then multiplied by what? Remember that the cost here is 100 rand, so multiplied by 100, right? Then here it's going to be what? For the green one, it's going to be h So it's going to be 2, open bracket, it's going to be h, right? For the green one, it's going to be h multiplied by 3x, right? Then multiplied by what? So let me just do multiplication like this. Multiplied by what? Multiplied by 50 rand. Because remember the fact that the green one represented for all the sides. So it's going to be multiplied by 50. Then it's going to be plus 2. Then here it's going to be what? It's going to be the red one, right? So it's going to be h multiplied by what? Multiplied by just x. Then multiplied by 50, right? Then I'm just going to highlight which one is which, right? So remember the fact that red one is this one, right? Then green one is going to be this one. And yellow one is going to be this one. Now let's just simplify it, right? So it's going to be what? It's going to be the cost, and I'm just going to call it C. It's going to be equals to what? It's going to be the cost. So let's just do this so that you guys are not confused, right? So the cost here, right? The cost here is going to be 2. So here it's going to be what? Let's just simplify the one that's inside the bracket. So it's going to be 3 multiplied by 100, which is going to give me 300. So I'm going to have 300, right? X squared, because it's x and x here, so it's going to be x squared, right? Then here, I'm going to simplify the one that's inside the bracket. It's going to be 3, right, multiplied by 50, which is going to give me 150. So it's going to be the same as 150 hx, right? So we sorted. Then here is going to be what? It's going to be the same as 2 multiplied by what? By 50, right? Then it's going to be xh, right? So let's distribute the 200, the 2. So it's going to be what? It's going to be 2 multiplied by 300, which is going to give us 600. So it's going to be what? It's going to be 600, right? X squared, right? Then it's going to be plus what? It's going to be plus, then it's going to be 2 multiplied by 150, right? Which is going to give us 300, right? Then it's going to be hx. Then the last one is going to be 2 multiplied by 50, which is going to be 100. So it's going to be plus 100, right? So it's going to be plus 100, right? Then this is going to be xh, right? So that's what we have. So I'm just going to take this and just continue with this side. I know that this is a mess. I'm sorry about that. Okay. So the reason why I don't want to skip to the next page is because of I need this diagram. I needed the diagram to simplify everything, right? So we know the fact that the cost, right, is, okay, we can just skip this one to the next page, right? So we know the fact that here the cost, after simplifying it that side, right, it's 600 x, because I don't need a diagram anymore, x squared, right? Then it's plus 300, right, plus 300 hx. Then the last one is plus 100 hx. Do you see the fact that hx is common here? So I can group them. So it's going to be equals to 600 x squared plus what? Plus 400 hx, right? So remember the fact that I want everything in terms of x, because here it's in terms of x, right? Remember that on the other side, we already solved the helper function, which was h is equals to what? Let's go up. H is equals to 3x squared. So it's going to be equals to 3x squared. So I'm going to substitute there wherever I see h. So it's going to be x. Now it's going to be in terms of x is equals to 600 x squared plus 400, right? Then open bracket, it's going to be what? It's going to be 3 divided by x squared, right? So we're going to simplify this. It's going to be the cost is equals to what? To 600 x squared, right? Then this is going to be plus what? 400 multiplied by 3, which is going to be 1,200, right? Then this is going to be, remember the fact that this was xh, so x is here, right? So one of the x's are going to cancel out here, and this one's going to be left in the denominator. So it's going to be 1,200 divided by x. And this is exactly what they want. So this is exactly how to find the cost function, right? So this is how you would do it. And then now let's move on to 10.11. 11, not 10. So 11.3, it says calculate the width of the box, the one that's in terms of x. So we need to basically calculate the x value when the cost is at minimum, right? So we need to calculate you need to find the first derivative and solve for x. So that's what they want from us. So first I'm going to clean up the cost and take the x on top. So I'm going to say the following. Cost of x is basically equals to 600x squared, right? Then this is going to be plus 1,200 x to the power negative 1, right? So I'm finding c prime of x is equals to what? It's going to be equals to 1,200, right? Because it's going to be 600, right? Multiplied by 2, which is 1,200 x, right? Then this is going to be minus 1,200, right? Then this is going to be x to the power negative 2, right? So now this we're finding when c prime of x is equals to 0. So this is going to be 0 is equals to 1,200 of x minus what? Minus 1,200 of x cubed, x squared, negative x squared, right? So take it to the other side is the same as 1,200, right, of x to the power 2. I just took the negative x to the power negative 2 to the denominator, and this is going to be 1,200 multiply, then this is x, multiplied by x, so it's going to be 1,200, right, is equals to 1,200 x multiplied by x squared. Then this is the same as 1,200 is equals to 1,200 x cubed. Divide both sides by 1,200. You're going to have 1 is equals to x cubed. So cube root both sides. So x is going to be therefore equals to 1. And this is going to be your final answer. So the minimum width is going to be what? 1 meter. So that's how you would find the answer to this question. So now we're going to do example 5, right? It says a cone with the radius r, right? So we see the fact that there's a cone with the radius r. So this is the radius here, the one from B going the other direction, right? And they tell us the fact that it has a height of AB. So this is the height, right? This is the total height, which is AB, right? Then they tell us the fact that there's a sphere with with the center O. So do you see the fact that there's a sphere here? So this is the sphere. So this one, let me just highlight it, right? So it can make sense. So there's a sphere. Where is it? Yes, highlighter. So there's a sphere. This is going to be the sphere, right? Do you see the fact that this is the sphere? And they tell us the fact that the sphere has what? Has the center. So here they tell us the sphere has a center O, right? And then has a radius of what? Has a radius of 8. So if this is 8, do you see the fact that the radius is a point from the center going to the circumference, which is at A, right? This. And I'm just going to highlight it with a different color so that you can see what I'm talking about, or let me just really quick. This 8 here, right, is the radius. That means the fact that from O going to this point here, this is going to be also the radius, right? Because it's a point going from the center to the circumference, so this is also 8, right? So this is also 8, right? I hope that makes sense. So now it says calculate the volume of the sphere, and this is the volume formula for the sphere. So it's going to be the following. So for 9.1, it's just substituting the radius inside. So it's going to be volume of the sphere, right? It's going to be equals to 4 divided by 3. That's going to be pi r cubed, right? So substitute the, the radius there. So the volume here is going to be 4 over 3. Then it's going to be pi. Then r is 8. And it's going to be all cubed. So punch that into the calculator. You're going to get your volume as being equals to what? To 2,048 pi. Then this is going to be divided by 3. So that's the volume of the sphere. So I'm just going to call it S, volume of S. So we are done with that one. The second one, it says, show that r squared is equals to what? Is equals to 64 minus r. So it says, show that r squared is equals to 64 minus r. R x is
x squared. That's what I wanted to say, right? So here, how can we find that? I'm just going to highlight the triangle that we're going to use that r squared situation. Do you see where r is? I'm just going to take my highlighter, but with a different color now. So let's just do it blue, right? Do you see the fact that r is here? We need to write r in terms of x, and x is here, right? Do you see the fact that this is a right angle triangle, right? And we can use what Pythagoras to write r in terms of x, because we already have this 8, right? So that's what we're going to use. And this is actually the helper function, right? So this is the helper function. And the reason why it's a helper function is because they already told us the radius of the sphere, right? I hope that made sense. So this is going to be 9.2. So it's going to be what? Using Pythagoras, right? Using Pythagoras, we know the fact that this is the hypotenuse, 8 is the hypotenuse, because it's opposite to the right angle triangle. So it's going to be right, it's opposite to the square. So it's going to be what? It's going to be 8 squared is equals to r squared plus x squared, right? This is going to be 64 is equals to r squared plus x squared. We want everything to be in terms of r, so I'm going to take the x to the other side. So it's going to be 64 minus x squared is equals to r squared. So therefore, we know the fact that we have exactly what they want, which is going to be r squared is equals to what? 264 minus rx squared, right? So that's how you would do it. So for the next question, we're just going to go to the next page. It says determine the ratio, right? So we need to divide two things because they said the ratio. Determine the ratio between the largest, very important word, largest, right? So the largest volume. So here what they mean is that we need to find the maximum volume, right? So the largest volume of the cone. So we need to find the maximum volume of the cone and the volume of the sphere. So first we need to find the maximum volume of the cone. Then we're going to divide it by the sphere, the volume of the sphere, which is we already calculated. This is the volume of the sphere, right? So now we need to find the maximum volume of the cone, right? So we see the fact that volume here of the cone is equals to what? Is equals to, so I'm going to call it C, it's equals to 1 over 3, right? Pi r squared h, right? So now I'm going to rewrite what? Everything in terms of what? In terms of a, in terms of x, right? So what I'm going to do is I'm going to substitute r squared and h. And h is actually termed in terms of what? In terms of x, right? Let me just highlight h. H, remember the fact that it's this one.
Totally fine. We love it.
Do you see the fact that h is equals to what? Do you see from here? H is equals to 8 plus x. It's made out of 8 and x, right? So we know the fact that 8 is equals to 8 plus x, and r squared, we already calculated it as being 64 minus x squared. So this whole thing of the cone can be in terms of what? Of x, so we can actually differentiate, right? So the volume of the cone is basically equals to 1 over 3. Then it's going to be pi. Here it's going to be 64 minus x squared, right? Then this is going to be 8 plus h, right? 8 plus x, right? So knowing that now, we're going to just expand this other side, right? So it's going to be the volume, right? And the volume, when we expand it, it's going to be 1 over 3 pi. Let's expand this bracket. So we're going to get the following. We're going to get 512, right? 512 plus what? Plus 64, right? Plus 64x, right? Then this is going to be minus 8x squared. Then this is going to be minus x to the power 3, right? Then we're going to distribute the pi 1 over 3 pi, right? So that's what we're going to do. So it's going to be v, right? It's going to be equals to, or yes, let's just distribute it. So it's going to be 1 over 3. So it's going to be 1 over 3 pi multiplied by the first number, which is 512. So when we distribute that 1 over 3, you're going to get the following. It's going to be 5, 1, 2 pi divided by 3. And this is going to be plus 64
pi x, right? Then this is going to be divided by 3. Then this one's going to be minus 8 pi x squared divided by 3. Then the last one is going to be minus x cubed pi divided by 1 divided by 3, right? So now we can find the maximum, which is the maximum is the same as finding the first derivative, right? So that's what we're going to do. So we're going to say the cone, right, is equals to, let's differentiate it. The first one is going to become 0. Then when we differentiate the rest, it's going to be 64 pi divided by 3. Then the other one is going to be minus 16, right, pi x divided by 3. Then here's going to be minus what? Minus 3, right, pi divided by 3. And this is going to be x squared, right? So this, remember the figure we're looking for, when it's equals to 0. So it's going to be, this is going to be equals to 0. So it's going to be 0 is equals to 64 pi divided by 3, right? Minus 16 pi, right, divided by 3. Then this is going to be minus 3 pi divided by 3. Then it's going to be x squared. Take out pi over 3 as a common factor because it's common. So it's going to be equals to what? It's going to be pi divided by 3, right? You can take out, yes, pi over. You can take out negative pi over 3, right? Then it's going to be equals to what? It's going to be equals to 64, right? Minus 64 because I took it as being negative. So everything that was positive becomes negative and everything that's negative becomes positive. So let's do that. So this is going to be plus 16x, right? And the last one is going to be plus 3x squared, right? Then you're going to close it. So divide both sides by negative pi over 3. So 0 is going to be 0. Then here's going to be, I'm going to take the squared, the 3x squared to the front. So it's going to be 3x squared, right? Plus 16x. Then it's going to be minus 64, right? Then after doing that, we're going to factorize this expression. So when we factorize this expression, we're going to get the following. So we're going to factorize this expression. So we're going to get 0 is equals to what? Is equals to open bracket is going to be 3x, right? Minus 8. Now we're going to have x plus 8, right? Meaning x is equals to what? To 8 divided by 3, right? Or x is equals to what? X is equals to negative 8, right? Now, remember the fact that we're looking for the maximum, which got this volume. So we need to find which one gives us the maximum, then substitute it back into the original cone function to find the maximum, right? So that's what we need to do. So here we see, let's go to the original volume, right? So where we already substituted x. So when we go back, which is this one, right? We see the fact that the coefficient of x cubed is what? It's a negative number. So we see the fact that a here, right? We see that a is what? Is less than 0, meaning our graph is going to look like this, right? Where x minus 8 is here, which is the minimum, which is not what we want. Then the maximum is at 8 divided by 3. So our maximum value is this one, right? So that's the one that we're going to substitute back here, right? So that's what we're going to do. So I'm just going to substitute it back. So when I substitute back, right, I'm going to substitute into this one because it's the one that's easier for me. So I'm going to say the maximum. This is the maximum volume of the cone. So this is going to be the maximum. It's going to be equals to what? It's going to be equals to 1 over 3 pi open bracket. Then remember that we're substituting this value. So it's going to be 64 minus what? Minus 8 divided by 3, right? Then this is going to be all squared, right? Then close your bracket, right? So that's going to be 8 plus 8 over 3, right? Paste that into the calculator. You're going to get your maximum volume of the cone to be this value. So it's going to be equals to 555,556 pi divided by y divided by 27, right? So now this is the maximum volume. So this is the maximum volume of the cone, right? So now remember, we need to find the ratio, and the ratio, right, is basically equals to the following. It's going to be volume of the cone divided by the volume of the maximum volume of the cone divided by the volume of the sphere, right? So we know the fact that the volume of the cone is the one that we just calculated, which is 5. Okay, so it's 5. Again, let me just write it here. 5,536 pi divided by 27, right? This whole thing is also divided by the volume of the sphere. Remember the fact that it was this number, so it's going to be 2048 divided by what? Divided by 3. Then this was what? Remember, it was pi, so this is going to be pi, right? Punch this into the calculator, you're going to get your answer as being what? As being 8 divided by 27. Therefore, your answer is going to be 0,3. And I'm just going to highlight the final answer. So therefore, this will be your final answer for this question. So now we're going to do questions that don't need the helper function, meaning the actual question is in terms of one variable when you find like the actual equation that you need to differentiate, right? So I'm going to do the first example, right? It says, given that f of x is equals to x cubed. So let me just change my pen. It says, given that f of x is equals to x squared, right? Determine the minimum distance between the point 10 is to 12 and the point on f, right? So here, what we need to do is remember the fact that the distance formula, right? The distance formula is equals to what? Is equals to the following, is the square root, right, of what? Of x1 minus x2 minus x1 all squared, plus then you're going to say y2 minus y1, right? Then this is going to be all squared, right? So now to basically find the distance and minimize it, we're going to find the time, right? We need to find first the distance formula, but you see the fact that we need 2 points, right? So this is going to be your first point. So this is going to be point number 1. Then point number 2 is going to be what? Any point. So point 2, right? So point 2 is going to be any point, right? So it's going to be any point, because they say a point on F, so it's going to be any point on F, right? So that means the fact that any point, it means the fact that it can be x is to y, right? Because it's any point in general. But the nice thing is that they gave us f of x, right? And we are given f of x as being equals to what? To x squared. So this f of x can be also written as y is equals to x squared. So now any point, because remember the fact that we want everything to be in terms of one thing, right? It needs to be either in terms of y or in terms of x, right? So now I'm going to change this x at this y into being x squared, right? So this f can be replaced as being what? As being x is to x squared. So now you're going to have 2 points, right? So you're going to have 2 points. So we're going to have 2 points, right? So we're going to have 2 points. And those 2 points is going to be 10 is to 2. And the other one is going to be x is to x squared, right? I hope that makes sense. So now we can use the distance formula to basically solve the distance and minimize it, right? So that's what we're going to do. So I'm just going to say here, the distance, and I'm going to call it d, is going to be equals to what? To the square root, right? Then I'm going to substitute here. So when I substitute, it's going to be what? This I'm going to call it 1. This I'm going to call it 1. And this one I'm going to call it 2, right? So x2 is going to be this x, so it's going to be x minus what? Minus 10 all squared, right? Then this is going to be plus y, then y is x squared, right? Minus 2, right? Then this is going to be all squared, and this is going to be part of the square root, right? So since we don't know how to differentiate inside the square root, I'm going to get rid of the square root right now. So I'm going to say this is d squared if I square both sides, this other side, the square root is going to cancel out. So you're going to have the following. It's going to be x. There's going to be 10 all squared. Plus it's going to be x squared minus 2 all squared. This is a tip for always, right? If you're going to have to minimize the distance because it's inside a square root, always square it, right? This is the case of always square it because you don't know how to differentiate when everything is inside the square root, right? So you're always going to differentiate what you call this. You're always going to square root it, right? So with that said, right, now let's expand this so we can differentiate it. So it's going to be d squared is equals to the following. So this one is going to be what? When you expand this one, right? So I'm just going to clean up the expansion. I'm not going to show how to expand because expanding is easy, right? So you're going to have the following as being x to the power of 4, right? Minus 3x squared, right? Then this is going to be minus 20x. Then this is going to be plus 104, right? So now we're going to differentiate it because we need to look for d prime squared at x is equals to 0. In our case, that's going to be d squared prime, right? Which is going to give us 1, which is going to give us 4x cubed, right? Minus 6x, right? Then minus 20, right? Then this is going to be equals to 0, right? Then this is going to be 4x cubed minus 6x minus 20, right? Then what we need to do is we need to solve for x, right? We see the fact that this is to the power 3. Then we need to use what? We need to factorize it, right? So I'm going to use this method here. We need to find the factor. Then we need to find the following terms, right? So first we need to take this 20 and find the factors of 20. So the factors of 20 is 1 multiplied by 20, right? This is going to be plus or minus, right? Then the other one is going to be 2 multiplied by 10. It's going to be plus or minus, right? Then this is going to be 5 multiplied by 4, which is going to be plus or minus, right? Then we're going to check which factors when you substitute here, you get 0. You find the fact that that factor is 2. If you punch in 2 here, if you substitute where you see x and put 2, you're going to get this whole term as being equals to 0. So your factor here is going to be 2, right? We did this way, we did solve for x. So that is why I'm moving fast in terms of finding the factor. Then this is going to be 4. It's going to be negative. This, since we don't have, do you see the fact that here we don't have what? We don't have x to the power 2, right? So this is going to be 0 there. Then this is going to be what? This is going to be negative 6, right? And here we're going to have negative 20. I hope it makes sense why here it's 0. It's because of this needs to be in terms of ax cubed, right? Then this needs to be bx squared, then minus the plus c x, then plus d. We do not have this b, so b here is going to be 0. I hope that makes sense, right? So if we don't have a term and you have to factorize it, remember that term that you don't have is equals to 0. I hope I've clarified that. So now first thing that we need to do is drop this 4. So it's going to be 4 here. There's going to be 4 multiplied by 2, which is going to give you 8. Then you're going to add them. So you're going to get 0 plus 8, which is going to get positive 8. Then it's going to be what? It's going to be 6. It's going to be 8 multiplied by 2, which is going to give you what? Positive 16. Then you're going to add them. Negative 6 plus 16 is going to give you 10. Then you're going to say 10 multiplied by 2, which is going to give you positive 20. Then you're going to add them. This is going to give you 0, right? So this thing, when you factorize it, it's going to be 0 is equals to, that's going to be x minus 2 because here it's positive. So when you write it back, it's going to be negative. Then here it's going to be 4x squared, right? Then it's going to be plus 8x. Then it's going to be plus 10, right? So now we need to factorize this part, right? So when we factorize that part, we're going to find the fact that it's undefined, right? And what are we going to use for to check the fact that it's undefined? So it's going to be undefined, right? And how do you use it? You can use the quadratic formula or you can use this delta, right? To check whether there is real roots or not, right? If we get a negative number, so if we get a negative number here, right? After substituting A, B, and C, if we get a negative number, right, then it's undefined. So if we get a negative number, it's going to result to be undefined. Hope that makes sense, right? So now let's do that just to check whether it's undefined. So it's going to be A is going to be equals to 4, B is equals to 8, then C is equals to 10. So delta is going to be equals to 8 squared minus 4. Then this is going to be 4. Then this is going to be 10, right? So delta is going to be equals to 96. Negative 96, which is negative. Therefore, we know the fact that that is going to be undefined, right? So our answer here, our only answer here is going to be what? Is going to be, let me just go here. So remember the fact that it's undefined, and we had, let me just rewrite it here. We had 0, right, is equals to what? Is equals to x minus 2. Then it's going to be what? It was 4x squared. So it was 4x squared, right, plus 8x. Then it was plus 10. And we know the fact that this one is undefined. So since it's undefined, our only answer is going to be x is equals to 2, right? So remember the fact that we're looking for the minimum distance. So we need to substitute this 2 back here, right? We need to substitute it back here. Then after substituting back here, we're going to find what? We're going to square root it to find the distance. So we're going to substitute x equals to 2 into what? Into d squared. Right, remember that d squared is equals to what? Is equals to, after simplifying it, it was x to the power of 4 minus 3. Then this is going to be x squared minus 20 x. Then this is going to be plus 104, right? Substitute what? We substitute into d squared, so it's going to be 2 to the power of 4 minus 3. Then this is going to be 2 whole squared minus what? Minus, so this is going to be minus 20 all squared. And this is going to be plus 104. Pass that into the calculator. You're going to get your answer as being what? 68, right? Remember, we're not looking for the distance squared. We're looking for the distance. So it's going to be, distance is going to be equal to the square root of 68. We're just going to give us what? We're just going to give us 8, 2, 5. And you are done with this question. So now let's do example 2, right? Example 2 is similar to example 1, but here is in like a situation point of view, right? So it says an area view of a stretch of the road is shown in the diagram below, right? So this is the diagram. It says the road can be described as the function. So the road is described as this function. So let's just highlight this function, and they tell us the fact that when x is greater than or equals to 0, so meaning the road is in the positive x's only, right? It says if the coordinate, right? So they say if the coordinate x's dotted line are chosen as the diagram. So this is going to be what? The xx, the y-axis, right? But Benny sits at a vantage point, right? At B. So Benny sits here, as you can see, right? And observes a car at point P. So it observes the car at point P traveling along the road. Remember that the road is in terms of this function, right? They say calculate the distance, right, between Benny and the car when it's the closest to the car. So what we need to do is that we need to calculate this distance between this point here and this point here, right? So the car is at point P, and we need to find the distance between Benny and the car, right? And the point at Benny is going to be what? It's going to be x is to y, but we already know that y is in terms of this function. So this is the same as having this point as being x is to x squared plus 2. Do you see the fact that it's exactly what we have done here? This equation is exactly like that, but here is in terms of situation. So we're looking for the distance between those two, right? So now let's find the distance, and we need to calculate the distance between Benny and the car and the car is closest to 20. So we need looking for the lowest, right? We're looking for the minimum distance, basically. Yeah, we're looking for the minimum distance. That's what we're looking for between the car and Benny. I hope that makes sense, right? So now let's just answer the question, right? With everything that we know. Remember the fact that we're going to find the distance formula, then we're going to minimize it, right? So I'm going to find the distance, right? So we know the fact that the distance is equals to the square root, right? The square root, then it's going to be what? It's going to be x, right? So it's going to be x 2 minus x1 all squared plus y2 minus y1 all squared. I said the fact that every time we're finding the distance, just find the distance squared, right? So that's what we're going to do. So this is the same as finding x2 minus x1 all squared without the square root. So it's going to be y2 minus y1 all squared, right? So this one is going to be 2 and this one is going to be 1, right? So let's substitute. So d squared is going to be equals to the following. It's going to be equals to what? This is going to be, remember the fact that x2 is what? It's just x, then minus what? Minus, or what you call this? Minus x1, which is going to be 0. No, this is what I mean. This is going to be 1. Benny is going to be 1. Then the car is going to be 2, right? So this is going to be 0. Then this is going to be all squared. Plus here, we're going to have what? We're going to have y2. Remember that y2 is x squared plus 2, right? Minus y1, right? Which is 3. So it's going to be 3. And this is going to be all squared. So d squared is going to be equals to what? This is going to give us x squared. Then this is going to be plus what? Plus is going to be x squared minus what? Minus 1. Then this is going to be all squared, right? So what we're going to do is we're going to expand this. So it's going to be d squared is going to be equals to x squared, right? Then this is going to be plus x to the power 4, right? So it's going to be x to the power 4. Then this is going to be minus 2x squared. Then it's going to be plus 1, right? Then now we're just going to group like terms. So it's going to be d squared is equals to what? It's equals to x to the power 4, right? That's going to be minus what? Minus x squared. That's going to be plus 1, right? So now that's what we have so far, right? So, but remember the fact that we need to find the minimum because the closest distance, it needs the minimum distance. So we're going to find d2 squared all prime, right? But we're going to look when d2 squared all prime is equals to 0. So that's what we're looking for. So when we do that, it's going to be 4x cubed, right? Minus what? Minus 2x, then it's going to be 0, this one, right? So this is going to be equals to 0. Is equals to what? It's equals to, we're going to take out what? We're going to take out 2x as a common factor. So it's going to be 2x, open bracket, you're going to have 2x squared, right? So it's going to be 2x squared minus 1, right? So this is the same as having 2x is equals to 0, or as having 2x squared minus 1 is equals to 0. So here we're going to have what? We're going to have x is equals to 0, and here we're going to take out the 1 to the other side. So it's going to be 2x squared is equals to 1. That's going to be x squared is equals to 1 over 2. So x is going to be equals to plus or minus 1 divided by root 2. But remember the fact that they did specify the fact that x needs to be on the positive. So the root, it can be only on the positive. So x here is going to be equals to positive 1 over root 2, right? So now we need to what? We need to pick which one gives us the minimum between these two. Which one is going to give us the minimum, right? So since we don't know, remember the fact that our original function is this one, right? It's going to be this one, right? Before we differentiate it. We don't know how x to the power 4 looks. We don't know that, right? So we need to basically check it out using the rule that we talked about, using this. Let's just go back. I just want to show you using this situation, right? Where we find the second derivative and we substitute the two values to check when it's local minimum and local maximum, right? So that's what we're going to do. Let me just go back to the question. Okay. So, yes. So we're going to go back to the question, right? Remember the fact that we have the following, right? We have that our distance squared, right, is equals to what? We have our distance squared as being equals to the following. It's x to the power. Okay, this is the squared without differentiating it. X to the power of 4, right? Minus x squared, right? Plus 1, right? And we, after differentiating it, we got the following. Remember, we got the following as being 4 x to the power 3, right? Then it was minus 2 x, right? So that's what we got. And we got that our x is equals to 0, right? And we got that x is equals to positive 1 root 2, right? That's what we got, right? Now we need to pick which one between the two x values gives us the minimum. Because closest, remember, means what? Means minimum. We need to check which one of those, right? So since we don't know how the shape of x to the power 4 looks, is that we're going to use that rule, right? So we're going to find d all squared double prime, right? So that's what we're going to do. So let's do that. So when we find that, we're going to find d double prime. So you're going to get 12x squared, right? So that's going to be minus 2, right? Then we're going to substitute here. So for d squared double prime, we're going to substitute what? We're going to substitute 0 first and check what value do we get. If we get a positive, right, then that is the local minimum. If we get a negative, then that is going to be the local maximum. Remember, the rule says the fact that if I get, I'm just going to do it with reference to this, right, of a, if I get it to be greater than 0, then this gives us the local max, right, then no, local minimum, right, and if I substitute this, right, and I get less than 0, meaning this is going to give me the local max, right? So I'm looking for a positive answer so that I can get the local minimum, right? So if I do that, if I substitute 0, so it's going to be 12, then it's going to be 0 all squared minus 2. I'm going to get my answer to be negative 2. This gives us the, since it's negative, right? This is when it is positive, and this is when it's negative. Since this is negative, it's going to give us the local maximum, right? And this is not what we want. But if I substitute, right, d2 of double prime at 1 over root 3, right? So it's going to be 12, open bracket, root 2, sorry. So it's going to be 1 divided by root 2, all squared, minus 2. Paste that into the calculator. So it's going to be 12, right, open bracket. It's going to be 1 divided by root 2, right? Then all squared minus 2. I'm going to get a positive. I'm going to get a positive 4, right? Meaning this is going to be the local minimum, right? So now we know the fact that our answer is at what? It's at this point. And I'm just going to highlight that point, right? Our answer is here at this point, right? Because of when we find the second derivative, I'm going to get what? I'm going to get a local minimum, right? So I'm going to take this point and substitute it back where? I'm going to substitute it back here, right? To find our closest distance. So let's do that. So it's going to be d2 is equals to what? Is equals to 1 divided by root 2 to the power of 4 minus what? Minus 1 divided by root 2 to the power 2 plus 1. Paste that into the calculator. I'm going to get it to be 3 divided by 4. But remember the fact that I'm looking for what? I am looking for the distance not squared, right? So d is going to be equals to the square root of 3 divided by 4, which is going to give us what? Root 3 divided by 4, which is the same as what? 0.87. And that's how you would solve this question. So now let's do example 3, right? It says, O is the center to the semicircle passing through A, B, C. and d, and the radius of it is what? Is x minus x squared units, right? So they tell us that the radius is x squared minus x squared, right? Then they tell us the fact that the triangle AOB is a right angle triangle, as we see. Then now it says what? It says show that the area of the shaded part is given as this, right? So we need to find the area of this portion. And I'm just going to highlight that portion, right? So they want us, the shaded part is this portion here, right? We need to find the area of this portion here. So that's the area that we need to look for, right? So it's going to be the area of this portion, right? So since we can't just directly find that area of that portion, we need to find first the area of this whole thing. And I'm just going to do it with another color. This area of this portion here, right? This quarter circle, this whole thing, right? Then what we're going to do is we're going to subtract this portion here. So I'm going to have to subtract this right angle triangle, right, from it. So I'm going to have to subtract this right angle triangle from it to find the area of what? Of the yellow portion. So I have to find the area of the blue part, which is the entire thing. Then subtract the green to find the yellow. I hope that makes sense, right? So let's do that, right? So I'm going to take my pen, right? And I'm going to say 10.2.1, right? So we know the following, right? We know that the area of the shaded area, the shaded region, right? So the shaded region, from what I just said, for this shaded region, right, is equal to the following, is equals to the area of the segment. The segment, right, is the whole blue part, right? So it's going to be the area of the blue. I'm just going to call it the area of blue, right, minus the area of green. Area of green, right, green. So now let's find the area of the blue, right? So the area of the blue, which is the segment, right? So the area of the segment, which is the area of the what? Of the blue thing, right? Is equals to a quarter of a circle. So this is equals to, right, 1/4 area of the big circle, which makes sense, right? So it's going to be equals to 1/4 area of big circle. We already know what's the area of the big circle, right? Area of a big circle is pi r squared. So this is the same as what? 1/4 is equals to pi r squared. Substitute your radius by what? By this. So it's going to be equals to 1/4 pi. Then it's going to be what? It's going to be x minus x squared all squared, right? So that is going to be the area of the blue part, right? Then now we need to find the area, right, of the green part, right? Which is the area of the what? Of the triangle. Right? So the area of the triangle is going to be equals to what? To 1/2, because this is a right angle triangle, right? It's going to be 1/2 breadth times height. Do you see the fact that the breadth and the height, so this is going to be the height, and the breadth, they are both radius, right? Both B and H are radius. And we already know what is our radius, right? Our radius is that, so that is going to be equals to what? It's going to be equals to 1/2. Then it's going to be what? X minus x squared all, right? So then the other one is going to be x minus x squared, which is the same as 1/2. Then it's going to be what? X minus x squared all squared, right? So that is going to be the area of the triangle, right? So now we take that area of shaded region, right, is equals to what? It's going to be equals to this whole segment. So it's going to be 1/4 pi, right? And then open bracket, x minus x squared, right? Then all squared minus what? 1/2. That's going to be x minus x squared all squared, right? So first what we're going to do is that since we have x minus x squared all squared as being a common factor, I can add 1 over 4 and negative 1 over 2. So that's going to give me what? That's going to give me pi, right? Minus 2 divided by what? Divided by 4, right? And this is going to be equals to 1 to x minus x squared all squared, right? So now let's expand that. So it's going to be pi minus 2 divided by 4. Then when we expand that, it's going to give us x to the power 4, which is exactly this, right? Minus what? Minus 2x cubed, right? Then it's going to be plus x squared, right? So this is what we're going to have, right? So which answers this question, right? So going to the next page, it says determine the value of x, right? Right, for which the shaded area will be maximum. So we need to find the first derivative of this area. So let's do that. So I'm just going to call it area of x is equals to, rewrite that. So it's going to be pi minus 2 divided by 4, then multiplied by x to the power 4 minus 2x cubed, right, plus x to the all squared, right? We're looking for the first derivative because we're looking for the maximum. So it's going to be the first derivative, right? Then it's going to be what? I'm not going to distribute this pi over 4. I'm just going to differentiate this, right? So it's going to be pi minus 2 divided by 4. Then I'm going to differentiate this ones. So it's going to be what? It's going to give us what? It's going to give us 4x to the power 3 minus 6x. Then it's going to be plus 2x, right? Then now what we're going to do is we're solving for when this is equals to 0, remember? So when the first derivative of the shaded area is equals to 0, it's going to be 0 is equals to pi minus 2 divided by 4. Then here we're going to have 4x cubed minus 6, this is squared, x squared plus 2, right? So this, since it's a number, then this is all inside a bracket. Since this is a number, when we divide it with here with 0, so we're still going to get 0 is equals to 4x cubed minus 6x squared plus, this is x, this is going to be plus 2x, right? So now, since every term has x, I can take out x as a common factor. So I'm going to say 0 is equals to what? 2x, open bracket. I'm going to have the following. So I can take out actually 2x. So it's going to be 2x, open bracket. I'm going to have 2x squared minus 3, right? X. Then we're going to have plus 2. So I can factorize this. So it's going to be 0 is equals to 2x. Open bracket, I'm going to have the following. It's going to be 2x minus 1. Then we're going to have x minus 1, right? So x is going to be equals to 0, right? Or x is going to be equals to what? 2 positive 1 over 2, right? Or x is going to be equals to negative 1, right? So now remember the fact that we're looking for the x value when it's maximum, right? So since you remember the fact that our original function, which is this one, is in terms of x to the power 4. Do you see that, right? I don't know where is it maximum. So I'm going to use the rule of finding the second derivative and substituting 0, 1, and negative 1 to check where it is, right? So let's do that. So let's find the second derivative. So finding the second derivative, I'm going to say, I'm just going to do it here. I'm going to say a of the double prime of x is going to be equals to what? It's going to equals to, from here, it's going to be equals to 12 x squared, right? That's going to be minus 12, right? X. That's going to be plus 2, right? So this is going to be this whole thing. Remember the fact that it's multiplied by 2 minus 2 divided by 4, right? So now I'm going to substitute what? I'm going to substitute when it's equals to 0, right? So when you substitute when it's equals to 0, so it's going to be 0 here, then it's going to be 0 here, plus 2, then here it's going to be pi minus 2 divided by 4, right? So when you punch that into the calculator, right, you're going to have the following. So you're going to say 12, open bracket, 12, right, open is going to be 0 all squared minus 12, right, and it's going to be 0, that's going to be plus 2, right? Then this whole thing is divided by what? By pi, right? Minus 2 then divided by 4. So your answer here is going to be what? It's going to be equals to 0.57. Right? Remember the fact that we're looking for the local maximum, right? And remember the fact that maximum is when this, right? I'm just going to say A is greater than 0. This is going to give us the what? The local. This is going to give us the local minimum, right? When it's positive, and it gives us the local maximum when it's negative. So this gives us the local. This gives us the local maximum. So since this is positive, it's going to give us local minimum, which is not what we want, right? So this is not our answer. So now let's do it when A is equals to 1/2. So I'm just going to substitute it here, right? You're going to do the same thing. Now, instead of 0, you're going to have 2, right? So let me just do that.
You put the thing building to light going and then.
So we're going to substitute 2. So it's going to be 2. You're going to get your answer as being what? As being. So when we substitute 2, we're going to get our answer as being. Let me just do something. This is going to be 2 to the power. Let me just check something. I feel like I made a slight mistake. This is going to be 2. Here it's going to be 2. Minus. So it's going to be. But yes. So it's going to be 2 multiplied by 12 all squared. And this is going to be 2 also, right? Here it's going to be 2 negative 2. Then it's going to be plus 2. So you're going to get your values as being. Let me just do it again. So this is going to be 12. Right? So it's going to be 2 all squared, right? Minus 12. Then it's going to be 2. Then it's going to be plus 7, right? Which is going to give you what? Oh, not 2. It's going to be a half. And we made a mistake. So it's going to be, now we're going to substitute when using a half. So it's going to be 12, open bracket is going to be, so whenever you see 0, you're going to substitute a half. So it's going to be a half all squared, right? Then it's going to be minus, then it's going to be 12, then it's going to be a half, right? Then that's going to be all, and that's going to be just not all squared, plus 2, right? Then multiply by this master value, which is pi minus 2 divided by 4. Then you're going to get your answer as being what? As being negative. Negative 2,285, right? So since this is negative, that means it's going to give us our local maximum, right? Since I already found my local maximum, I can just conclude definitely this one is going to be the local minimum, right? Therefore, I can conclude that x is equals to what? Is equals to 1/2. So that is going to be your x value. So that's how you would solve for this question. So now we're going to do motion questions, right? So motion questions is questions that involve displacement, velocity, and acceleration. So we need to understand the relationship between displacement, velocity, and acceleration. Displacement is also known as distance, right? So if we have, let me just change my color. If we have displacement, right? So displacement, right? So displacement as being equals to is, so the distance in terms of time, right? Then how do we find our velocity? So our velocity from displacement is going to be equals to the following. It's going to be equals to, I'm going to name velocity, v is to time, is going to be equals to the first derivative of what? Of displacement. So your first derivative of the distance, right? Then now acceleration, right? So acceleration is going to be equals to what? It's going to be equals to a. I'm going to name it like this. And that is basically what? That's going to be the second derivative, right, of the displacement. And also you can calculate it. You can calculate it finding the first derivative of what? Of velocity. I hope that made sense, right? So that is the relationship between the three, right? Is that if you have your displacement to find your velocity, you find the first derivative. If you have your velocity and you want your acceleration, you can find it using the first derivative. Or if you have your displacement, you can find it using the second second differentiation, right? So with that said, we can do a question that relates everything that we just said, right? So it says the height, right? So it says, let me just highlight. It tells us the fact that the height is in meters of a golf ball is t seconds after it has been hit into the air. It's given as this, right? So this is the height of the golf ball when you hit it, right? Into the air. Then they say determine the following. So this is the questions that we're going to answer, right? So in our case, our displacement here is going to be our height. So in this question, the displacement is height, right? So this is actually our displacement. Displacement, right? So the first question says what? It says calculate. We need to determine the following. The average velocity, the average vertical velocity of the ball during the first 2 seconds, right? So we need to find the average distance during the first 2 seconds. So meaning the first second it was at t0, so number 1 here, right? So the first second is at t0 and the second one is at t2, right? The first 2 seconds. So the initial and the one that they want, which is 2 seconds, right? So what is average velocity? So average, I'm just going to say average here. It's going to be equals to what? It's going to be equals to the height at 0, right? The final position minus the initial, which is t at 0, right? And that is going to be divided by what? Divided by 2 minus what? 2 minus 0. So that's what we're going to do. It's the same as when we were doing functions, how we found the average gradient, average velocity. In our case, if you find the first derivative, remember the fact that here the first derivative is what? Is actually the first derivative is actually the velocity. So here, that's the same relationship, is that this it represents more or less like the average gradient, because the first derivative in this case is actually velocity. I hope that makes sense, right? So first what we need to do is we need to find h at 2, right? So if we look at h at 2, it's going to be equals to what? Is equals to 20, open bracket. It's going to be 2 minus 5, 2 all squared. When you pass that into the calculator, you're going to get 20, right? Then h at 0 is going to be 20, open bracket 0, then minus 5, then it's going to be 0 whole squared, which is going to give us 0, right? So substitute it here. So it's going to be 20 minus 0 divided by 2 minus 0, which is going to give us, when you pass this into the calculator, you're going to get your average velocity as being 10 meters per second squared, right? So that's how you're going to find the first question, right? So now let's do the second one, which is going to be here. It says calculate, we need to determine the, what you call is the vertical velocity of the ball at t 1,5, right? Remember the fact that this is displacement. First, we need to find velocity. How do we find velocity? Remember that velocity is basically equals to the first derivative of the height, which is, I said that height is the displacement. So that's what we're going to do. So we're going to find the first derivative of the height, which is going to give us 20 minus what? 20 minus 10t, right? So that is going to be what? That is going to be our velocity. So velocity here is basically equals to this, which is going to be 20 minus 10t, right? So we're looking at velocity at 1,5 seconds, right? So we're going to substitute it there. So it's going to be 10 open bracket 1,5. Then pass that into the calculator. You're going to get your velocity to being what? To being 5 meters per second squared, right? So that is going to be your velocity, right? And then number 3, it says the following. It says determine the following: the time at which the vertical velocity is equals to 0. So now we're looking for number 3. We're looking for when velocity is equals to 0, right? So we've already determined what is our velocity. So it's going to be 20 minus 10t is equals to 0. So we're solving for the time. So we're solving for t. So it's going to be 20 is equals to what? Is equals to 10t, right? Divide both that by 10. So your velocity is your time, your time is going to be equals to 2 seconds, right? So when velocity is equals to what? 0, then the time is equals to 2 seconds, right? So now it says the vertical velocity at which the ball hits the ground. What does it mean to hit the ground? So number 4, what does it mean that to hit the ground? To hit the ground meaning the fact that your h is equals to what? Your h is equals to 0. So we know the fact that the time at which it hits the ground, it's when they said the vertical, calculate the vertical velocity at which the ball hits the ground, right? When does that happen? I said it happens when your height is equals to 0. That's what I wanted to say. When your height is equals to 0. So first what we're going to do is that we need to solve for the time when the height is equals to 0. Then substitute that time back into the velocity to find the velocity, because that's what they want, right? So it's going to be equals to what? Remember the fact that the height is 20, right? T minus 5 t squared is equals to 0. We're solving for t first, right? So we can take out what? We can take out 5t as a common factor. So it's going to be 5t, right? Open bracket, we're going to have the following. We're going to have 4 minus t, right? Then this is going to be equals to 0. This is the same as 5t is equals to 0, or 4 minus t is equals to 0. Take the t to the other side, so it's the same as 4 equals to t. Where this side is the same as t is equals to 0. Then this side is the same as t is equals to. So now we're going to substitute t, which is t equals to 4 into the velocity to find what? To find the velocity where it hits the ground. So that's what we're going to do. We're going to find the velocity at 4 is equals to what? Is equals to. Then you're going to say, remember that the formula for velocity is this one. Is going to be 20 minus 10, open bracket, is going to be 4. Then this is going to be what? This is going to be equals to the following. So it's going to be 20 minus, which is going to give us negative 20 meters per second, right? Meters per second squared. So this is going to be the velocity where the ball hits the ground, right? The reason why we didn't use t at 0, remember the fact that the height of the ball is at 0 2 position. It's when it starts, right, at the initial position and at the end of the position. So t at 0 is at the initial position where the ball haven't even hit the ball, right? I hope that makes sense why we didn't use t is equals to 0, but we used t is equals to 4, right? So remember the fact that the graph it looks like this, right? So this is at t0, this is before hitting the ball, right? This is when the height is going to be equals to 0, right? And also the height is going to be equals to 0 at the end, which is our t is going to be when t is equals to 4. So this, we can't use it. We can only use this one because of the looking for after you've hit the ball and it has landed. I hope that makes sense, right? So now let's do the last part of the question, right? So now let's do the last part. It says, what is the acceleration of the ball? Acceleration of the ball is when we're looking for h double prime. Remember, h double prime gives us the acceleration. So let's do that. So we know already the first derivative of h is equals to this one, right? So now we're going to find h double prime. So it's going to be h double prime, right? Then from here, it's going to be, the 20 is going to be 0, right? Then negative 10. So it's going to be negative 10, right? Because, yeah, negative 10. Then this is going to give us 1. So our h double prime is going to be equals to negative 10. Therefore, our acceleration is going to be equals to negative 10 meters per square, right? This is not meters per square. It's just meters per, not per square. And we just erase this to the power negative 1 here. Made a mistake. So this is to the power negative 1, right? Also here, made a mistake. Acceleration is 2 is squared. Acceleration is the one that has the squared. So let me just erase this one just to clean it up, right? So this will be your final answer for acceleration. So this is how you find acceleration, and this is number 5. So now we're going to do a question that talks about the rate of change, right? So these are the type of question that talks about the rate of change, right? So it says the number of molecules of a certain disease in the blood stream T, right, at T hours after it has been, after it has been taken into representation, that's after it has been taken, right, is represented by the equation, and they give us the equation, and they tell us the fact that our time is between 0 and 10. So the first question here, which is 10 point, let me just do it here. So 10.1, it says, determine the number of molecules of the disease in the bloodstream after 3 hours after the drug has been taken, right? So we're looking for the number of molecules. The number of molecules, remember, is represented by this function, but I'll just highlight it, right? So we're looking for when T is equals to 3 hours. So we're looking for when T is equals to 3. So the only thing that we need to do, just substitute 3 into this equation, right? Into this equation to find the number of molecules. So it's going to be M is to 3, right, is equals to negative. Then it's going to be 3 all cubed, right? Plus 3, then it's going to be 3, then this is going to be all squared, plus 72, then it's going to be 3, right? Punch that into the calculator, you're going to get 72, right? So you're going to get, not 72, you're going to get 216 molecules, right? So the number of molecules are going to be 216 molecules. So this is going to be 216 molecules, right? So now we're going to move to 10.2. It says, determine the rate, right? The rate means in prime. That's what we're going to look for, right? That's why it's called, I said this is the rate of change questions, right? So they say determine the rate at which the number of molecules of the drug in the bloodstream is changing at exactly 2 hours. So here we're looking for what? We're looking for the following. We're looking for the first derivative, because that's rate, right? Then at 2 hours. That's what we're looking for. So first, let's find the first derivative. So it's going to be m prime, right, of t is going to be equals to negative 3 t cubed, right? Then it's going to be plus what? Plus 6, right? T, then it's going to be plus 72, right? Then we're looking at the rate of change after 2 hours, at 2 hours, right? So it's going to be this 2 is equals to negative 3, open bracket 2, then this is squared. Sorry about that. This is squared because we have differentiated. So this is going to be squared. So this is going to be squared, right? And this is going to be plus 6. Then this is going to be 2. Then it's going to be plus 72, right? Punch that into the calculator. You're going to get your answer as being the following at 72. So it's going to be 72 molecules, right, per hour. So that's how you would answer this question, right? 10.3, it says, let me just take my highlighter, right? It says, how many hours after taking the drug will the rate of change at which the number of molecules of the drug in the bloodstream changing being maximum, right? So what they want here is that they want when the rate of change. So now we're taking as the rate of change as being the actual function, right? So we know the fact that we're taking the rate of change, and remember the rate of change was what? The rate of change is m prime, right? As being what? As being the actual function, right? We're looking for the maximum of the rate of change. So we're looking for, so 10.3, we're looking for the maximum of the rate of change, right? But we're looking for the maximum of the rate of the change, but we're looking for the amount of hours. Remember that hours means time, right? So we're looking for the maximum of the rate of change, right? And remember that rate of change is what? It's m time, which because the actual function is the first derivative, right? So if we're looking for the maximum of the rate of change, do you see the fact that we're actually looking for double prime of t is equals to 0? This represents the maximum of the rate of change. I hope that makes sense, right? So now we need to find the second derivative. So it's going to be m double prime at t is going to be equals to what? We already know the first derivative. So it's going to be the second derivative is going to be equals to negative 6t, right? Plus 6. Remember the fact that this is equated to 0. So it's going to be negative 6t plus 6. Take the 6t to the other side. So it's going to be 6t is equals to 6. Divide both sides by see, by 6, so it's going to be T is equals to 1. So the amount of hours is going to take us 1 hour, right? So the maximum, so therefore we know the fact that the maximum rate of change, right, so the rate of change of the number of molecules, of the number of molecules, right, of the drug in the bloodstream right, is after 1 hour. So that will be your final answer for this question. So now let's do this question. It says water is flowing into a tank at the rate of 5 liters per, which was 5 liters per minute. So it's going to be 5 liters per minute. So it's flowing into the tank, right, at the rate of 5 liters per minute, right? At the same time, it's flowing out. So at the same time, it's flowing out of the tank at k liters per minute, right? It says the volume in liters of the water in the tank at time t is in minutes, right? Then they give us the formula of the volume in terms of this function, right? So the first question says what? It says, what is the initial volume? What is the initial volume of the water in the tank, right? So the initial volume happens when t is equals to 0, right? So for 11.1, the initial volume happens when t is equals to 0. So we're basically going to calculate the volume when t is equals to 0. So it's going to be V of 0 is equals to 100, then minus 4, then it's going to be 0. So the initial volume is actually 100 liters, right? So that's going to be our initial volume, right? Then 11.2, it says write down 2 different expressions from which the rate of change of volume in the water. Remember the fact that here we have 2 types of rate of change, right? We have it when it's going in, right? See the rate of change when the water is coming in and the water flowing out, right? So it's 2 of them, right? So we need to write down 2 expressions. So the first expression is expressing it with water coming in and water coming out. So it's going to be rate in, right? So it's going to be rate in, right? So that's when water is coming in, which is, we know the fact that is 5 liters, minus the rate of going out. So the rate out, right? Which is going to be equals to k liters. And this is going to be represented as saying what? As saying 5, which is the number of liters going in, minus k, right? And this is going to be liters per minute, right? So that's the rate, right? So that's the first one. The second one is the one that we know where we need to differentiate the volume, right? So another way to express the rate of change of volume is saying that the first derivative of what? Of t, which is going to be equals to what? In our case, it's just going to be equals to -4. So these are the 2 ways, right, of expressing the rate of change. And this is going to be liters per minute. I hope that made sense, right? So now it says determine the value, and one more thing, this and this are the same thing. It's just expressed in different ways, right? So it says determine the value of k, that is the rate at which the water is flowing out, right? So since we know the fact that these 2 are equal, so I'm going to say 11.3. Since we know the fact that the rate in minus the rate out is the same as the first derivative, right? Is that we're going to equate them together. So it's going to be rate in minus the rate out, right? It's basically equals to V prime, right? We already know what this is. It's going to be 5 minus k is equals to this one, which is -4, right? Then now we can basically solve for k, take the 5 to the other side. So it's going to be -k is equals to -4, -5 is going to give us -9. So therefore k is equals to 9. What? It's going to be equals to 9 liters, right, per minute. And that's how you would solve for k. And this is going to be the final question, and this is going to be the answer for how to answer this question.